2024. Good morning, ladies and gentlemen. Welcome back to IDWS Conference 2024. I remain Adrian Hayes. I am your MC, host, compere, facilitator, and all-round nice guy for today and tomorrow. I'm not very good, but I am the best in my price range. So, I hope you all had a marvelous, entertaining, and enlightening and informative day yesterday. Some very interesting perspectives came up. And also, for those who went to the museum last night, I hope you had a very enjoyable time. And I've lived in the Middle East for many years, and I know the rich culture of this region. I even rode a camel across the empty quarter for 44 days, the Rub al Khali. So I've seen it, but it's fascinating when you go to a museum like last night, seeing how much rich history and culture there is in the region. And I think it's fantastic what the kingdom is doing, apart from innovating and leadership on technologies, what they are doing to promoting tourism in the region. So, with that, we have a packed day of presentations, keynotes, panel discussions, and such like, getting into the meat of this conference. And to start the proceedings today, I'd like to invite Engineer Tariq Al-Gaddafi, Vice President for Water Research, to give a keynote speech. Tariq.
Good morning, everyone. I'm very pleased to be here and to see all of you in this prestigious event. I think we've learned a lot through the first day, and for those who have visited the Oasis Park it will be one of the biggest worldwide for the water R&D, and then for the people as well who enjoyed the museum and the cultural event that we had put together. So, for me today, I'm not going to take much of your time, but we want to give some insights of what we think as leaders in the kingdom in here, especially when we look into the water sector. So let me go back a little bit in perspective. We have, in our planet, is full of water. So if we narrow that down, you will see a lot of fishermen around the sea, oceans, you name it. But what they have in common is that most of these fishermen, even though the sea and the ocean is so huge, they still go to places and they never want to disclose it. Why? Because they think it's their business. It's their benefits, and they want to gain for it. So they innovate a place, or they think that this place is unique for them to get whatever that needs to be done for the business, to capitalize on it, to sell, and so on. However, the water sector should be unique, and this is my main message today. So when we look into the water sector and the business of it and how we innovate, it should not be a closed loop or a hidden agenda area. Why? Because it benefits everyone. What do I mean by that? When we look into any innovative ideas in any type of business, usually people are so secretive about it and they don't want to share it because they think one day it will boom and it will make money out of it. And don't get me wrong, you can make a lot of money out of many different technologies. But the message and the belief that we want to give should be very clear for the water, especially in a limited community that we have in the water, whether water leaders, water expertise, water specialists, professors, and so on. And I see that changing throughout the time. So my belief throughout this is to be very open. And maybe yesterday I had so many great discussions and talk with a lot of the professional people in here. And most of them, or I would say all of them, agreed in collaboration. And that's why we are all here together today, to collaborate, to enhance the collaborations and networking. Networking is a crucial part of our life. And to me, this is an important part of how we connected to our happiness. What that means is connected to your dopamine, in your head. Whenever we innovate, whenever we put an ambitious plan, whenever we scout for technologies and we achieve it, we cross it. Why do people say and most professionals, by the way, they always say, write down your ideas, write down your goals, and so on, because it's biologically connected to you. What that means, if you write it down, you are increasing the dopamine into your body. And once you increase it and you cross it, it keeps increasing on and on and on. And this is how we want the culture of innovation, especially in the water sector. For example, at Saudi Water Authority, I'm leading one of the arms that focuses on R&D, as well as in some of the innovative projects and execution, capital execution projects. When I look into them, there is always a way to enhance and innovate and to scout for technology. One thing that I consider a main achievement for this year was the ability to be able to scout for technologies in a different way than the regular one. And we did it with one of the partners that we have. What that means is we don't have to reinvent the wheels. What we're doing is we're seeing where the world is looking at, and we are trying to enhance it on and on and on, and we make sure we bring the right people and the right capability and the right infrastructure to adapt it throughout. So I hope during these 3 days, we spend it efficiently, where we can share ideas, where we can collaborate, where we can get the best and maximize the benefit out of what we think, what we feel, what we believe. Making a difference today will make a positive impact tomorrow, but making it in a sustainable way will sustain the positivity throughout the next and next generation. Thank you so much.
Thank you, Tariq Al-Ghafari, who I can tell you has been working very hard for this conference, has probably been going on 2 hours sleep per night for the last week. Is that correct? So, without further ado, we'd like to introduce the first panel discussion of the day, which is being hosted by Nada Abu Bakr, who is Director for Water for Middle East for Ricardo. Nada, would you like to come to the stage and introduce your panel? Smart Infrastructure and Asset Management, CEO Perspectives on Future-Proofing Water Systems. Thank you. Nada, if you're here, please come to the stage. Okay, can we launch Air Sea Rescue to find Nada? And we'll start. Okay, while we're waiting for Nada to come on the stage, last night's panel discussion, Neil Reynolds asked the panel, Tariq was, oh, Nada, you're here, okay, right. Okay, we'll leave that one for later. Nada, over to you to introduce your panel. Okay.
Alrighty, good morning everyone. My name is Nada Abu Bakr. I'm Middle East Director for Ricardo. Very excited to have you all joining us in our first panel session for this exciting event. So we're going to be covering a pretty important topic, and that is around how the leadership is shaping the future of water management across the water cycle. Why is this important? Well, water is a critical and essential resource for life. And as we face growing challenges with water caused by climate change, caused by population growth, aging infrastructure, and various different challenges that are posed by the rising demands of water from the multiple sectors that are utilizing water, this is now it's more important now more than ever to be discussing the future of water and how the leadership is responding to those challenges and utilizing the innovations that we have today, the exciting innovations coming out to leverage and solve these problems. So I'm very excited to be joined by an esteemed group of water leaders this morning who will share with us some of these approaches, how they're doing it today and looking into the future. And I'm just going to quickly provide an introduction to the panelists. We've got Engineer Mohammed Abu Haid, that is
to participate in this panel discussion. And from what I see, I think majority of the audience are Arabic speakers, so allow me to answer that question in Arabic.
Please go ahead.
السلام عليكم، أسعد الله صباحكم بالخير والمسرات. اليوم لو سلطنا الضوء على واقع استهلاك المياه من مصادر المياه المتاحة، لوجدنا أن القطاع الزراعي هو المستهلك الأكبر لمصادر المياه المتاحة، سواء المياه المتجددة أو الغير متجددة أو المياه السطحية والجوفية. لو عدنا ووجدنا وعرجنا على إحصائيات الاستراتيجية الوطنية للمياه وخطوط الأساس التي وضعت لعام 2016، لوجدنا القطاع الزراعي يستهلك 84% من كامل مصادر المياه المتاحة في المملكة. كافة القطاعات تستهلك ما يقارب 24 مليار متر مكعب في عام 2016. اليوم 21 مليار متر مكعب جلها في القطاع الزراعي. 90% من هذا الرقم هو من مصادر مياه غير متجددة. في ظل وجود مستهدفات طموحة لترشيد استهلاك المياه وتخفيض هذا الرقم من 21 مليار متر مكعب إلى 11 مليار، إعادة استخدام المياه المتوفرة من محطات الصرف الصحي المعالجة ورفعها من 15% في عام 2016 وصولاً إلى أكثر من 70% في عام 2030. مستهدف رفع كفاءة الري ليصل من 55% في 2016 إلى أكثر من 75% في عام 2030. وجدنا أن المؤسسة يحتم عليها العمل على اتجاهين في وضع استراتيجياتها. الجانب الأول هو الاستثمار في البنية التقنية الجديدة التي توظف الابتكار والتقنيات الحديثة في إدارة الطلب على المياه. على سبيل المثال البنية التحتية اليوم التي نعمل على إنشائها تتضمن وجود أجهزة الاستشعار التي تأخذ في الاعتبار استخدام تقنيات إنترنت الأشياء، وفي جانب التنبؤات تأخذ في الذكاء الاصطناعي وتوظفه لتحقيق ذلك. بل عملنا في أحد المشاريع لإدارة الطلب وخفض هذا الرقم من 21 مليار للوصول إلى 11 مليار، توظيف الذكاء الاصطناعي في تحليل صور الأقمار الصناعية في تقدير استهلاك القطاع الزراعي في المملكة، خاصة في ظل وجود دولة مترامية الأطراف والأنشطة الزراعية منتشرة في كل مناطق المملكة. حصر هذا الاستهلاك وتقديره وقياسه يتطلب الاستثمار في الذكاء الاصطناعي وتحليل صور الأقمار الصناعية في تقدير استهلاك كل حيازة في هذه المناطق على مدار العام، وتحديد الحيازات الزراعية التي تستهلك كميات أكبر من الكميات المخصصة لها. الجانب الثاني في الاستثمار في الذي وضعته المؤسسة ضمن استراتيجياتها هو أن تكون استراتيجياتها مرنة وتتكيف مع التغير المناخي. على سبيل المثال اليوم بعد إضافة مهام إدارة وتشغيل السدود في المملكة، وجدنا أن أهمية إدارة البيانات بشكل كامل وربط بيانات المؤسسة التشغيلية والاستجابة للطوارئ مع البيانات التي تردنا من المركز الوطني للأرصاد مهمة جدا في إدارة منظومة السدود بشكل كامل، ليس فقط كإدارة تشغيلية ولكن أيضا في الاستجابة وأخذ التنبؤات في توقعات الهطول المطري الكثيف أو فترات الجفاف التي قد تواجه المملكة في بعض الأشهر على مدار العام. نستفيد من هذه البيانات في تحديد السدود التي بالإمكان تصريف كميات المياه منها استجابة لحالة مطرية طارئة، وأيضا الاستفادة من الفوائض في تخزين كميات المياه الفائضة في المخزونات الجوفية وتنمية الموارد المائية للحصول عليها في فترات الجفاف في حال حصلت في هذا الجانب. نعتقد أنه الابتكار وتوظيف التقنيات الحديثة هو عامل ممكن في إدارة الطلب على المياه وإدارة الموارد المتاحة في المملكة، وهذا ما سنعمل عليه ونستثمر فيه.
Thank you, Engineer Mohammed Abu Haid. That was a great insight, a holistic view of how the management of water from the agricultural and SIO perspective and the utilization of the smart technologies to tackle that. So thank you for that. I want to jump across to the UK, Bob, if I may. Very keen to understand how is the UK water sector responding to the challenges that we've discussed around population growth, climate change, and environmental sustainability.
Hello, everyone. Good morning. It's a pleasure to be here. Salam alaikum. Sorry, my Arabic is not good enough to speak in this way, even though I spent 5 years in this region. But it's a pleasure to be here, and I would like to thank the organizers of the conference for inviting me here today. I'm going to tell you a little story about the UK. Well, it's quite a long story, actually. But the first thing I want to say about the UK's situation is that everybody thinks it rains a lot in the UK. And that's true. I was talking to some people this morning who are linked with Manchester University. Manchester is one of those cities where it always seems to rain. In Wales, it always seems to rain, where I'm from. But actually, in the UK, there are very big differences between levels of rainfall around the country. And that is leading to challenges with water supply, particularly in the southeast of the UK and the eastern side of the country. And these are areas that we call water-stressed areas. So this all came into focus in 2012, when there was a long period without rainfall in the UK. There was quite a serious drought situation, and those areas with low rainfall were particularly badly affected. And just to give you an idea, the rainfall in the southeast of the UK is about 20% of the national average, and it's about the same amount of rain as they have in Jerusalem. So this is a kind of something that not a lot of people understand or know about. So what happened in 2012 is this all came into focus. And as an industry, we said to ourselves, well, what's going to happen if this continues? We're starting to feel the pressures of climate change, as well as this uneven distribution for 30 years. Why? When we have all of these problems with rainfall, well, it was government policy. Government policy was no reservoirs because they damage the environment. No reservoirs until you have reduced your leakage. No reservoirs until you can make everybody efficient in the way that they use water, the per capita consumption. But the piece of work that we did as an industry actually showed that if we carry on with this policy, then by 2050 we would run out of water in the UK. So this really made people sit up and pay attention. People started to get seriously concerned, and the government policy has changed, and now we have a kind of a catch-up program almost of about nearly 20 large infrastructure projects. These are reservoirs. There are 10 reservoirs about to be built. Mine is the first one. There are pipelines to link parts of the country together. We're even using the canal system in the UK. Those of you will know who've been to the UK will know that we have a canal system from the Victorian era which was used to move heavy goods around the country during the Industrial Revolution. This canal system is being used to move water from places in the UK where it's plentiful to where it is stressed in the southeast. So we have a major program. I think it's about £14 billion of infrastructure investment across the UK, but mainly in the southeast region, to make sure that those areas in the southeast and the east of the country have sustainable water supplies for the future. We are trying to find 5,000 megalitres a day. Those of you who are water engineers will know that that is a lot of water, 5,000 megalitres a day, to satisfy the balance between demand and supply in the future. And almost half of this 5,000 megalitres a day is because of a new philosophy about the environment. And water companies are being asked to take less water from the environment, to allow the environment to recover from over-abstraction, taking too much water. And as a result of this, we have to find new sources of water as well. So, one of the things we are doing in the Water UK is we're starting to build the first water reuse plants. So 2 or 3 companies are developing these at the moment, and I think in 10 years' time, we will start to build desalination plants. So the UK is moving from a situation where everybody thinks there's lots of rain and lots of water and no problems with the water supply, to a situation where we are going to be relying also on water reuse and desalination in the same way as this region and other regions of the world. It's a big change around story.
That's fascinating, Bob. Thank you for sharing. And I quite liked the story that you shared around how the narrative is around you're not going to have the next big infrastructure until you solve the problem that must be set by policy. So there's a nice link to infrastructure and policy that's kind of, you know, creating that kind of nice governance structure for the sector. So that's, you know, that's great to see that drive and shift in that water sector. Thank you for sharing that. I want to now jump across back to Saudi Arabia, particularly in the context of Vision 2030. We all know the impact that Vision 2030, the great impact it's had on the kingdom. Engineer Mohammed Halawani, in what ways has Vision 2030 supported the transformation for the private sector's strategic planning and operational efficiency?
Okay. Assalamu alaikum jami'an. Good morning, everyone. First, I would like to thank the conference for this great event, and really I'm proud to be here with all the audience and the colleague in the panel. For your question, Nada, I believe the vision of 2030, it was really a big change for the private sector, how they were thinking to do business in Saudi Arabia. The journey of the private sector, it started, let's call it before the vision of 2030 and before the transformation program, 2020. At that time, the private sector ambitious and all the thinking of the private sector was only how to generate profits, how to do, just to bring some trading business and to sell it to the private sector and to the government. So from my point of view, the private sector at that time, their thinking of how to do business is very limited. When the vision of 2030 came, when the national water strategy has been started to be implemented in Saudi Arabia, the private sector, they needed to adapt to the new trends of the market. They needed to find a lot of solutions, smart technologies. They needed to start innovation. You started to see some Saudi innovations hubs to start how to do optimization of the assets, how to do smart technologies. For really, I believe what happened to the private sector, it shaped our minds, how to think, how to do business in Saudi Arabia, how to deal with the international market. It's a great journey for the private sector. 10 years ago, you never hear that the private sector was thinking how to think about the decarbonization, like example. There is a lot of things happen in the past 5 to 6 years, made the private sector really to start to interact with the government, with the international market. Today, for the first time in Saudi Arabia, you can hear all the governmental entities and the private sector, they are speaking the same language. As long as you have one vision, as long as you have one target, everyone speaks the same language, everyone thinking how to optimize the assets, how to talk about the smart technologies, how to make sure you have no water losses, how to make sure you are really, in terms of cost, very optimized. And this, in the long term, even it's sometimes in the short term, it make you to invest some money, but in the short term, it will help you as a private sector and as a government. This is in general how the private sector look at these kind of things.
Thank you, Engineer Mohammed. It's always great to have that direction and shared vision that and the implication that Vision 2030 has had on the private sector. Thank you for sharing that. Now I want to jump across to a very critical asset that's around water transmission networks. Dr. Tariq and Naim, you're managing a critical asset in the kingdom, and as a water leader, how do you balance the need for immediate operational efficiency with that long-term sustainability of this critical asset?
Thank you, Nada. صباحكم الله بالخير جميعا. Good morning, everyone. It's a very important topic, and it's basically the importance comes from the fact that we need to strike a balance between achieving operational efficiency and yet ensuring the long-term sustainability of the water assets. There are many broad, I would say, approaches and operational scenarios, but in general, we focus on a couple of them. The first one, I would say, the typical kind of approaches or operational scenarios, which basically comes potentially as a recommendation from the equipment manufacturer to carry out certain activities related to the corrective, preventive, and daily routine kind of maintenance activities. And the basically main objective here is to ensure that we achieve operational performance of the asset, yet also the longevity of the asset and the long-term sustainability of the asset. The other broad category is basically related to how do we employ and adapt new technologies and advanced technologies in this space, and particularly, for example, technologies related to the utilization of 3D printing, robotics, centralized control systems, twin systems, or what have you. In this regard, if we take, for example, the case of robotics, we have been employing robotics to basically give us a clear indication on the health status of certain pipelines, particularly of the old ones. And this is helping to give us an indication of the current status and also avoiding, hopefully, having major issues down the road, which is also very cost effective when it comes to other alternative ways of doing it. The other potential use of technologies is basically 3D printing. And we have been experimenting with this in one of our transmission systems, whereby we manufacture certain spare parts that may not sometimes be available, or you may not be able to basically acquire them fairly quick. And that would certainly also help reduce the time, cost, and achieve also uninterrupted service. Now, on top of all of these broad categories, if you like, we employ also, or it's very important to employ contingency and emergency plans, and also to have in place comprehensive risk registers that basically would cover all of the transmission systems in our case, and all water assets broadly. This would help certainly prolonging the use of the assets and ensuring the long-term sustainability of the water assets.
Wonderful. Thanks for sharing those insights, Dr. Tariq. I want to now move into we've touched on some of the smart water aspects, and I want to dive a bit deeper into smart water and the future of water. Going back to SIO, Engineer Mohammed, SIO is driving to move into a data-driven organization, and you've touched on some of those areas. Can you share with us how you're utilizing the smart technologies to optimize water allocation for different regions, but also different types of crops across the kingdom?
طبعاً اليوم في ظل ظروف الندرة اللي تواجهها المملكة من محدودية المصادر وارتفاع الطلب على المياه في القطاع الزراعي، بالإضافة إلى وجود مستهدفات طموحة في الاستراتيجية الوطنية للمياه، أصبح من الضروري إيجاد حلول تجمع الابتكار وذكاء الآلة وأن توظف بالشكل المطلوب لتحقيق إدارة هذه المياه وتوزيعها بشكل عادل في القطاع الزراعي. ما قمنا به في هذا الجانب، طورنا منصة ذكاء الأعمال. هذه المنصة تجمع البيانات التشغيلية وإنتاج كميات المياه المعالجة التي ترد إلى المؤسسة من محطات معالجة الصرف الصحي في المملكة. هذه البيانات بالإضافة إلى بيانات المناخ والطقس، بالإضافة إلى بيانات التربة واستهلاك المحاصيل ونمطها على مسار العام، نجد بعض المحاصيل استهلاكها يقل في الشتاء ويزداد في فترات الزراعة وفترات الصيف. هذه المنصة ساعدت بشكل كبير في تحديد المخصص والمقنن المائي لكل مزارع على حدة، بناء على ما لديه من محاصيل وبناء على ما لديه من غطاء شجري في هذه الحيازة. ساعدتنا هذه المنصة في تنبؤ النمط التشغيلي في أنظمة المؤسسة التشغيلية، سواء في النقل أو في التوزيع، وتوزيع المياه التي ترد بشكل مثالي يحقق الاستدامة والعدالة في توفير هذه المياه في ظل محدودية مصادر المياه المتاحة. ساعد ذلك أيضا في خلق فرص جديدة في فترات الشتاء في الاستفادة من وفر كميات المياه التي نتحصل عليها في فترة الشتاء في زراعة محاصيل موسمية، نستفيد من الوفرة، ننتج كميات وفيرة من الحبوب والأعلاف تساهم في تغطية الطلب في قطاع الثروة الحيوانية، وأيضا في تغطية احتياج السوق من بعض المحاصيل، وأيضا في نفس الوقت ساهم في الاستفادة من هذا المورد الثمين في ظل ندرته في المملكة العربية السعودية. حققت هذه المنصة أهداف التنمية المستدامة والهدف السادس في أهداف التنمية المستدامة، ويساعد ليس فقط المؤسسة ولكن يساعد أيضا في تحقيق مستهدفات الاستراتيجية الوطنية للزراعة في توظيف المياه واستغلالها بالشكل الأمثل في فترات الوفرة وفي فترات الجفاف.
Thank you, Engineer Mohammed. It seems like there's an active program around water management in optimizing it across regions, but also across crops. You've mentioned 84% of water usage going across agriculture, so it's great to see an active program to reduce that demand. So I want to jump across to Dr. Tariq around. Obviously, you're trialing a lot of technologies, smart technologies around IoT and digitalization. There's a lot of technologies out there. It's a very crowded market. The elephant in the room is adoption and turning it into business as usual. Interested to understand what steps have you has your organization taken to accelerate that process of adoption of these technologies and turning into business as usual?
Thank you, Nada. So basically, as you already said, there are emerging technologies that affect the daily life of every one of us and all industries almost. And in this regard, we have started already making some steps by focusing primarily into integrating the advanced technologies and analytical tools into our existing platforms and processes. We have a platform. I'll give you an example. We do have today a platform called IMDAD, which was built jointly with our colleagues at previously SWIC, now SWA. And IMDAD is basically a platform that coordinates the water supply across the entire value chain of the water sector: production, transmission, and distribution. In addition, we also have another comprehensive GIS system that basically maps out all of the desalination plants, transmission pipelines, storage tanks, pump stations, city gates, distribution networks, etc. Both of these systems, when they couple together, they basically provide a very comprehensive source of information for the entire water sector, including all of its assets and infrastructure. Now, by basically relying or adopting certain analytical tools and advanced technologies, machine learning or what have you, we can basically extract very important knowledge related to the utilization of the assets. For example, we've been able to basically,
based on the discussion we've had, is smart. Certainly in the UK, we're looking at smart meters for all of our customers. In the UK, the challenge is about behavior and using smart meters to change customer behavior to reduce consumption. So that's all around smart.
Yep. Smart, good word. Engineer Mohammed Halawani?
I think the word is sustainability.
Sustainability.
But I would like to add a small thing. Really, today I get very interesting news that UK is thinking to build a desalination plant. Really, it's something I never thought that 5 or 10 years ago. A few months ago, I think Portugal also, they awarded a consortium to build the first desalination plant in Portugal. And now UK is thinking, so good to know how the world is reshaping, let's say.
Excellent. So we've got smart, we've got sustainability. Engineer Mohammed Abu Haid, what word would you like to describe the future of water?
I think there is a challenge of having a competition in the water resources. But I do believe when we utilize the innovation and the what we have from our HR's capabilities, we can achieve beyond the expectation.
And what word would you use?
Well, I think utilizing the available resources, thinking out of the box will be the right choice for that.
Excellent, excellent. Thank you. And last but not least, what word did you describe the future of water?
optimization.
Optimization. Excellent. Thank you all. It's been an absolute pleasure to moderate your session. Thank you for all your insights. And please join me in welcoming this wonderful panel session. Panelists.
Thank you.
Thank you, Nada. Thank you, all the panelists. Very informative session. My word is possibility, I think, and opportunity. Give them a round of applause again as they leave the stage. Thank you. So for our next keynote speech, I'd like to invite Amma Batiki up the stage shortly, speak about something that I think is very fundamental to this conference, water innovation management and AI. I was speaking at a conference last week on AI and how, we're in this AI scramble phase 23, 24. The next 2 years, 2025, 26, will be the AI pivot stage, and then the AI fueled business moving from 2027 onwards. And to discuss how the AI business and how it's going to affect water management, innovation water management, please welcome to the stage Amar Batiki.
Hey, thank you. Thanks for the intro. Hi, everyone. I'd like to start by thanking you for inviting me to present on a topic I'm really passionate about, AI and how the AI is going to help create more sustainable water solutions. So just kind of a bit of a background, I lead pretty much digital and data for Jacobs, a 45,000 employee organization that drives engineering solutions in critical infrastructure, water and environment. And we deliver water solutions from end to end. We have planning, design, all the way to operating around 250 facilities across the globe. And we've been in the kingdom for 60 years, and we're really proud to be part of the journey in delivering critical infrastructure and water solutions in the kingdom. So when we talk about water, we truly believe all water has value across the full water life cycle. And as we've been delivering water solutions, we continue to hear the increase in complexity in how to deliver water solutions, also the increase in capital and operational cost. And we truly believe that data and AI are going to be a key part of delivering better solutions to our water regulators and our water utilities. But before you do that, you really need to work hard on pretty much securing, connecting, and accessing the data. Typically, the utilities have their data spread all over, and it's not really easy to access. And over the last few years, we've been really focused on identifying ways and methods in automating how you connect and access data. So really, it's not as easy as people think. We have data linked to the CMMS, maintenance equipment, your ERPs, your GIS, some of your designs. You need to figure out how you connect that to empower your data. And we've worked on really figuring out ways to automate accessing that data and allowing you to deliver value through insights from the connectivity of that data. Once you do that, you actually can start creating solutions across the full life cycle of your data. It starts off from your business case. The ability to come up with a proper business case that's based on data was an important thing, all the way to operations where you kind of make a dynamic decision-making operation component. Now, in the last 18 months, there's been a bigger focus on AI, and there are AI solutions. So I thought I'd simplify that into 3 buckets. The easiest way to leverage AI is your chat assistants. It's basically providing you access to information that is existing on the web and your proprietary data, and you have a chat bot that you can ask and get information. So that was kind of our first key focus on leveraging AI. The second one is around enhancing, connecting the data and enhancing how you get solutions as a result of the connected data, and enabling you to come up with logical answers around questions that you give the AI, which is kind of the second component. So enhanced logic and enabling you to do tasks. And then the final stage, which now we've started working on, is the AI agent. It's actually a AI-enabled, automated, and managing workflows that basically taking tasks on your behalf. So you start by accessing the information better through AI, then work on increasing connectivity between your data. AI can access your data in a better way, and then finally having an automated AI agent that takes. And what you see in red is where your system will overflow if you have a weather event that was 25% higher. and it would show you the 7 sites that would overflow. And then it also now can give you recommendations on where you have extra capacity in the system and if your system is able to connect that. Historically, this would have taken a study or a research component. Now it's automated for us, and we've got this deployed in a couple of cities, and our clients really like the interaction that you have with a chatbot and an action bot. We've spent a lot of time in pretty much enhancing operations of our wastewater collection system, our distribution system, and our treatment works in the last 5 years. And we've leveraged data as we do that, and our focus in the last 12 months has been around increasing AI utilization. So today, without AI, you can actually optimize around energy and chemicals. You can actually work on delivering work schedules, leveraging your data without AI. So the next evolution of the solution, we started first by using the chatbots to provide access to your maintenance manuals. You know, on every wastewater treatment plant, you have a huge number of equipment with maintenance manuals, and you would have to go through them to find the answer. You actually now can just simply request the answer through your chatbot. You also can include your predictive, preventive maintenance manual that helps you decide when to replace a pump station. Instead of scheduling that, your AI now tells you when that should be done on an automated way. We also have incorporated the safety data inside our AI agent, and it basically looks at your safety reports and gives you potential safety hazards that you should avoid and recommends activities to reduce safety. And in part also focusing on operational cost, we've figured out a way to reduce energy and chemical consumption by accessing your blowers data, your chemical consumption, and your AI now gives you daily recommendations around that. So really now moving from leveraging data to having an AI agent that's helping you in your day-to-day operation. Where do we think is the next stage? And this is kind of really what I wanted to talk about. We are now starting to look at pretty much augmented reality. So how can we take this data and information to your operators at the front line and make sure they are really having access to data live in the plant itself? So as they walk through the plant and they're looking at equipment, they can get access to the metadata. We've done that through putting all this data on your virtual reality glasses, and we want to deploy these glasses with our operators. As you can see, it gives you information around your pipes, your pump stations. It also tells you actions that you could take. You could take them from your command and control center, but it kind of shows you where this information can be actioned on site, so that if there's anything that's urgent that you need to do, it points that out. But also more importantly, as you take that action, we want to make sure we identify any hazards or any health and safety concerns that can come up and tell you what's going on. So basically really work on making the frontline operators enabled and safe and no longer have to be very experienced also. They can have a command and control center person that is experienced that's helped guiding them as they do the operations. We've started this in the water sector. We do plan to take this beyond the water sector. We feel it's consistent in how you do O&M. So truly, when you think about what AI can do, and kind of I've listened to the panel before, it is really an enabler to make us come up with solutions we couldn't do in the last few years. We had a lot of progress on coming up with solutions based on data, but now you can process that data in a way that you couldn't historically and come up with solutions across the full life cycle of your assets and of your projects. So really exciting times. I truly believe that AI is going to enable us to create a more sustainable water solution for many places in the world. Thank you. Appreciate it.
Thank you, Amma, and I'm sure we all learned something from Amma's very enlightening speech. So to now carry this forward to the next panel discussion, I'd like to invite Dr. Mary Matthews, AI Water Management and AI, with her panel to discuss this, which we have just a second. So Dr. Mary Matthews, Engineer Simon Ailey, Engineer Abdullah Jabri, Dr. Hussein Bassi, Dr. Lin Wayan, and Dr. Ahmed Al-Thioud. Mary, take it away. Thank you. Thank you.
Thank you so much. Is my microphone is on? Thank you very much. I really appreciate this, everybody. Let's bring everybody on. Engineer Simon Ailey, please join us. Followed by Engineer Abdullah Jabri, Dr. Hussein Bassi, Dr. Liu Weiyan, and Dr. Ahmed Abu Al-Thioud. Wonderful. Thank you all so much for joining us. In this particular session, let's have a seat so we can start our discussion. I'd like to ask you all very quickly, because we're going to have a quick round of introductions. We've got our introductions, our titles up here, but I want you to tell me very, very quickly, who are you and where are you from?
Starting with me, Mary.
Yes.
Good morning. So my name's Simon Ailey. I work for the Water Research Centre in the UK and also in the Middle East, and I lead international strategy.
Great.
So my name is Abdullah Jabri. I'm the General Manager of Engineering Design and AI Application from the Saudi Water Authority.
Wonderful.
My name is Hussein Bassi, and I'm an energy expert at Watira, Saudi Water Authority.
Super. Dr. Liu?
I'm Liu Weiyan from China, China's largest water company, BWG. I'm in charge of the operation of all the water works. Thank you.
Assalamu alaikum. Good morning. My name is Ahmed Abu Saud. I am the Senior Mentor Management Expert in the United Nations Development Program on water and oceans.
All right. Thank you all so much for being here and for joining us today. We just heard a very interesting presentation about the role of AI and water and how that can really change things. And I appreciate that you all were so generous in sending me early questions. But given that we're a little short on time today, and we want to give you all a chance to explain what you do and why it's important, we're going to have what we call the lightning round. And I'm going to do this from time to time. I'm going to start here this time with Simon, but then I'm going to mix it up a little bit. I'd like you to tell us, let's say you're in an elevator with someone, you're going to the 11th floor, and you need to explain to someone who's important, who does not know anything about water or AI, how you use AI and water and why that's important to them. And you've got approximately 1.5 minutes to do that. And all of you get to answer this too.
Does it start now?
It starts now.
Okay. So I guess from my perspective, AI and water, if we take the water pipe analogy, Mary, think of a water pipe in the ground. Think of the number of factors that can influence the health of that pipe, okay? And you might be talking about the pipe material itself, its age, it's the year that it was built, what is in the pipe, the type of water, the temperature, and you'll also be looking at the externalities around the pipe, the actual soil that it's in, the ground conditions, perhaps the salinity, perhaps any impacts of tides, etc. All that data can be used manually, traditionally, to calculate the health of that asset and its propensity to leak or burst or fail. What AI does is accelerate that process. So it takes all of that data and more. It can take previous burst data, previous repair data, and it can very, very quickly process it so that engineers like myself can get the insights needed to make strategic decisions. And those decisions can be investment decisions, They can be decisions as to when to replace that asset, perhaps to line that asset, or perhaps just to repair a leak. So it enables me as an engineer to do that much, much faster. But the important thing with AI for me is closing the loop. So taking those decisions, the things that I've made, the things that people do on the ground, and feeding them back into algorithms so that AI can learn and give more advanced insights and greater accuracy.
Amazing. So that would basically help us reduce the incredible water losses that are in the system already.
Absolutely. It's
All
key
right.
to doing that, and it's key to doing it efficiently.
Excellent. Very, very good. I'm going to come back to this. All right. Engineer Abdallah, I want to ask you a question very similar to that, but building, this is the trick we're going to play here, on what Engineer Simon has said. So he's got this information with AI from the pipes and the surrounding areas and so forth to improve the efficiency. How does that relate to your work?
So it goes like into, you have this big dump of data, like Simon mentioned, in terms of parameters, whether it was temperature, flows, or in terms of assets, or in terms of even geotechnical locations or GIS data. So you put all of these dump of data into a single model that will tell you where is the data can be perfected and where the data how can be efficient. Where is the data that it has some kind of gaps within those data and you have problems and you need extra parameters to be reading from those data. And it would help you into some kind of forecasting on what might go wrong, how you can make this better, how can you be in terms of energy efficiency or increasing your quality of that asset itself. So all of these big dump of data to be dealt with in a very efficient way. Like Simon is saying, it can be done through AI.
Excellent. All right. Very good. Let me now take what you said and ask Dr. Hussain. Here's the question for you. He mentioned, Dr. Abdallah mentioned, Engineer Abdallah mentioned that it helps with the efficiency, not only with regards to the water efficiency, but to the energy efficiency. Tell me how AI helps you with that, with the energy efficiency.
Right. I'm really glad that you put me right next to Engineer Abdallah, because we're working together already in one of the projects that we are having in SWA. Let me put it this way. Now, the use of artificial intelligence in our water system is that I can put it in 3 different categories of applications. The first one is about prediction. That will help even for the executive operation and maintenance, R&D, to oversee what's going to happen in the future so they can be prepared for it. And that's, of course, relied on a lot of data that has been collected so far. The second thing is that it can help in the optimization. So we can optimize the better use of the operation in terms of energy consumption, water losses, water operation, and so on. One more thing that can help is that it can help the decision makers to have a better idea how to operate the plants. Now, all of these 3 categories can work in terms of just giving some sort of like, I would say it like insights and some advice. But artificial intelligence can go all the way beyond that. It can take a decision on your behalf and then just do it. But we are not, we are still on the way to take it all the way there.
All right. Then let me now ask Dr. Liu a very important question. And thank you so much for that, gentlemen, for kind of setting this up for Dr. Liu. You work with wastewater treatment plants all over China, around the world, including here in Saudi Arabia. Do you see the application of AI as something that will increase your water efficiency and your energy efficiency, but what other benefits do you see for that in your specific day-to-day life and area of expertise?
Okay. First, I want to give a very short introduction of our company. BWG is China's largest water company. Just as Mary said, we have more than 500 wastewater treatment plants and more than 200 of water and desalination water plant. So how to manage this waterworks is my essential thing. With AI technology, we integrated the big data with the AI model. We developed, full process of the intelligent control to decrease the cost for the, especially for the energy consumption. We know the Saudi's vision 2030, you have the target to the net zero carbon emission for 2060. We also have the similar target in China. So in water industry, our aim is to meet the country's mission, the target. So we do a lot of things like that. The second thing we developed is with AI technology. We developed a predictive system for the equipment, such as the pump. We can predict the condition or the failure before it's totally break down. So we can save the time and it has, larger the lifespan for the pump or other equipment, and so on. So many scenarios we have developed because it's essential for a large water company to do that. Thank you.
Excellent. Thank you. Thank you so much. And this actually now beautifully sets up the question I have for Ahmed El Sayed, who I confess is actually my colleague. So I look forward to his response on this because I always get to ask him the difficult questions. Ahmed, in your experience, both within Egypt as well as working internationally in UNDP, do you see the path forward with AI and water being something that can be used in many countries rather than in developed countries or very wealthy countries? Is it something, how would you see it used in, say, least developed countries, small island developing states? Do you see that there's a potential for that there? And if so, how would you do that?
Oh, definitely.
That was an easy question.
AI is important now because, as our colleagues mentioned, it helps us to do some homework for us as decision makers and planners for water. So the AI is a tool, and we have to know that. It's a tool that helps us to have a better management of our water resources. So any country that has water resources management plans can use these tools to improve water resources. For example, I used to work in the Ministry of Water Resources in Egypt while I was an engineer, and we talk about 1 month to calculate the Nile forecast for the next year, because we have to collect the historical information and write and draw trends and see how these trends and try to collect data from the field. This took us a lot of time and a lot of effort. The needs of we have a lot of the applications of AI that can fit for any country who wants to have a better management of their water resources. So it's a revolution.
Excellent. Thank you. Simon, I get the feeling you want to comment on this.
Yeah, if I could, if you don't mind,
Please.
if that's okay. You mentioned agriculture, and that's the bit we've not touched on yet, is the fact that we can use data, you mentioned if it's cleansed, to bring together that whole world of water, that system. depending on which country you're in, 60, 70% of the water consumption is for agriculture. So if we can use that same data and link the whole world of water and use AI to accelerate that decision making, then that'd be brilliant. Sorry.
Nope, excellent. I get excited every time I hear about this. But one of the things I want to ask while I have the opportunity, because I'm not an expert in AI, I am an expert in water, but I'm not an expert in AI, is we hear a lot of reports about the water intensity of AI and that there's some challenges in terms of the demand for water resources to run, to cool, as I understand, okay guys, I'm not an expert in this, to cool the systems, to keep the system working. Tell me, Abdullah, how much, and all of you, how concerned should we be about this?
Not much, actually, because like Dr. Hussein mentioned, we already started a couple of POCs that are already, and including one of the initiative right now in the transformational roles of the SWA itself, when it was a Saline Water Conversion Corporation. Right now, it's a Saudi Water Authority in terms of the entire water sector. So we've started an initiative, and we already started, and we have more than one POC and more than one success cases in terms of a full platform in terms of water management monitoring completely. And it's not that intensive, I would like to say. We've started more than one. We've chosen 2 or 3 of them. It was a success story. It was easy to implement in terms of an end goal, but it was very hectic in terms of cleansing the data, actually eliminating the manual or the human intervention into within those data, and closing the gap within the parameter that we want to monitor. I would like to say that, and hopefully that we can hear it today, that we've already have a success use case, and hopefully that we will hear a launch within this conference about that platform.
Inshallah. We look forward to that. That sounds wonderful, and I'm very excited about it. Let me ask Dr. Liu, if I may. How do you, within China, where you do have various conditions, how do you manage the water demand intensity for the AI? Is that something that you factor into the work that you do?
Yes, I just want to add some additional idea. That is, I mean, the AI technology is not the only core for the water management. I want to see the standardization of the facilities and the data is a crucial thing. And Mary said also for the challenge of the AI, I think it will lead to the reduction of the manpower. That's true. I think it's poses a social issue. But if we do like in another way, if we employ the same quality of the employees, they will have the adequate time to do the innovation work, such as to find more scenarios for the AI application. That will be good. It's not a challenge, but chance for all of us to get good from the AI. So in China, we want, in our company, we want to do that for our employees, to do the innovation work. Their routine work should be replaced by the AI. Yes.
Excellent. Thank you.
Okay.
Dr. Hussein, you
Yes.
look like you're ready to respond to that as well.
Right. I don't know. You have a really, really good body reading skills. Thank you for that. Well, here's the thing. Now, everybody here is talking about data and data gathering and data processing and artificial intelligence applications on all of these things. Now, but there's one step behind it, which is the sensors that are connected, everywhere. So it's the hardware that we are supposed to have a good focus on. Let me give you a very quick example of what we are doing so far at Watira. Watira is the R&D arm of Saudi Water Authority. And as of for now, we are developing a couple of sensors to have a better readings of different things, such as water quality, energy consumption, water leakage as well. So that will follow the same concept that has mentioned here, how we can have sensors that would give us accurate information with very good accuracy, and the maintenance for those sensors are not going to be some sort of like a headache. And once we have that, then the next phase comes how we can transmit those data into, for example, the central data center that can process that kind of data. Once we have the data with good quality, with good frequency, with accurate information that we are requiring, then the software will gonna be the top layer that can help us out to interpret the data that we collected and put it in the right way. And that's where the projects that we're talking about, Engineer Abdullah here mentioned about, is that once we have the data, but we didn't tell you what's the big story behind it yet. And we're not going to tell you until this project, inshallah, is done.
Okay, I think that's very fair. And I'm really interested to see how this will work. Let me ask Engineer Ahmed a quick question, because I think this is really something that ties together. He and I are, we're going to say, old enough that we remember back in the days where we actually, Ahmed was speaking about having to go out in the field to collect ideas to where ideally it would be.
We have to be careful about using the AI, as our colleagues mentioned, garbage in, garbage out. If you don't have the right data for the AI, you will not get the right answer. So you have to build, as our colleagues mentioned, you have to build your database, your data collection systems, in order to feed the AI with the right information. And this is at the basics for any successful system. We are using AI in the future, in the past, but what we can say it's was not programmed. We use it. We use our brains, our small computers to draw the trends and try to predict. Now the technology helped us to go faster and do more data and try to, and we have the ability now to analyze millions of data in seconds. And this is the revolution that we need to take care when we are using it. We have to keep our data collection systems as perfect as possible, that accurate, validated, and then, as my colleague mentioned, the layer of the AI can come and take this data and give you the answers that you spend in the past maybe months, or sometimes you cannot even have the ability to make the analysis of this data. So, as I said, if you want to have an updated system for water resources management using technologies like AI in any country, you have to first start with the infrastructure, data, the data collection systems, then you have your technology, and then the manpower who will operate, because you have to have quality control and quality assurance for every step you have, in order, because when you reach to the AI level, then you will have the decision, and this decision will go to the decision maker based on this strong base of data and information. So any country can do that, but as I said, you have to be careful, very careful about the data collection systems.
All right. Simon, again, you seem ready to
just,
pounce.
just because I'm just building from it, because I think the word of caution with AI is really important, and to recognize that us in our world, what we're talking about is our silo of water. We're talking about a regulatory authority. We're talking about water treatment, wastewater treatment, and conveyance and storage. But the world of water is all the sectors coming together. So it's how do we form future regulation that allows that smart AI to transfer from our sector in and out, but also to agriculture, tourism, leisure, education, and healthcare. And you start to bring that together with societal impacts and sectors that do a lot more of this, like if you have X or Twitter or LinkedIn, all the kind of algorithms that look at those societal factors as well. When you bring that together carefully, I think that's when we'll see the step change in the world of water beyond what we do. But it is hard enough to do it just in our world, let alone bringing those other sectors in as well.
Exactly, and yet I think we've got a lot of potential to learn from these other sectors. One of the hats I wear is I'm a member of UN Water, which is all of the UN agencies that work on water. There are 36 different UN agencies and organizations that work on water, and the senior program managers come together about twice a year, and one of the biggest challenges we have is seeing water from the water sector and going, okay, we've got to fix this. Why don't they understand? We cannot realize any of the sustainable development goals for 2030 if we cannot get water right. The Global Commission on the Economics of Water has released an absolutely astounding report on global water, the global water cycle, as well as the value of water and the importance of valuing water. You all have been really a wonderful panel. I want to ask each of you to give me just a quick forecast. If you were speaking to your great-granddaughter about, I know this is way off, for a few of you this is a lot further off. If you were speaking to your great-granddaughter and she asked you, what did you see the future to be like when it came to AI and water? What one word would you use to describe that? Let's start, actually, I'm going to start with Ahmed this time.
Yeah, I think the future will be mimicking the human. You have to have I think they are now trying to do that. There is no perfect AI up till now, and that's true. But for engineering, I think the human role will stay because we have to make verification for the AI results and make sure that the AI will give us the right answers. And
one word.
Yes, I hope that in 10, 15 years from now, we can have a automated system for water resources management in most of the countries that is really starving for water and suffer from droughts and so from lack of water resources.
Inshallah. Thank you so much. Now we're going to try to keep this down to one word. Dr. Liu.
I do have one word.
Okay, one word.
If my granddaughter comes to me and saying how the future is going to look like with artificial intelligence and water, I'm going to ask her to go and watch the Matrix movie. That's going to answer the whole thing.
Okay, very good, very good. Dr. Liu.
Okay, I want to see there are the steps to the application of AI. First is the foundation, is the standardization. Second, automation. Third, AI technology. That will be the step. That's all.
Very good. Thank you.
Well, my message is going to be for my daughter, not for my granddaughter. So it's going to be adopted. It's going to be part of our life.
Okay, very good.
So 50 years' time, I'd like to think, I can't get this in one word, but I'd like to think that my daughters, my great-granddaughters, live in a world where water and food are valued just as much as life.
Very good. Thank you. Honestly, I think I could ask you all questions for the next 3 or 4 hours, but I also know that our organizers and our very kind audience have other things we have to get onto, so we will look forward to continuing the conversations off stage. And again, I want to thank you all so much for joining us and sharing your insights. And I'd like to thank the audience also for the excellent attentiveness and support. So thank you all very much. It's been wonderful to have you here. Thank you. A round of applause for our panelists.
Thank you, Mary. Thank you, Simon, Abdullah, Hussein, Liu, and Dr. Ahmed. Thank you very much indeed. Okay. One of the interesting things, whilst we get off the stage before I introduce the next speaker, I'm glad you asked, Mary, about the water usage of AI. There's something in sustainability. There is no solution on any challenge. Everything we do is a trade-off. And as you well know, data is the hidden sort of thing. Data, carbon emissions by 2040, they reckon will be 25% water usage and, of course, employability. And that requires excellent judgment. So, moving on, we're now going into 3 separate case studies for the next, leading up to coffee break. The first one we are going to be speaking on is AI-assisted simulation software to reduce engineering lead time. And that is Dr. Sangu Lee. Dr. Sangu, would you like to come to the stage, please? Dr. Sangu, over to you. Give him a round of applause, please.
Thank you very much for the kind introduction. And as introduced, my name is Sang-Ho Lee, and I'm a professor at Kookmin University in South Korea. But I'm also a part-time water expert in WITRA SWA. So the presentation that I'm going to talk about today is one of my projects that I'm working on in WITRA, which is about the development of the simulation program for the membrane brine concentrator. So in my talk, I'd like to give you some brief overview of the digital desalination as well as the simulation-based design. And then I'm going to talk about some specific case study related to the development of simulation software for the membrane brine concentrator, which is an essential part of the brine mining. And then I'll also talk about our future of of this kind of approach, as well as the potential of AI for improving the efficiency of the process design and simulation. So these are the contents that I'm going to give you in today's presentation. So let me start with the introduction. Although we know a lot of the desalination, but we still have a lot of challenges, like the challenges for the process design, plant design, as well as the challenges in the operation and maintenance. So we have challenges like design and the energy efficiency and cost optimization are related to the design challenges. And we have operational challenges like the prevention of scaling and foulings. And so there are many kind of things that we have to consider. If we talk about the design challenges, so far we have some object of the design targets, and we needed to consider several things for the design. And so far, what we think is that the design procedure is more like a black box. So we don't know exactly what's happening inside the plant and process, but based on some experience and some empirical calculations, we can design the process. So that makes some uncertainties in the design that should be avoided probably in the future. As for the operation and maintenance challenges, what we wanted to do is to know what will happen in the future in the plant, as well as what's actually going on in the plant. So that's the ideal practice for the operation and maintenance. However, in the real practice is we don't know exactly what's happening, and we want to know what will happen exactly, but there are some limitations in the technologies. So because of that, the idea of digital desalination came, which is the integration of advanced digital technologies like IoT and digital twins and AI for improving the design and operation efficiencies. So the thing that I'm going to talk about, which is the simulation-based design, is also one of the digital desalination approaches. So digital desalination is not just a fancy word that makes people fascinated. Instead, it should be a way to reduce the water cost for the desalination. So if you break down the water cost, we have some capital recovery as well as the energy cost, labors, and maintenance, replacement, as well as some overhead. But if we know what will happen in the design steps, we can optimize the capital expenses so that we can reduce the capital recovery. And we can also optimize the process for reducing the energy consumption as well as the reduction in the labor cost. We can actually reduce the water cost. So digital desalination should be the way to actually, on the levelization-based design, we first needed to develop the simulation model, and then we can carry out the simulation based on some scenarios or by considering a variety of different parameters. And by doing that, we can optimize the design and process configurations and process parameters. And then eventually, what we also needed to do is the validation of the design by comparing this with the actual data from either pilot plant or the full-scale plant. Of course, by doing that, we can reduce a significant amount of the actual test in the field. And in this context, we can say that we can reduce a lot of time and a lot of money by choosing this kind of approach. And this simulation-based design is the first step toward the digital twin. So this kind of design can be classified as digital prototypes. So digital prototype means that when we don't have any physical plant, but if we have the simulation models, we can actually see what will happen before it is constructed. So that's the digital prototyping for the conceptual design. So this is very efficient if you wanted to develop a novel process such as the membrane brine concentrator. And from digital prototype, we can have the actual digital model, digital shadow, and eventually we can make this digital twin, which is synchronization between the virtual plant and the real plant. So starting from this digital simulation-based design, we can eventually make this digital twin for not only the design, but also the operation and maintenance. So there are different types of the model. Of course, in process design, we normally use some computer models, either the mechanistic model or the statistical model. An AI model is also a special kind of this statistical model. And simulations can be classified into several categories like flow sheeting simulations and specification simulations, optimization simulations, and synthesis problems. And one thing that I want to mention at this point is that we have a choice between some mechanistic model, which consists of the mathematical equations, and the statistical model or AI model that uses some, deep learning models or some other models. And depending on the situation, we needed to choose either mechanistic or AI models, because there should be a balance between simplicity and complexity. If the problem is very complex, we needed to go for the AI model. But if the problem is rather straightforward, in this case, there is no reason why we need to consider AI model. Instead, we needed to consider the mechanistic model because it is more universal and generalized approaches. So by doing this process simulation, we can increase the productivity, performance, and product quality. And there are a couple of questions that we can answer by carrying out these process simulations. And sometimes auto projection is done, which is also simplified case for the process simulation. So unlike these conventional auto projections, process simulation that I'm talking about here is more broadened, and it can include not only the reverse osmosis, but also all different kinds of these membrane processes. And it can be it can also include the membranes from different manufacturers as well as different configurations. So by doing that, we can actually understand more about this process design, and we can consider the new cases by using this kind of approaches. So let me talk about the case study, which is about the design of a membrane brine concentrator using simulation software. So as you know that this membrane brine concentrator is an essential part for the brine mining, because we first needed to concentrate the brine, and then we needed to extract some of the valuable resources. However, there's some limited information on these membrane brine concentrators, and we also have limited data available for the design and optimization. Because of this limitation, we started developing these simulation programs a few years ago. So when we first deal with this problem, we found that there are some fundamental differences between the reverse osmosis and these membrane brine concentrators. So we needed to consider different mathematical models as well as the different conditions for the operation, and we also needed to deal with some convergence problems. So we have gone through these kind of steps. So we set up the mechanical model for the process design. So we first have a couple of parameters and variables, and then we have some model equations for the simulation of 3 stages membrane brine concentrators. But of course, we can simulate the second 2 stages or 4 stages, depending on the situation. And we also developed the models for the post-processing of the outputs, like final brine concentration, as well as the specific energy consumption. We first started using Microsoft Excel, and then we found that it's not possible. So instead we used a commercial program named Engineering Equation Solver, just for developing this program. So we developed the code, and we developed the interface. This is actually the first version of our membrane brine concentrator. And of course, we compared our simulation results with the result from the pilot plant working in Witira. So we found that this model prediction matches the pilot plant data very well. So this is the model validation. And so we developed the first version, which consists of 7 sub-programs. So the first program compares the conventional SWRO with the hybrid system consisting of SWRO with the brine concentrator. And then we have a couple of sub-programs for different simulations, like using commercial membranes, using some custom-made membranes, using some commercial nanofiltration membranes. So there are a couple of sub-programs depending on the users. So some program is for the beginners, and some programs are for the researchers and engineers and experts. In fact, I prepared the demonstration of the first version and the second version of our software, but unfortunately, because of some technical issues, I cannot do that right now. But instead, we prepare a workshop session starting at 12:45. So at that time, I'll actually show the program, and I'll actually run the program to explain the potential of this program. So this program can be used for planning, designing, and operation and maintenance of this membrane brine concentrator system. And so this is the interface of the first version, which is good, but it's not fancy. So, and it's something not easy to access by general engineers and some researchers. So we plan to develop the second version based on the first version. So the second version, we plan to have a new platform. Instead of using commercial platform like EES, we plan to have our own platform based on C# programming language. And this can be used for variety of different kind of cases. And we also make this program more stable and a very nice interface. And we started developing this program this year. So the development will end by the end of this year. And we have a framework, we have some interface, we have libraries, so that we came up with the program. So this is still the first draft. So the final version will be available at the end of December. But so far, we confirmed that this program is working, and there are a lot of possibilities that we can do with this kind of program and platform. The demonstration of the second version will be also done 12:45 today in the workshop session. So let me briefly mention about the future plans and conclude my presentation. So the reason why we developed this membrane brine concentrator simulation program is that we wanted to collaborate with the people not only in SWA, but also in many different universities and research institutes and companies who are interested in the membrane brine concentrators. So we can share the knowledge, we can share the experience, and we can share the program so that we can co-develop the IPs, or we can write the papers together. So there are a lot of possibilities and benefits expected from this international collaboration. And then we also plan to extend our program beyond the membrane brine concentrator, because we already have the platform for process simulation. So by replacing the equation with some specific process, we can have a custom-made process simulation programs, not just for membrane brine concentrators, but also other brine mining processes like crystallization, Azure models, NSC model with the AI model, so we can have the advantages from two different modeling approaches. So that's all I prepared for my presentation today. Thank you very much for your attention.
Thank you very much for this first case study. And without further ado, I'd like to bring Dr. Simon Ailey back to the stage to speak on sustainability and advanced materials. Simon?
Thank you, Andrew. Thank you. Good morning, ladies and gentlemen. And the first thing I need is a clicker. So my name is Simon Ailey. I've got the pleasure of working for the Water Research Centre in the UK, where I lead our international strategy. I'm a chemical engineer, 28 years experience, and hence most of my work is around solving really difficult problems. And I do that with water regulators and water companies and municipalities around the world. So let's start for a second. I know it's coffee coming up soon, but let's just take a minute to have a look at that image on the screen. And just imagine you're stood on the surface of the moon. That moon has a radius of about 1,700 kilometers. It has a solid core, which is made mostly of iron, a very high iron content. And that core is about 240 kilometers in diameter. The crust of the moon, the surface of the moon, measures in thickness from about 70 kilometers thick to about 150 kilometers thick. And it's comprised of oxygen, and I'll read these out now. Oxygen, silicon, magnesium, iron, calcium, aluminium. You know, all the 6 Apollo missions to the moon, they've actually brought back over 2,196 samples for analysis. That moon is 384,400 kilometers away from where we are today. And I would argue that we probably know more about the composition of the moon and its properties than we do the assets that are buried beneath our ground, the assets that we manage every day. So what I'm going to do this morning is just share a few little insights over the next few minutes on a subject that we're working at the moment. So I want to start with big pipes and little pipes. So SWA in the room, probably NWC as well, and other people that work in the water sector in Saudi Arabia. You'll know you've got big transmission pipes, and you know you've got smaller distribution pipes, distribution networks. I want to talk about something with those pipes that's really important to those countries that are looking to transform the way they work with regards to non-revenue water. And that is, and it's certainly the case in the UK, that we've really focused on those little pipes, and we've assumed that little pipes are the cause of most water loss. But actually, what we need to remember is those really big transmission pipes, those large diameter assets, they do leak. We go out, we look at them, we survey them, we analyze them. They do leak. And 2% of a very big pipe is a very, very big volume. So let's not ignore those assets. Let's consider all our assets when we talk about non-revenue water. Here's an example of some work we've done on those large diameter assets. So we've broken those large diameter assets. They're not in district metered areas. They're not DMAs. But we can break them up. We can break them up into TMAs, transmission main areas. We can break them up and call them trunk main areas. And we can balance those areas up. And we've done this in part of the UK, breaking a large transmission network down into 600 smaller pieces that we can then analyze. And we can do that analysis using software, using machine learning to try and gain those efficiencies. Why is that important? Well, it allowed us to understand if there was leakage in the first place, and in this case there was, and then take action. So the first step we did in taking action with this network is we found one particular section of transmission main looked like it was leaking. We predicted it. We went and we did an in-pipe survey of that pipe. We found the leakage on day one, and it was 2 MLD. So it starts to show that the data, the analytics, the strategic thinking really can very quickly turn into a tangible benefit on the ground and reduce water loss. I mentioned the word strategy. And I think it's really important that we have a plan in everything we do. There is a real tendency around the world to dive in and deploy technology. And there's plenty of brilliant technology available here in this room and out in the exhibition. And I would encourage you to go and see it and engage with those technology developers, the software solution developers. They form part of our future and a key part of it. But it's got to start with a bit of strategy first. It's got to start with a bit of planning first. So we have plenty of tools that you can see on the screen that can be used to find leakage on networks. From external devices that work on acoustics but bringing in AI and software to help expedite that process, through to systems that can go inside pipes that are designed to go a few meters or designed to run for tens of kilometers. All that technology is out there. But to get the best value from that technology, you need to use all of it in different times and for different purposes. So again, it comes back to having a plan. So the little pipes, the distribution, the service pipes. I think this is where the bulk of the global effort is. And again, don't ignore those big pipes. But these are the pipes that our customers, these are the ones they phone in about. These are the ones they pick up the phone, they get on Twitter or X, and they make complaints, they make comments. So this is where we respond. This is how we respond. There's plenty of examples in the Middle East and around the world of some excellent low levels of non-revenue water. The UK is perhaps a mediocre performer in that space, maybe about 20% non-revenue water, and I know I shouldn't be using percentages because it's actually about real volumes that matter. Percentages can hide the truth. And there are countries out there where non-revenue water is much higher. Interestingly, I would say that the countries with high NRW have the potential to make the biggest step change because technology and solutions have stepped up significantly and are now able to accelerate that transition to a low leakage network. But why would we choose to do that? This conference is about sustainability, so we want to be sustainable, we want to be able to leave something to our children. But we also want to invest. And actually, there's some strong evidence coming out now that investing in non-revenue water has quite a significant GDP growth impact as well. So there's good reasons for doing it. Education, giving our children, our children's children, a future, another reason for doing it. The skills development, R&D. I mean, we're talking about innovation here at this conference. We're talking about R&D and the brilliant Reybig water oasis that we saw yesterday. That's all about development. It's all about capacity building. So by tackling leakage, you are growing your economy and you're growing your country. And that's pretty impressive for fixing a few leaks on a few pipes. So I want to tell you a real story. So this is not from Saudi Arabia, but this is real non-revenue water data. And if you look at the screen there, you see a nice little graph, and it's in megaliters per day, and you can see a proper water loss reduction journey. And if you look at the start of that journey from this water utility, they had a pretty bumpy ride. Yep, you can see the level of leakage going up and down, and then they start a downward trend, okay? This is good. We like a downward trend when we're looking at that kind of performance graph. Things are looking good. Until you look at the gray line in that red circle, and all of a sudden, things start going wrong. The question is why? And what's happened is when they started that downward trend, they put more people out on the network. People, leak detection, just find leaks, and then when you find them, spray a mark on the ground, dig a hole and go and fix the leak and carry on and go and find the next one. Which is logical. This is common across the world. That's a logical approach. However, if you're using the same contractors, the same people doing the job with the same procedures and the same materials, the same pipe, the same fitting in the same environment, we all know in this room what you're going to get. You're going to get the same results. And that's exactly what's happened. It's worked for a short amount of time, and then it fails again. And that's not what we're about. It's not what I'm about. It's not what we're about in this room. It's not about what my company's about. We want sustainable results. And you can see the photos from this particular network where you have services that are buried only 200 millimeters deep, and they should be about 600, 650. No decent bend radiuses on the pipe, so the pipe split. You have electrofusion tees where the correct procedures have not been followed. And the worrying thing for us is in this room is when that is done, those networks will pass a pressure test. You will get a certificate at the end of it from your contractors that say, yes, it's passed. The reality is, of course, is about a year to 18 months down the line, it fails. It's simply not fit for purpose. So what do we do about it? And this is what we are doing for another client in the region at the moment. We're running quite a large non-revenue water reduction program. And the first thing we're doing is we're replacing 150,000 service pipes. And we have already written a new standard for the service pipes, and we're doing training, capacity building, audit. Nice to start with a plan. Wouldn't it be nice to start with a strategy? This is what we've done here in New Zealand. So non-revenue water, as you can imagine, features huge numbers of variables from what you should do about your pipe replacement strategy, your REPEX, your OPEX, what you should do about your metering strategy. Do you do smart meter rollout? When do you do it? How many meters do you roll out? Do you roll out DMAs? All of those are huge, big strategic investment decisions. And you need a strategy that includes adaptive pathways because your business will change day by day, because the impact of climate change is probably accelerating. We need strategies that flex and adapt to that. And in New Zealand, to allow them to properly, technically and commercially evaluate every single step along that pathway. That in turn can enable you to actually predict the results you're going to get from each and every step on that pathway. And I mean predict technically, water loss reduction, consumer billing, you can predict that. And then as you're doing it, you can then measure it, validate it, feed it back into your strategy, and adapt if you need to. You know, a linear strategy in our world just doesn't work. You've got to have flex in it. You've got to have adaptability. And that's exactly what we're doing with our non-revenue water programs, where we actually calculate the water loss in MLD, megalitres per day, for each and every intervention you're going to make. So finally, technology is brilliant. It's a key part of enabling us to adapt for the future and to respond very quickly, or to predict and respond very quickly to the impact of climate change. But there's a lot of the work that we need to do right now is focused on people, processes, and procedures. And that's what I'm passionate about, as well as bringing in that technology so that we can solve problems together. If you want to continue this conversation, I'm here today and tomorrow. I'm on LinkedIn, look me up. And finally, if you want to talk about the subject of leakage, from leakage professionals from around the world, if you want to meet with your peers and gain that knowledge, we are a sponsor of the Global Leakage Summit happening in May in London.
Okay, innovation is important, but especially you need to use innovation to create real results. Also, earlier, we have seen how AI can help us in the water industry. How we can use this technology to go on and get a better operation, lower costs. What is important is that when we are talking about AI, usually we don't have a rule or a model for that system. So all the information that will be used to generate models and to optimize the systems will come from the data. And that's why data is so important. We at Turing are developing AI solutions for the water industry and digital solutions. And I can tell you, 80% of our time in any AI project is related with the data management. And I also can tell you that more than 90% of the problems are also related to data. So when we start any project, we need to really focus on how we will manage, how we will gather the data, and how we will check if this data is correct to be used to train our models. And of course, these models will be later be used through an algorithm optimization to generate set points that will be used in real plants. I will show here one example from optimization in a real desalination plant in Bahrain. It's a plant for more than 200,000 cubic meters per day and has 26 trains. So a lot of work during this application was done even before we start to receive data. We need to understand how this data is generated, how it's stored, how this data will be moved from the plant to our system, and how the set points will be moved back or informed. When we talk about data, we have usually 4 challenges. The first one is data availability. How can I look at this data? And seems to be easier, but when we move from historical data that you can share in a file, even a big one, but with daily operations, you need to receive the data from the plant every day. In this case, it was every day because it was a desalination plant where you generated set points at every 24 hours. But sometimes now we move to SBRO systems, or systems where you need to generate a set point at every hour. We saw before today people talking about agents that take actions in water systems almost in live real data. So the availability is really important, and you need to have a good technology to transfer the information from the field to the data management base and to the system. Also, another issue is data quality. When we handle data on a historic view, we can have data analysts, human intervention, looking for the data, looking for errors. But when we are doing or working with agents in real time, we need an automated algorithm to check if this data is really good, if there is any sensor problem. Because after you use this data to generate something, it's really hard to remove that influence from the models. Because you know, we are training or retraining those models at every hour. And I will show you later why this is important. Because the retraining is the secret to get better results. But of course, you need to have good data to make this retraining in a good way. The latency is also important, because sometimes it took time from the data to come from a sensor in the field to the SCADA system to the database. As we are training these AI agents almost in real time, if you have outdated data, you will have outdated results. And so we may lose here that 1 or 2 or 3% of extra savings that are really important. We need to get the best from the system. So latency is a really big issue. And last but not least important, the cybersecurity. So all this needs to be done in a safely way, following regulations. Every company has its own rules. Also, nations have those rules. And what we can see as a tendency in the market is also on-premise applications, where the data, in fact, never leaves the plant. What you do is you take the model and train the model inside the plant system. So it's safer, but also you need to be sure that the model that you are not seeing, that you don't have, you are not touching the model, but you need to be sure that this model is making good decisions. The plant that we use as an example, we did a lot of job before starting, but in the beginning, the solution that we used was a daily email transfer. So it was simpler and faster for the beginning, and was a safe solution as the operators just get a file and send the file to a specific email in our system. With this file, we were able to make the optimization in the beginning with very small configuration, and our system generated set points that went sent back to the operators by email. So it doesn't need to be high technology, but you just need to focus on how you will do it. But at the end, that solution took too much time from the operators. So we had to move to something that was already planned for a second phase and was done. This is the architecture of one OPC server, where you have a secure connection, and the OPC server is in the plant, so it collects all the data from the plant, and you have a secure connection to our system where we run the AI models. This was totally integrated, is automated and reliable, and also it allows you to make a direct integrated pipeline through all that I explained before. So you need to check first if the data is healthy, then you go to the model, you retrain the model, then you go to the optimization algorithm and test various scenarios to see what is the most energy efficient position at the plant to generate the goal of the production of that day. And then you generate the set points and send these set points back to the plant. Here we have the result. So we can see that in the beginning, here is a 3 months performance test. So we got some trains from the plant operated by the operator with his set points, and some trains were operated by this AI agent. And what we can see that in the beginning, the first 2 to 3 weeks, we got some savings, 0.8%. But that daily return from data from the plant, so the AI agent can see the results from what he decided yesterday and can take better decisions. So this is a key factor to any effective high energy saving in any AI project. And we see that after 1 month, we are in almost 2%. And we can see in 3 months, at the very end, we were close to 5% energy savings in a specific energy use. And for sure, this velocity, in one moment you get to some limit, but you need to give time to the model to adapt and to understand how a plant operates. My message here is, if we have poor data, we will have unreliable models. So we need to expend time looking at the plant, getting, understanding which sensors we have, how these sensors are maintained, calibrated, and we have to monitor this data before we use it for training. Also, as data is needed for training, we need to have it updated fast. And maybe here the golden gem. You need to have a performance monitoring framework that will be able to detect anomalies, will be able to detect problems, and also as we are talking about models or any agent that is taking decisions, we need to monitor in real time the errors of these decisions. And so we can check if the model is updated, if the system is working well. So it's not only look at the result, we got energy savings or not, but we need to monitor all the process to be sure that good decisions are not only being made at the moment, but also will be made in the future. And as I talked before, we don't have more time to have a human on the loop. So we need to have like a supervisor of the AI, is an AI supervisor of the AI agent. But that's the solution that can give us really good results. Thank you for all. That's our experience. I will be in the Congress until tomorrow. So if you want to talk about AI, it's my passion. And we can see you later. Thank you.
Thank you, Sandro, and thank you to all the speakers and panelists this morning for our first theme, water management and AI. So you'll be pleased to know we are now going for coffee break. When we come back, we'll be back to desalination technologies. We are going to try and shorten the catch-up time with the panel discussions in particular. But if you could be back here, if you can try and get back here in 15 minutes' time, just after 10:45, we'd appreciate it. Enjoy your coffee break.
Can you hear me?
Hello, can you hear me?
Ladies and gentlemen, we will be commencing the conference in 2 minutes. In 2 minutes. Testing.
You want to announce again or what? You will introduce?
Ladies and gentlemen, we're going to start the conference again. If you could come in from the exhibition halls to listen to some great keynote speakers and panel discussions, we'd appreciate your presence. Thank you. Coffee breaks always go on longer than planned in conferences. Okay, ladies and gentlemen, welcome back. That concluded, as I said before, the coffee break. Our first theme, AI and water management. We're now on to our second theme, desalination technologies, which of course Saudi Arabia has been the leading player in the world. And to start this next theme, we're delighted to introduce to the stage Professor Stephen Gray, who's going to be speaking, offer a keynote speech on pioneering desalination technologies. Stephen.
Hello, everyone. It's great to be here at the IDWS Conference. It's my first time here, and I think a conference in water that's focused on innovation is a great initiative, given the challenges that the water sector is going to face globally over the next few years, next decade. So congratulations to the organisers for picking out that theme and running with it. For those of you who don't know me, I'm Professor Stephen Gray from Victoria University in Australia, in Melbourne, Australia. And I've been in water research for over 30 years and mainly focused on membrane treatments. My topic for today is on next generation desalination. But I was also invited to give some presentation on the desalination sector in Australia, the desalination market. So I'll start off by doing that and then move on to what's coming up in desalination. So there's a map of Australia, and you can see different colours there, but what they're representing is those darker areas are regions where we're experiencing decrease in rainfall, and the green areas where we're getting more rainfall. And that's based on actual data, but if we do climate modelling, we get much the same outcome as what's shown there. And we're expecting that to get more severe in terms of drying out of Australia. When we look at where our major urban areas are, we can see that they're in those brown areas, so those regions where we're going to experience less rainfall, and that's going to be potentially a problem for us. During 2000, up to 2010, from the start of the millennium, we had an extended dry period of about 13 years, and that precipitated our first wave of desalination investment. And you can see the desalination plants there located on the map. And some of the attendees here noted to me that Australia built these desalination plants and then haven't used them, because once we finished building them, we certainly got a lot of rain down the east coast. And so we didn't use them initially, but we are now. And they're not running full out, but flat out, but we're learning how to run them at low capacity. So that's one of the good learnings for the Australian desalination community, is how to achieve running of desalination plants at high turn down ratios, so at lower capacity than what they're designed for. That's certainly the true on the East Coast and Adelaide, but you'll see in Perth, they have never had any rainfall come back to support their water needs. So they've just continued to dry out. So they built the Perth desalination plant first. They built a second one, the Southern Seawater Desalination Plant, and augmented that before it was finished because they needed the extra water. And then in 2022, so more recently, they've just finished their groundwater replenishment scheme, so some recycled water that they're building as well, or have built to support them. So still very dry in the southwest of Australia. You'll also see in the northwest, Cape Preston, that desalination plant, which is quite significant, 140 megalitres a day, was built there to support mining operations, so iron ore processing operations. So it's not there to support a big community, it's there to support industrial needs. And so they're the investments we currently have. The way they were built, we contracted large international companies experienced in desalination, went for fairly conservative designs, and while this conference is about innovation, one of the barriers to innovation is also people's willingness to take a risk. And for big investments like this, people not so keen to take a risk. So that's maybe something for us to think about as we think about innovation and how that gets commercialised. The other novel thing of the Australian systems is most of them were designed to have their energy needs offset by additional renewable energy schemes. So we built the plants, but we also built wind farms and solar farms to offset their energy use, and that goes into the grid. Those locations in red, the red writing, they're new desalination plants that are either under construction or being proposed. So while we finished that first round of investment back in 2010, and there hasn't been a great deal since, we're starting to see a second wave of investment in desalination in Australia. And if you look at Perth, Brisbane, Sydney, they're the main cities where there's desalination being built for communities. So Perth are building a third desalination plant. They already have the two that are running flat out. They're putting in another third one, again running on renewable energy, or their energy needs being offset by new renewable energy schemes. In Brisbane, proposed that they augment their current desalination plant, put in a water treatment plant for their water recycling scheme, and then at some stage thinking about a new desalination plant north of Brisbane. Sydney has a small plant just to the north of it that's under construction, so a fairly small one, 30 megalitres a day to support a satellite community of Sydney, and also looking at a recycling scheme which is there to also assist with some of their nutrient discharges into the river, as well as supplying water. But there's two other schemes there that are quite significant. One's the Northern Water Desalination Plant near Adelaide, the red dot near Adelaide, and that's there to support, it's being proposed to support our large Olympic dam mining operations. So that's one of the largest copper mines in the world. So what's being proposed is a desalination plant and a 600-kilometre pipeline. That's been proposed before, maybe 10 years ago, and never got off the ground, but now it's looking like it will take off. And so it will be there to support that mining operation, potentially some new green hydrogen production. So one of the things that, or one of the investments Australia wants to make is into green hydrogen, and they'll have to do that using desalinated water. We will have to do that with desalinated water. And potentially some agricultural use as well, probably fairly minor there. But the other location where we have lots of red is up in the northwest, up on near Karratha. That's again, it's small augmentation to a current thermal desal plant, a small RO, 24 megalitres a day for another mining operation with Rio Tinto, and then another proposed big desalination plant to support further mining operations, green hydrogen production, and some agriculture. So that's been proposed by Legacy, a French company, Suez, and the native title holders there. So those last two are being proposed. I'm going to flick over these because I need to make sure I don't go over time. Okay, so this one looks a little bit different to what I was expecting, but we've had some studies done on Australia's road to decarbonisation. So Australia is moving towards zero carbon emissions from its energy system, and to do that there's potential ways we could go about doing that, and we've had some universities and consultants looking at what that transition might look like for different sectors of the Australian economy, and one of those sectors is the water sector. So if you look at the left graph, what they're doing is predicting water demand as a result of that transition, and there's different ways we can transition, but you see we have an increase in total water consumption. We have a drying climate, so the next graph along is showing how much fresh water we're going to use in that, so how much environmental water from rivers and lakes, and you see that's going to decline. So that gap, that increasing gap, is going to have to be filled by what we would call manufactured water, so desalinated water or water recycling. And that graph in the middle of Australia, that map of Australia, shows some locations on the coast, and they're proposed to be desalination hubs, and then the blue lines running in are pipelines to distribute that water inland to mining operations and other agricultural activities. So this is not a government document, it's a privately funded study, but it shows that, you know, Australia, to make that transition to zero carbon discharges from its energy production, will have to invest quite heavily in desalination. And I suppose the two last proposals I mentioned before, up in the northwest, the Nulla Nulla desalination plant and the Northern Water desalination plant down in South Australia, would fit into that type of an approach, so that they will have desalination plants on the coast supporting mining, green energy production and agriculture, and distribution through fairly long pipelines. I'm going to skip over this one because we need to move along. In terms of next generation desal, what I was asked to do was to look at what are the new technologies that could make an impact in the near future. So not something that might be some years away, and so that's what I've done. When we look at why we want to have new technologies, it's because we want lower energy consumption, lower cost. We're going to be faced with increased algal blooms, more NOM, so we have to be able to deal with those and also participate in the circular economy. Okay. These overheads are a little bit different, as I said, to what I was expecting, so it's come up already, but there you see a flow sheet of typical desalination process. You have some pre-treatment, an RO process, and then some restabilisation. underneath what says ceramic membranes, we might have a DAF or a media filter and ultrafiltration, as well as cartridge filters before the RO. One of the things people are getting excited about is ceramic membranes. Ceramic membranes as pre-treatment to RO, and looking at that because they have high flow rate, so high flux, so very low footprint, lower energy compared to DAF and UF, able to handle algal blooms very well, so you don't get a shutdown of your system, and also lower cost overall. One of the, so while we're putting up ceramic membranes as a possible advancement because of their ability to handle those algae blooms, but on the right there I've listed some other membranes that are either emerging or currently available that can also handle algae blooms quite well as well, so they might be alternatives. But at the moment, there's a lot of focus on ceramic membranes. Ceramic membranes also have the advantage of being very long lasting, so they'll last not for 10 years, maybe 20 years. There's been some plants operating in Japan for that long. With regards to the RO system, there's probably going to be a series of continuous improvements across different aspects of the RO process and RO management. Up there I've got the interlocking end caps from DuPont, currently sold by DuPont but are not widely used through the industry. Their patent is running out, so there's potential for that to be picked up by other manufacturers as well. They give the advantage of lower pressure drop on the permeate side, as well as the way we manage O-rings. Dry storage of membranes, so replacement membranes stored on site. If you can store them dry, you're not worried about preserving agents and having to change them out. So the membranes last longer, less likely to degrade with time. So again, cost savings associated with that. And one of the other advances that has been happening is not really a widget as such, but it's the service life of membranes has increased and improved in some instances. So we see examples of desalination plants, seawater desalination plants, where they haven't changed out the RO membranes for over 10 years. 10 years or 14 years in some instances. And that represents a significant savings for the operations of the desalination plant. So while this is seen in some instances, the challenge is how do we roll that out so it becomes the norm. It's all about how we manage those membranes in service. In terms of the actual RO elements, some of the ways that they can be improved is through spacer design, and we saw some of those in the applicants for the prize yesterday. There were some of those up there, and so that's an area that people have been focused on. With the advent of 3D printing, those more complicated designs become more reasonable to manufacture, and in fact we have the first company appearing, which is shown down there at the bottom, which is printing little dots on the surface which act as the spacers. So not much in terms of obstruction there, so low pressure drop across the membrane, low biofouling as a result of that, or low fouling on the membrane because they're not getting caught up. In terms of membrane materials, we have a few new membrane materials listed there. So the aquaporin membranes are currently commercial but not used a great deal for seawater. They're under trial. They potentially offer greater permeability, so more water flow through their system for reduced energy consumption. They're also looking at having hollow fibre membranes for the second stage RO. Again, see lower energy consumption as a result of that. Our award winner from yesterday, the NALA membranes, along with Zvitaco, offer low fouling membranes because of either the ability to chlorine dose in the case of Nala, or in case of Zvita, a non-fouling surface with Zvita ionic coatings on it. All those membranes will make some advancement, but they've also got to compete with the likes of the incumbent membrane manufacturers such as DuPont, who are constantly improving their membrane permeability and membrane functionality. So we would expect some improvement there. Where it comes from, we're not entirely sure. In terms of restabilisation and circular economy, IDE are probably quite well advanced in thinking about how we can capture chemicals that we use for desalination from the brine and the seawater. And the process that is proposed there, the processes that are proposed there, is to put pellet reactor in the feed to precipitate out calcium carbonate, put that through a calcinator to produce carbon dioxide and calcium hydroxide, which can then be used to restabilise the treated water. And seem to be able to, or claiming they can do that at a reasonable price. There's some other benefits of doing that. So because with a pellet reactor, you're increasing the pH. So the pH goes up to about 8.8, 8.9. In terms of biofouling, biological growth, it's not as easy for biological organisms to grow at that pH, so you see some reduction in biofouling potential as a result of that increase in pH. Increase in pH also improves boron rejection, and so you can either get away with no second stage RO or a smaller second stage RO and less chemical consumption there. There's some other initiatives that are out there which people are looking at. So use of ion exchange for boron, bromide removal, that's been around for a while, sold by DuPont. Interest in Australia because we have some particular issues with bromide, but can also be used for boron removal as well, as just as another alternative to that second stage RO. Probably one advancement that Saudi Arabia might be quite interested in is in the high recovery RO. So this is taking it from 40 to 50% water recovery up to 50 to 60% water recovery through the use of high pressure reverse osmosis, so operating up to about 120 bar. And with the advent of pressure recovery systems that can operate at that pressure, that's becoming quite reasonable to operate, or it seems to be quite reasonable. So the energy consumption there per additional water is about 2.1, 2.9 kilowatt hours per cubic metre. So there's some of the energy consumptions being reported. They still have a bit of a barrier to implementation. So when you run those systems currently, you see quite severe compaction of the RO membranes and you lose permeability. So I think maybe next year in the prize, perhaps we'll see some ideas about how we can make more mechanically stable, so membranes that compress less for use in high pressure RO. But certainly in terms of energy consumption, cost, it's looking like it might be quite attractive to do that. Recovery of minerals from brines, I think we have another talk later today on that, so I'll leave that for them to cover. And I'll skip over this one. This one was not looking like I was expecting. But in summary, Australia does have a second wave of desalination investment occurring. So we're seeing that occurring not just for meeting urban needs, but also now more for industrial needs, and we would expect that to continue long term as we transition to a carbon neutral economy. In terms of the next generation desalination, what I've presented is just a few examples of the technology that's currently looking like it will make an impact fairly soon, but there are probably other technologies out there as well. But I think you can see that there are advancements right across the seawater desalination process that look quite attractive, and we're going to need to improve our energy consumption and our costs if we're actually going to be able to deliver on those plans for desalination. My last. If we're going to make it to build those desalination plants to support that energy transition. Thank you.
Microphone, there we go. Thank you very much, Professor Stephen Gray, for that fascinating talk on desalination. So we're going to go straight into our next panel discussion. Future-ready desalination, best practices and innovations for sustainable solutions, chaired by Professor In Kim. And joining him on stage, well, virtually will be Christine Carbon, Farouk Hassan on stage, Dr. Rami Mohammed, Dr. Peng Wang, and Professor Hans Ruenvelder. Could I ask again for panelists to please keep your responses short so we can try and catch up some time that we've lost in the morning. Professor In Kim, over to you. Thank you.
Very good. But you said mention my name.
Close this.
Because to him.
TV screen, yeah. Hi.
He said he will. She said he will.
I should sit here then.
That's okay.
Thank you. Good morning, ladies and gentlemen. This session is especially for discussing, as you can see, the title is Future Ready Desalination. We're going to select best practice and some of the innovations in sustainability. We have 5 global experts in the panel, and each one of them has a lot of experience on that. But since we are under a little bit tight schedules, so it's going to be approximately between 20 to 25 minutes. So I'd like to introduce the 5 now. First one is Professor Hans Ruenvelder, KAUST in Saudi Arabia, and the Professor Peng Wang from Sen University in China, and we have Dr. Rami Mohammed from GTI Energy in US, and then Mr. Farouk Hassan is from Siemens, and then lastly, not least, and we have Christian Carboni. But the last person is on the line. Let me start by giving a core niche question to the first person, to the Professor Hans Ruenvelder. Well, this question goes to you. What is considered a major problem in membrane-based seawater desalination? And do you know any opportunities to address this in any suitable way?
Okay.
Can you
Thanks
please
for the question.
comment on it?
Thank you.
All right.
One of the major problems in desalination is biofouling. This is acknowledged by industry. The annual cost for Saudi Arabia alone is around $400 million. And there's many ways you can try to contribute to reduce it. So typical is that chemicals like antiscalants are being dosed. And it has been found that antiscalants can contain food for bacteria to grow. So if at some point you optimize your anti-scalants or make better choices in anti-scalants, at least you're not adding food, which would lead to biofouling. So there's some easy tricks what you can do. Another approach is what you could do is that you look at cleanings. Now research is being done on novel cleanings where they also reuse the cleaning chemicals. So that means that cleanings becomes more sustainable. If I make a step to how could so sustainability is increasingly important. The other aspect is how can you at some point reduce the cost of desalination? Now there's many ways what you can do. So there is, as I said, this chemical dosage, cleaning. You can also think what we have found is that when you have a short increase in permeate flux, or you have a short-term higher elevated water temperature, you could have a permanent performance loss. So I think when you have this information, you can improve membranes, that it resists less, or you modify your operation that the impact or your performance is being not permanent. I also have the idea that, of course, membrane-based desalination is well established. So with probably a lot of different types of research, you can scrape off a little bit of the cost of desalination. Probably if you lump it all together, you may be able to reduce desalination cost by 10%. If you really want to have a huge reduction for the cost, you could also take into account water distribution in the network. Because if you have huge losses in the distribution network, and you could target them, you can reduce building desalination plants. So I think there's a lot of, if you want to have really major costs in desalination, I think I would do investment more maybe in distribution networks. Is this answering your question?
Thank you very much.
Thank you.
Now, I'd like to ask Professor Peng Wang. Second question goes to you. Can you please talk on China's practice in terms of water desalination plant and wastewater reuse, especially in terms of innovative solutions? Please comment on it.
Thank you. So first, I want to say thank you to SWA for organizing GPID as well as this conference. I had wonderful 2 days thus far. I came from China, from Guangdong province. If you have been in Guangdong province, you would know that this is a province that has 126 million people, with GDP of 2023, 1.9 trillion, which is almost 2 times the GDP of the kingdom. Now, in terms of water desalination, Guangdong province has a lot of advantages because the length of the coastal line of Guangdong province is over 4,000 kilometers. And we have Shenzhen, we have Guangzhou, we have Zhuhai, all those mega cities in the province. But when we talk about water desalination capacity of this province, I can say that there so far has not been any large desalination plant that produce drinking water for municipal uses. This is the reason why I believe that we can learn tremendously from the kingdom, from other countries in the region in terms of promoting sustainable desalination to provide sufficient water for everyone, and also how to manage big projects with efficiency. Now, in light of this, there has been type of innovative research, innovative strategy, innovative designs in terms of desalination, which at this point are being investigated, are being studied, are being piloted at smaller scale, like a pilot scale, medium-sized project. So I was invited to serve as panel member last week in China to assess some of the state-funded large project desalination and wastewater reuse. And I was very much impressed by the innovative approaches they were studying, and also the very impressive progress they made. Now, for those studies, they are looking at very innovative processes, how to achieve zero liquid discharge for desalination project at smaller scale for the petrochemical plants of medium size to reach zero liquid discharge. So all of these, even though they are not as a full size, large project size, but I believe the creativity, their innovative aspect can be gradually being translated into larger projects. So for this, I would say, really, we share the same problem, and we need to learn from each other. That's why I feel I have picked up a lot of things from this conference thus far, and I do hope that SWA will work more closely with Chinese partners in the years to come. Thank you.
Thank you. Okay, next question goes to Dr. Rami Mohammed. Let me get into a little bit more details.
Oh, okay.
All right. Now, we have a lot of unit operational technology, such as adsorption or cold osmosis, humidification, dehumidification, many those technologies. Now, which emerging desal technology do you believe have any potential for global water stress? Can you comment on that?
Yeah, actually, thank you so much for this question. It's actually a very challenging question actually to be addressed in a short period of time. But our colleague here talked about like a membrane. Membrane is considered like one of emerging technology for future sustainability. Mainly as the bio-inspired membrane and graphene-based membrane, which has like a high freshwater production rate and could reject salt at low pressure, so less energy consumption. But I would like to focus more about like thermal desalination as a different category from membrane category. In terms of this, we are in research and development. We are focused on nanoporous material application, such as like adsorption desalination technology using combination between nanoporous material and evaporation. And this technology actually is promising to address the water scarcity now and in future because it's used like an eco-friendly refrigerant, and also it can be powered by solar energy or low-grade waste heat, which is a good candidate for energy decarbonization. So if you can harvest waste heat from industry to power a desalination system, this should be considered an emerging approach to address the water scarcity and also energy decarbonization. Another thing actually, or another approach or another strategy we see here in Saudi Arabia in integrating the system. So we see in KAUST, for example, a good example here about like integrating multi-effect desalination with adsorption technology to increase the temperature limit, which led to like 3 to 4 folds increase in freshwater production and energy consumption as well. Another nanoporous material application is water harvesting from atmosphere. And this is good for like a hot and humid climate. It's a local problem, and you can solve and harvest some water, and you can direct it for like fresh water or food production and agriculture, as Professor Hang said. These two things actually is a good example, adsorption and nanomaterial. And also something about how to power the future desalination plant. When we're talking about like Gulf area or MENA, like Middle East, it makes sense to talk about solar energy, right? And we have a good example in Dubai right now. They're building a planet that will be commissioned in 2026, and it produces about 800,000 cubic meter per day, and it will serve about like 2 million people. And the good thing with this planet is reverse osmosis, which is a state of the art right now, but it's powered by solar energy. This is a good example to leverage the advantage of solar energy. But I came from United States, which this option is not there. So we have to rely on fossil fuel to power our desalination plant. Especially, I came from, technically from Chicago, so almost no sun there. So we have to invent another technology that can be integrated by desalination in future, which is carbon capture. So we are at GTI Energy. We develop a different technology to capture the carbon from the flue gases that you use to power the desalination. So in conclusion, sustainability should focus about the technology itself, integration, and solve the local problems. Hope this answers your question.
Thank you very much for your
Thank you.
answers now. Next question goes to gentleman who's working long time in real multinational firms, Siemens. Mr. Farooq Hassan. What could be the key enablers for desalination market growth in the Middle East? Simple question. But you have vast experience on it, right? Please comment on that.
Assalamu alaikum, and good morning. It's still morning, huh? And thank you, Ian, for asking this question. Middle East is located in a water-stressed region. And the prime source of drinkable water is desalination. Inefficiencies in the desalination plant processes is a major contributor of excessive amount of energy and chemicals, high maintenance cost, as well as inconsistencies in water feed quality is also making a big challenge for this industry to be cost effective. On the other hand, the market is pushing to bring the cost of potable water less than 30 cents per meter cube, so it's a challenge. We used to say that if we want to really think out of the box, then behave a little bit unconventionally. Go for the disruptive technologies, cutting-edge innovative solutions in order to effectively monitor, optimize, and maintain the desalination plant as well as the relevant processes. Utilizing the operational intelligence to support and enable the operators to take informed decisions. Siemens is committed to play a vital role when it comes to supporting our water customers to achieve their water management sustainability goals. Now, I want to just give a small example of considering a desalination plant. We start from engineering and design, then we go to the simulation, optimization, life cycle support, and this remains a continuous loop. So we start with the engineering, and we use our Comos engineering tool to reduce the engineering efforts, cut down the cost and time spent in engineering, then go to the simulation using the CIMIT to ensure remote commissioning. And you imagine that if you don't have to fly in an expert from overseas, how much cost it can also save, and the time. Plus the operator training simulators. Then moving to the optimization, using our dynamic data modeling tool, predictive process simulation tool called GPROM, which is used to optimize the energy requirement or energy consumption, production cost, as well as resource management or resource efficiencies. Ultimately, and last but not the least, moving from this to the life cycle support, we have Comos MRO, which is ensuring the maintenance and rather I would say the smart maintenance and the managing the inventories and also the overhauling the plant. And then using the augmented reality to really go on site, check the machines to have the operational intelligence. And this process is enabling I would say the evergreen plant, which is on its own course correction, keeping itself fitting into the sustainability equation. And this is we are committed to.
Thank you.
I hope I answer your question. A little bit longer, but.
All right. If we have more, then I can come back to you. All right. Well, I'd like to ask another question to Mr. Christian Carboni. Are you online now?
Yes, I hope you can hear me.
That's great.
Yes.
Okay. Now, I'd like to get in more details. Now, whenever we are dealing with desalinated water by using reverse osmosis membrane, are there any health issues related to desalinated water, as far as you know?
Well, interesting question. First of all, let me thank the organizer for inviting me, but particularly for West for they made for allow me to be connected, given the logistic problem that I had. For sure, reverse osmosis is a good technology because take away a lot of pollutants, but we know that there is some potential issue in using particularly reverse osmosis. One of this issue you know very well, which is the needing to remineralize, primarily with calcium magnesium, also for problem distribution network and for organoleptic reason. But there is a lot of open question studied working in these periods, also for understanding the contribution of trace elements, lithium, for example, that contribute to the health. In Europe, in particular in Spain, South Portugal, Greece, Italy, where we are using the desalination plant, we are trying to solve this problem, mixing source of water from reverse osmosis, groundwater, surface water, try to improve the water with also these small and trace elements. Second topic, you know very well, I don't want to lose in time with this, is boron and arsenic that pass through the membrane that can create problem, in particular if you want to reuse in agriculture, for irrigation, the desalinated water. The point that I wanted to stress, to put your attention on, is the need to check contaminant emerging concern. This meaning from one side PFAS, from one side pharmaceutical, in particular if we make reuse reverse osmosis with more process that can concentrate these things, because some pollutants pass through the membrane of reverse osmosis. For example, PFBA, that is a PFAS. This PFAS is in the list of the 20 PFAS need to be monitored and checked in Drinking Water Directive European Commission. And these PFAS pass through the reverse osmosis. For sure, reverse osmosis take out a lot of pollutants, but some pass. Also some pesticide, also some pharmaceutical. I think that in the future, you need to pay attention to this one because they come in our body, because pharmaceutical make antimicrobial resistant, for example. I hope I answered your question and you can hear me very well.
Thank you very much. Well, Mr. Corney talked about PFAS. Everybody probably aware on this matter is forever pollutant materials in the drinking waters and the environment. It's polyfluoroalkyl substances. It's very hard material to get rid of it. Anyway, since we are utilizing reverse osmosis, that it's one of the tools that we can do to get it a lot. Yes. This session is now under the title of Future-Ready Desalination, Secure New Innovations in Sustainability. There are so many keywords, as you know, right? It's energy efficiencies and low cost, high throughput, and environmentally friendly, and many, many others. However, I can categorize two things. One is incremental advances. The other one is more disruptive technology. However, if we look at more practical point of view, incremental advances required to get more focus on that. In terms of less than TRL 1 to 3, I think that is very good to find new quantum jump areas. Now, since our time is past about 20 minutes, there's some signs to save some more times. I think it's about time for me to say thank you very much for the audience first, and then thank you very much for your attending here. Thank you. This session is adjourned. Thank you very much.
Thank you.
Thank you. Thank you, Professor In. Thank you to all the panelists for that informative session. Much appreciated. Thank you very much. Okay, so we're now going on to 4 case studies. Again, I'd ask all speakers if they could try and shorten as much as they can so we can catch up on time where we can. The first case study is Sustainability in Advanced Materials, tuning polyamide membrane chemistry for enhanced desalination, Professor Isham Al-Jundi.
Good morning. My name is Jundi. I'm from King Fahd University, and my talk is about an attempt to synthesize a new membrane for desalination, RO membrane. And why RO? Because it is currently the state-of-the-art technology for desalination. However, this technology is expensive. And can you hear me? Yes, this technology is expensive, and currently the most efficient desalination process costs about 3 kilowatt hours per cubic meter. And for the current production in Saudi Arabia, which is about 15 million cubic meters per day, that means the energy consumption is about 45 million kilowatt hour. That's at least. And this energy is equivalent to the household consumption of a country like Jordan. It is equivalent to the household consumption of a city like Rome for 2 days. So it is very expensive, yet efficient, and that's why you will see most of the desalination plants in the high-income countries. More than 60% of the desalination plants are in the high-income countries. So this is one reason we want to make it more energy efficient. And this is basically our objective in the Center of Membranes and Water Security in King Fahd University. We want to cut the cost of water production by 50%. The second reason is that there is a trade-off usually in the RO membranes between the permeability and the selectivity. As you increase the permeability, the selectivity decreases, and vice versa. So we want to try to go over this, what is called upper bound line that is shown in the second graph. So let me give you a brief about the RO membranes. In the past, it was fabricated from cellulose acetate. Maybe currently also there are some few companies that are producing RO membranes from cellulose triacetate. But this is an asymmetric membrane, unlike the thin film composite membrane, which is made of three different layers of materials. And the most important layer is the upper layer, which is the polyamide layer. This polyamide layer is conventionally produced by interacting or the reaction between organic monomer that is dispersed in the organic phase and another monomer that is in the aqueous phase. Usually it's an diamine and alkyl chloride monomers. As you can see over here, the selective layer is the very top layer of this membrane, while the others are supporting layers, although they are very important. So to regulate the membrane fabrication, you need to look at the at least top two layers, which is the polyamide layer and the polysulfone layer. And then you can change a lot of parameters, including the hydrophilicity, the reaction parameters, using novel monomers, trying to introduce some nanomaterials on the surface, etc. But all of them will have advantages and disadvantages. The route that we have taken is to focus on the top layer and increase maybe the hydrophilicity, or basically trying to disrupt the polyamide network by introducing another amine in the chain so that it can change the interchange spacing and hopefully increase the permeability. So the first route is increasing the hydrophilicity. We need to look at the two top layers, the polyamide layer and the supporting layer underneath it. We can increase the hydrophilicity of both, but each one has advantages and disadvantages. For example, if you increase the hydrophilicity of the support layer underneath the polyamide layer, maybe it will attract the amine solution to the porous structure, and then it will create a mechanical interlocking with it, and this will increase the mass transfer resistance in the membrane. However, it's going to be much more stable than if you have done it in a relatively hydrophobic surface of support. In addition, increasing the hydrophilicity, maybe by increasing different chemical moieties, will change the electronic density charge, and this will alter also the reactivity of the amine groups and the diamine. So we need to have a balance between both of these two layers. So basically what we have done, we first synthesized the regular polyamide layer from conventional amine and alkyl chloride. And then we introduced in the second membrane another molecule that has two amine groups. One of them is masked with another molecule, with another group. And then we later on unmasked this group and made the amine group exposed to the surface, which we hypothesized that this will make it more hydrophilic and it will attract more water and increase the permeability. And if you look at the scanning electron microscope picture, you will see that the structure of the top layer has changed, while the cross-sectional area, basically, it is the same. There's a PET support layer and polysulfone layer, and then the polyamide layer, and the thickness is almost the same. we measure the roughness of the surface, which is very important regarding the fouling, regarding the permeation. And we measure the contact angle as well, which gives you an indication about the hydrophilicity of the surface. And you see the last one has lower contact angle, which means that it is more hydrophilic than the original one. Even if you corrected to the roughness of the surface, you will see that the intrinsic hydrophilicity of the membrane is higher. So that's the first indication about the membrane, that is more hydrophilic, so it will attract more water. And then we tested this membrane on different saline solutions, monovalent ions, divalent ions, and even with a real seawater sample. And it showed higher permeability than the original membrane without the modification with this molecule. And then we tested the fouling behavior. Fouling behavior was similar. However, when we calculated the permeate after the fouling, after the cleaning, it was a little bit higher in the modified membrane. In the second route, we introduced another molecule in the reaction, and we hypothesized that this molecule will react with one of the acyl chlorides in the TMC, and then it will create more spacing okay. It will create more spacing, interlayer spacing or interchain spacing between the molecules, and eventually it will have more permeability, hopefully without compromising the rejection of the salt. And again, we tested the contact angle and roughness, and this time the contact angle was a little bit higher, which means it can go to the more hydrophobic side than the other one. But if you look at the roughness of the surface, and then if you correct it with to the roughness, and you will see almost similar contact angle. However, the major change was in the zeta potential, which indicates the surface charge of the membrane. And if you see, the red line represents the modified membrane. It has a higher isoelectric point and lower negativity after the pH of 6. And that's also give you an indication about the cross-linking of the membrane. Maybe the original membrane higher cross-linking degree. We tested the membrane for the saline solution, and we tested also the rejection. Much higher permeation was noticed for the modified membrane, while having also almost the same salt rejection of around 90%, which is in the nanofiltration side. We tested also for the divalent salts, and it was having higher permeation flux, while having almost the same salt rejection for the divalent ions. And the fouling performance was almost similar, decline, slow decline, but stable salt rejection for up to 70 hours of continuous operation. However, when you normalize the data, you'll see that the modified membrane has a lower normalized flux, which may due to the higher positively charged surface that attracted the foulant to the surface. In conclusion, we were able to synthesize new membranes with different properties, and these properties more or less was similar in rejection. However, we enhanced the water permeability, and the rejection was in the nanofiltration side. However, we expect that after optimizing the concentrations of these monomers that we introduced, the performance will be better, inshallah. Finally, I would like to thank the sponsors for this, the Saudi Water Authority, King Fahd University, and most importantly, the team of the IRC Membranes and Water Security, Dr. Abdul Wahid, Dr. Amir, Dr. Jilani, and the other team members. With this, I would like to thank you. And,
Thank you, Issam. Thank you very much indeed. Okay, we're moving on as fast as we can for the second case study. Clean and renewable energy, clean and renewable energy technology in desalination. I'd like to invite to the stage Professor Dong-Suk Han, otherwise known as Shane. Shane, thank you.
Thank you for introduction. Assalamu alaikum, everyone. Let me try. Yes. I wanted the explaining of the renewable energy engagement in desalination plant. Mostly the renewable energy is considered as wind and solar PV power plant. But here is I want to introduce how to utilize the saline water to generate blue energy. So mostly the membrane-based desalination plant require the external energy higher than osmotic pressure of the target water salinity. So mostly the seawater has 0.6 mole and requiring at least the 20 bar. So it means very energy intensive. So COP21, Paris initiate certainly the initiative organization, and they targeting the involvement, the renewable energy involvement in desalination with the range of the 2050 to 2040, gradually increase every 20%. So that, but you know, each all country, including the GCC country, has their national determined commission contributing energy consumption reduction by 25 to 30% reduction. But when it reaches the, we need to reach the 1.5 Celsius degree reduction globally. But when it's thinking about the greenhouse gas emission amount, IPCC reported we need more effort to reduce 30% by 2030. So that upon the existing facility, all renewable energy, including the desalination plant, will be increased like that amount. But also we need to think about how to decarbonize the existing plant. One of the solutions is to use the out of brine. So mostly globally they use the SWR process with the range the water recovery 40 to 50%, requiring at least 60 to 70 bar of the osmotic pressure. They release a lot of out of brine in this existing plant, so we need to utilize it somehow. So EDS, the electric recovery device, utilize the high pressure existing out of brine, and the other ways, you know, even we use this ERD process, we just doesn't use any the salinity of the out of brine. we require a converter somehow using reverse electrodialysis or pressure retarded osmosis. Pressure retarded osmosis is based on the membrane-based power generation, and reverse electrolysis is based on electrochemical-based power generation. When you compare the overall, the PRO process more than RED process in terms of the energy efficiency and power density. So also, when you want to apply the PRO process in desalination plant, so we need to apply the certain pressure in the draw solution side with half of the osmotic pressure, and theoretically we reach a certain amount of power density when you use the dilute solution and concentrate the out of Brine level. But if you go to the modulation, the energy efficiency is going to down. And also we need to apply the actual plant. There are many possibility to lose their power density. So one of the solutions is to directly use the PRO process into existing SW process. This is the diagram is based on turbine-based. Advantage use directly the energy using to some other application. But disadvantage is turbine has their own energy, the operation efficiency. And the other way is the pressure exchange based. We added more pressure exchange the device after PRO process. Compared to the previous case, we can minimize the energy loss generated in PRO process. So the other way to see the pressure, the reverse electrodialysis, this major principle is to utilize the chemical energy to electrochemical energy through the stacked ion exchange membrane. So actually, I'm from Qatar. So Qatar has a lot of the energy-based industry like Saudi Arabia. So when you look at any specific industry area, there really many types of the water type having a different salinity. It means we can utilize somehow this is a saline to generate the power through the reverse electrodialysis. So we test somehow in the CAFCO fertilizer company. They're using some seawater to produce the cooling water somehow, apply the RED, hybridize for the osmosis. So we use the two water stream to be utilized the agriculture the application using the draw solution of ammonia contained wastewater. They're mostly used for draw solution of the FO process. So actually the case in using RED power plant is located in Italy, Mashallah. They test using brine basin and brackish water wall to generate the power with the value 1.5 to 1.7. But actually, when you look at the reference value, the generated power is less than theoretical value. And another, the Netherlands has their case study using the two stage. So their power density show like this, and this is summarized. And when you compare to the RED case and PRO case, mostly the PRO is a more higher efficiency than the RED case. This table shows the summarize using renewable energy to generate power density. Mostly the solar PV is best, and second is PRO, following by the RED and wind turbine. The PRO case, the RED case can be followed similar to the case of the PRO process. They can be directly integrated exist SWR process, but I already mentioned the SWR process energy intensive still. So we need to think about the carbon neutral, decarbonized process. in this plant, we can utilize the CO2 released desalination plant using the electrochemical CO2 electrolysis system. So that is our prototype example. SW process release the wastewater and out of brine that can be utilized somehow in RED process to generate the power to provide the CO2 electrolyzer, where the CO2 electrolyzer convert to the CO2 formic acid. Formic acid is another hydrogen carrier like ammonia, so we can reach the carbon neutral approach. So also, when you go back to the previous slide, when you convert the CO2 somehow another the C1, C2 like a chemical, very valuable chemical, they require 1 and 2 voltage. But RED already mentioned, the RED power density is very low than the PRO case, but we require, CO2 electrolyzer require only 1 and 2 voltage to get value of the chemical in this process. There is a benefit. Also, many researcher groups is developed a gas diffusion electrode that is show the more the high efficiency. Yeah, there is some hurdle when you get a liquid-based CO2 electrolyzer. But the research group developing some desalination chamber embedded the CO2 electrolyzer to overcome the energy barrier compared to gas diffusion electrode system. Finally, the membrane, last membrane, very close to the cathode area, we apply the forward osmosis. This is a major benefit is the dewatering of cathode area and increase the battery efficiency of formic acid. So whatever we apply the poor electrode, if we have the low scale of the CO2 electrolyzer, we can boost the yield of formic acid by help of the forward osmosis, last step. So this is a display the Qatar University, the booth in the exhibition hall. So we welcome to see how can it work using this system. So this is just an example. When you use the generally ion exchange membrane, the Faraday efficiency reaches 30% in terms of producing formic acid in this system. But when you apply the forward system in this system, get that kind of at least double of the yield formic acid compared to conventional one. So when you convert the solar energy conversion ratio, whatever we apply the different style of electrode and system, theoretically they can reach the 10 point something, the percentage. And also we tried to connect with the RED system, utilize their power and the outstream generated from this RED system to help the CO2 electrolysis. So when you apply the purging of CO2 in this system, shows some, the good open circuit potential over the time. So yes, this slide actually the last slide. I want to conclude the comparing the other research group, some result in terms of the solar to conversion efficiency over the durability. So they apply the light directly, or they use the solar PV energy source to convert the CO to the any types of hydrogen or other C types valuable chemicals. But our study is reached 10%, but we have the many feasibility, possibility to increase more the STC value efficiency. Also, other research group only focus on renewable energy like solar PV or direct solar energy. So here, there is no report using out of brine based blue energy. So this research will be start to utilize the blue energy from out of brine to boost chemical energy from CO2, mostly released from SW out of process. I appreciate by the financial support and my collaborator and my research group. شكرا جزيلا for listening to my presentation.
Thank you very much, Professor Dong-suk. Thank you very much indeed.
Thank you.
Okay, so halfway through the case studies, we'd now like to invite to the stage case study number 3, Process Innovation. Innovative desalination projects from Professor Ghafoor Noureddin. Professor Ghafoor.
There you go. Thank you, Mr. Chairman. Assalamu alaikum. So let me first thank the organizers on their head, SWA, for this kind invitation. So I would like to give you one case study of what we are doing from the water desalination group at KAUST in a very short time. Slides, please. The lunch will be delayed by 1 minute. That's fine. So the time the slides show up on the screen behind me, let me start my presentation. So today I'm trying to show a case, one of the technologies we are developing at KAUST. So this technology is based on the principle of membrane distillation, but actually is different. So I will go through some of these, the main challenges we have faced, and then the case study at the end. So this slide is just to show what we do in our group, but because of time constraints, maybe you can find it in our website later on. The main motivation of this work is from this very interesting and very serious study by MIT showing that emerging technologies still have a big potential for some applications. One I'm trying to show you. So the main, or one of the main features for sustainable technology is technology should be scalable. So we are working in the lab, but one of the main things we want to go is for scalability. And then, of course, technology that can handle a different feed, water quality, and here I will give you one example of the brine from desalination. And of course, very high selectivity and good performance. So this is just the principle of membrane distillation in case some of the audience is not familiar with. So we use a membrane that in general has pores, and this membrane is hydrophobic or super hydrophobic to the point that the water production is actually evaporation at the meniscus of the pore size. So at the interest of the pore size, we have evaporation. And how this process is driven is by creating a difference of vapor pressure between the two compartments of the membrane that could be driven by putting two liquids of different temperatures or by applying vacuum on the other side. But one of the main problems of this process is temperature polarization. As you can see, the temperature at the bulk is much higher. This is the energy we put in the system, is much higher than what actually is the driving force, which is at the membrane interface of the two sides of the membrane. So one thing is how to overcome this temperature polarization. So here I just put some pros and cons of this process. So the good thing is that this process is not highly affected by high salinity, and I will show you one example. And it also produces very high quality water because we are evaporating water, and the membrane is actually acting as a demister, so we don't have any contamination on the other side. But we still do not have a proper membrane for membrane distillation. A lot of laboratories, even some companies now, they are producing membranes for membrane distillation, but they are not actually very suitable for that. The second problem is manufacturing of the not only the manufacturing, the design of the module itself. And these are the two things I will talk about today, and this is what we have developed in our group. So the first thing is very fast to show. This is water flux versus salt concentration. So we tried, as you can see, seawater, red seawater, 40 gram per liter, then the brine of desalination, then produced water, 120 gram per liter. As you can see, the permeate is not decreasing significantly. So this is because, as you can see in the left side, this is actually what the thermodynamics dictate to us, is the evaporation ratio is not highly affected at this range of concentration and at this temperature. Of course, if you go very high temperature and high concentration, maybe the decrease is less, but not as significant as we see in the reverse osmosis, for instance. So if you see on the right side, when we use the real produced water or the real brine, after some time, without doing any pretreatment, after some time, actually, we have a drop of the flux. And of course, we do a lot of work with even using very advanced equipment like OCT, etc., to see what's going on the membrane surface. And you can see some SEM pictures and the layer that is produced on the membrane surface. That shows that, you know, there is either pore wetting in some cases, or you have scaling and fouling. But in either case, the water production quality is always excellent, as you can see in the table below. So we have a lot of techniques how to overcome this temperature polarization. As you can see, spacers, maybe photothermal or heating the membrane inside or outside, just how to make the actually the temperature gradient not very significantly affecting through from the inlet to the outlet channel. We have also developed, I'm so sorry because my presentation should have animation. You know, now I have every information in one slide, and I think this is there is some technical problem. This should not be like this, but that's fine. We also have developed, as you can see, the flashed feed evaporation, where we try to decouple heat transfer with mass transfer by not fully touching the membrane surface with full liquid. So we used nozzles to have like a mist on the membrane surface. Okay, now we had to look for the scale-up issues. As you can see in this graph, of course, I will not go into too much details, and the animation is not working. As you can see in membrane distillation, most of the flux is actually obtained at the inlet of the module. As you can, you know, 1% of the total production is produced at the outlet of the membrane. This is because of the temperature polarization. So I'm killing all my energy at the inlet of the process. So we need to overcome this. So we have, or we tried many concepts in doing that, and one of them is what we call smart feed distribution. A smart feed distribution, or I call it also shower head, and I'm sorry again, some of the data is actually behind some of the other images because of the animation is not working, but that's fine. So what we did is we developed a new module that makes the feed water inlet do not go or does not go at the membrane surface straightforward. It goes on top of a plate that is perforated, as you can see there, and the water or the hot water is distributed uniformly throughout the whole module channel. With this way, we are having actually the inlet temperature is almost uniform throughout the membrane surface, and you can see the difference between the normal or the typical design with our design. In the typical design, we are actually consuming 70% of our energy in the first part of the module, while with this new design, which is called the shower head design, actually we have a very uniform process. This is very important for scale up. We did some, what we call this optimization system to see the percentage of how much liquid water, the feed, goes on the surface or underneath the plate, which is directly into the membrane surface. This is what you see here. One means the full liquid is going to the membrane, and 0.9 means 90% and 10%, etc. And we found an optimum condition where 90% goes on the top and 10% goes in the front. And we did this in a lab scale experiment, as you can see here. Then our duty is to go beyond that and go for scale up. The second one is the membrane. As I said, there is no specific membrane for membrane distillation. So most of the membranes are hydrophobic, are porous, and there are some limitations on that. We developed a new membrane that actually is not shown in the first slide, but that's fine again. That has different characteristics. So this membrane looks like NF membrane, NF kind membrane, where we put two layers. One layer, you can see in the right side, this is the substrate, which is porous substrate, which is mostly the same empty membrane, but we cover the membrane with another layer, a thin film, that has much, much less pore size. Of course, with a lot of iterations, we found actually a very exciting results there. So by purpose, I didn't show the membrane or the specification of the membrane and the design itself due to some confidentiality at this point. But the data, as you can see, the rejection is very high, and we found 6 to 10 times higher flux than what we found on, or what we get with any commercial membrane, actually. And in some cases where commercial membrane cannot produce anything, we are producing a good flux. And this is important also to show that, you know, the energy is one of the most important things in membrane distillation if we don't count waste heat. That's why if we run the membrane distillation at lower temperatures, we are gaining at the end of the game, even we put energy into the feed side. And this is what we found, actually. There is another data hiding there, that's fine, I stress on this, but the second graph is to show that actually this membrane is not the same as we have in the commercial membranes, because we did a very extensive modeling, and we showed that the commercial membranes they do not match with the theory which is developed using CFD or using any different. And we developed a new model that use the curvature effect that actually matches our experiments. So this is just to show this membrane is not similar as other membranes, and that's why we have this data. So again, behind the picture there are some few things, but it's fine. Now we fabricated the pilot scale. It's already fabricated. It's on the way to cast. That's why I don't have data for the pilot this time. I would be happy to present it next time. This is the team and that developed this technology that has, again, just to recap, new module design, new fabrication method, and a new membrane in one, and a new spacer, which I didn't present because of time. So, conclusion is this talk is very short. I think my conclusions are already captured. Thank you very much for your attention.
Thank you very much, Professor Ghafour. Thank you very much for speeding up. That was a very valiant effort.
This is what I was told.
Apologies, but we are catching up. Okay, so for the last case study, I'd like to introduce to the stage Dr. Christopher Follows, who's going to speak about the circular economy, seawater brine valorization. Please welcome the stage. Thank you.
Thank you very much, Andrew. So I'd like you to think about this question, what does seawater brine valorization have to do with water sustainability? So think about that. Well, I thank you all for coming, and I thank the organizers for inviting me here today. And about 200 years ago, my grandfather's great-grandfather left his farm in Vermont in the United States because he couldn't earn a living there, and went west. And so some years ago, my parents went to visit the site of his farm where he'd been trying to earn a living. And they found it was on top of a hill, the ruins of this farm. The soil was very stony, not good for much. And it was in the middle of a dense forest where nobody lived. So what's the difference between now and 200 years ago? Why aren't the people in Vermont struggling for life as subsistence farmers? The difference is that technological advances and social changes have made it possible for them to have a very much higher standard of living. They've got a lot more disposable income. And that is really what brine valorization offers us. So I heard Professor Frauenfelder talk about how innovations could give a 10% reduction in the cost of reverse osmosis desalination. If we want to have a 50%, a 100% reduction in the cost of desalination, the way to do it is to find another source of income. Let's see if this button will do something. All right, so here is a graph you've actually seen once already today in a very small form. This is plotting the value of components in seawater versus the amount of them that are there. So many people have done different versions of these graphs and put fairly arbitrary lines across them to say, what's worth extracting and what's not worth extracting. And what I like to do is multiply the two lines together to get a value for the total amount of material that's there. So this is just rearranging the atoms, not adding anything new. And you see a few things stick out there. This is not even doing any changes and putting excess energy in. So these are the easiest things to get. And this is showing everything that has more than $1 worth of value in 1,000 meters cubed of seawater. And I want to focus today, because our goal is to realize value with the things that are at the very highest technology readiness level. So we're doing it with a lot of different things, lots of research into fundamental ways to get new things, but what's important now is what's at the very highest technology readiness level, what we can implement now in order to have more income, make desalination more sustainable. So we have this graph. We've got these nice columns with different slabs of value for different products. But there are two other questions we need to ask ourselves before we can go and implement seawater brine valorization. The first one is, for each of these products, what's the actual accessible size of the market that we can obtain? Are people going to want to buy that product in sufficient quantities? And the second one is, when we look at our best technology for producing that material from seawater desalination brine, how competitive is our margin to the other sources for those products? So I like to think of this as, we talk about low-hanging fruit, so I like to think of the tree of low-hanging fruit, where we see the ripeness, how high they are, and how big the fruit are. And the two that really stand out here that are worth pursuing are bromine and sodium chloride. So bromine has multiple uses. The market for bromine is expanding now after a big collapse about 20 to 30 years ago. And these are some of the main uses for it. For this region, the most important one is oil field chemicals, so clear brine fluids used in large quantities. Anecdotally, I'm told they would be used in much larger quantities if they were available at a reasonable price. That's things like calcium bromide, sodium bromide, and zinc bromide. And today, the sources of bromine and hence bromide products are very concentrated by a few suppliers. So these come from lake brines, from underground brines, and from bitterns from salt works. Our bromide here in the kingdom comes overwhelmingly from Jordan. The technologies for bromine extraction are very well established. Basically, you oxidize the bromide that's in your brine or your seawater, and then remove that volatile bromine and concentrate it and use it. So historically, the sea has been a source of bromine directly from the sea. So this is the growth of bromine production from the sea in tons per year over the first part of the 20th century. And as late as 2003, there was a very large plant processing 2 million tons per day of seawater in the Irish Sea. This was the Amlwch plant of the Ochtel Corporation in Wales. Now, if we contrast this plant versus a source of desalination brine, like the SWA's plant at Ras Al Khair, there are key competitive advantages to extracting bromine from desalination brine instead of directly from seawater. We're starting with a much higher concentration. Concentration of everything scales with the total dissolved solids in seawater. So that's good. The temperature is higher. These extractive processes work better at higher temperatures. That plant in the Irish Sea did not operate at full capacity during the winter. We have treated water coming out as desalination brine, right, as opposed to the untreated seawater that was going straight into this plant. Basically, all they had was something to filter out fish. Technologies are very established. We have these clear benefits for desalination brine over seawater, and the SWA plants alone could meet the current world bromine production. Second nice, sweet, low-hanging fruit is sodium chloride. So sodium chloride is produced from the sea. About 1/3 of the world's production, which is about 300 million tons per year, is produced directly from the sea through evaporation ponds like these. This solar salt production is spread out all over the world, and it's profitable enough that places like Mexico and Australia are producing solar salt on an industrial scale and shipping it across the Pacific Ocean to East Asia. Desalination brine has clear benefits here also in that we're starting at a much higher concentration. We need a lot less land if we're going to do a solar salt production starting from desalination brine rather than directly from seawater. This higher concentration means that we're also in a better economic position for all the potential downstream industries that would not be economic on their own to extract from seawater, but will be as byproducts of a solar salt production. Higher concentrations, also a better starting point for the emerging technologies that would enable us to replace this very land-intensive solar salt production with processes which have a smaller footprint. So the only downside of this is that the desalination plants are typically not located in areas that are ideal for solar salt production, not because of the weather is good, but because of the high level of development. So usually we build them close to cities where there's a high consumption of water. So it may be necessary to have pipelines, for example, to move brine to a more distant location. So I'm just going to I'm going to finish my presentation today, which I've tried to make short, by telling you about what we see as the next steps in SWA, a project we've been working on for quite some time and trying to bring to fruition, which is to reduce this footprint drastically by using emerging technologies in membrane brine concentration. So instead of having to use very large areas for concentrating and crystallization, we want to do as much of that as possible with membranes that can be fit into a small area. So we've analyzed this project. We've done the engineering for it. We know that it will be profitable, and the idea is to take about 1/6 of the desalination brine produced from a typical 1 million cubic meter per day plant and subject that to nanofiltration, which separates out the divalent ions, giving us a monovalent fraction which can be concentrated very readily without the fear of inorganic scale formation. So we can take that down with membrane brine concentration, whether osmotically assisted reverse osmosis or ultra-high pressure reverse osmosis. Thermal crystallizer, we still need some contribution from this, but the overall energy cost is looking good. And then from the bittern that's left over, the purge rather, after the sodium chloride is extracted, we can extract the bromine. So the final message that I want to leave you with is that there is really no other product that's currently at a technology readiness level where you could just roll something out and make a profit from desalination brine. These are the two. Unless we have those processes integrated downstream with a plant like this. So here's one possibility where we're going on, and after the bromine extraction, we're extracting potassium chloride and also looking at treating that divalent phase, the nanofiltration reject, to extract some other products there. So what we need are to move beyond bromine and sodium chloride are either new disruptive technologies, and we're working on a lot of those, or specifically in the case of something like magnesium, some strategic resolution to pursue something that's not necessarily economically viable. I heard just this week that apparently China has stopped selling magnesium to the United States. So if there are these strategic considerations that are outweighing economic ones, it makes sense to get into some other products. We spend a lot of effort talking about reducing the energy of concentrating brine. That's very important. But also very important is low energy ways of separating brine into different fractions. So thank you very much for your attention. I hope you found that useful.
Thank you very much, Christopher. That was a very interesting presentation. Thank you very much indeed. Right, ladies and gentlemen, we are now going to change the program, or not change it, but we're going to make this, our panel discussion, the last presentation before lunch. So we're going to lunch after this presentation, which I'm sure you'll be very happy about. So what we're going to do now for the panel discussion, Unlocking Innovation, Driving Technology and Societal Impact for Saudi Arabia's Water Future, I'd like to introduce the stage engineer Neil Reynolds, along with his panel, Scott Maves, engineer Chris Thomas, Phil Avantis, engineer Nasser Al-Badawi Al-Adwani, and engineer Ali Bilgath Ali Al-Sahari. Neil, over to you.
Thank you, Adrian. Well, good afternoon, everyone. My name is Neil Reynolds. I'm a consultant advisor at the Saudi Water Authority, particularly working with the Research and Innovative Projects Department. So I'm honored to introduce our panelists, which I'll do shortly, but basically, we're not just focused on water technology. We're here to create an ecosystem for the kingdom, and the plan is obviously to integrate research and innovation into the sector and a country on a major transformational journey. I think you've seen that in the past days, that there's a lot going on in Saudi Arabia, and our department is very much focused on achieving that. So today I'm joined by an exceptional group of panelists who are contributing significantly to the mission of their respective expertise and support of the Saudi Water Authority's vision. Together on our discussion introduced, we will discuss or explore how Saudi Arabia can lead the way in setting up an innovation-driven regulatory and commercial framework, fostering both integration and collaboration to enable transformation in sustainable water technology. So we're going to delve into what's possible and our combined efforts, how they will contribute to the future model that could redefine, I think, sustainable water management globally, balancing cutting-edge advancements and Saudi Arabia's unique environmental and cultural context. So without further ado, I would like to introduce you to Ali Al-Asari, who's the Executive Director at the Research and Development Organization at the Saudi Water Authority. We have Scott Maves from AFRI, a consultant working with us on integration and regulatory frameworks. We have Chris Thomas from Isle Utilities working with us on innovation and venturing. And we have Phil Avantantis from Clarivate, assisting us with IP strategy and insights. We're tight for time, I'm told, because the program, as you know, is delayed. So I'm going to probably generalize a question initially, and we'll see what time then we have left. But I think let's first try and get alignment on a mission. Given Saudi Arabia's water sector is undergoing transformational shift, requiring unprecedented levels of innovation and integration, how can we design a regulatory and innovation framework that not only meets the scale of this challenge, but positions the kingdom as a renowned leader in sustainable water management? So my question is, and I think for you, Ali, particularly also give some context around the authority at the same time. But what unique opportunities and challenges do you see in building an aspirational, fit-for-purpose model that interfaces seamlessly with the regulatory and water industry uplift role of the Saudi Water Authority? And just maybe some snippets there, you can touch on circular pathways. We've got the integration of innovation and regulation. We've got capacity building. So it's all of those things that hopefully will come out of this discussion today. So Ali, over to you. Thank you.
Yes, thanks, Neil. Assalamu alaikum wa rahmatullah. First, Neil, as you know, the research in the kingdom is modernizing. It is a strategy, and especially the research, development, innovation. Today, the question we are asking, what are the impact of this research? As you know, the kingdom has its own RDI national priorities, which is very famous for. Based on that, there is some aspects or integrations for these national priorities for any research arm to integrate with. I'm talking about the economic diversification, how we can get benefited from this research. Today, the question is not to have just a research output like the publications or any outputs which is not usable for the industry, but how we can make impact of this research. So the focus should be on the impact, and this is first and important point I'm always keeping and engaging with my team to follow the impact of their research before conducting any research or thinking about any proposed idea. Innovation, there is a big name for the innovation, but we need to think about the deep innovations. Today, it is not just general innovation, but it is a deep innovation. Especially, I'm talking about the talents and the way we are evaluating our progress and how we can integrate our objectives from the institutional mandate and how we can escalating between the national priorities and the operational tasks and operational objectives and research. The main focus in WATIRAS and what we are doing is the mission-based research. This is what we are focusing on, and capacity building, how we can make our internal people and how we can make training for our people to be talented enough and the individuals to make effect on the research and the research impact on the industry, especially in the water.
Thank you, Ali. And I think when I'm looking around now, the panel, each one of you is involved probably in a different area in terms of, IP, situation awareness, and we've got taking ideas to impact, and we've got AFRI particularly helping us with what that innovation framework could look like. So I think we have the answer on the panel in how we're going to get from idea to impact. So if I could then move on to you, Scott, who's assisting us with putting this framework in place. What are the opportunities, challenges that you're seeing in that respect?
Yeah, I think the challenge for the Saudi Water Authority is addressing a huge extent of complex and uncertain change affecting the water system in the country. If we look forward towards 2040 as an example, through Vision 2030, we have a very different economy. We'll have a different consumer, a very empowered consumer, empowered through smart technologies. On the energy side, there is net zero. Through Vision 2030, there are fiscal sustainability initiatives which could start to put pressure on water subsidies. That if that's dealt with, that will create a lot of change behind the consumer meter. And I think the large, big dynamic is, the impressive force towards AI and intelligent data systems that will dramatically, change water system operations. So I think when you put all that together, what it means for SWA is it needs to essentially manage quite a complex and extensive transformation program. And for the Saudi Water Authority, that's going to require a bit of a balance between enablers and controls. So, on the enabling side, there's a need to engage with quite a large and diverse stakeholder ecosystem, including the government, operating companies, researchers, investors, and it's that ecosystem that will be driving a lot of the forces of innovation that will be required. Besides the stakeholder ecosystem, another major enabler is really through the planning frameworks. So it's within Saudi Water Authority's mandate to manage system planning for the water sector. And I think that means there's a need to extend the planning horizon, to 2040 and beyond, so it can see a lot of the complex change that's on the horizon. And the other challenge for the planning mandate of SWA is to look beyond the traditional supply system to understand the interface between the water system and the consumer and the economy and the energy system and smart city systems and the agricultural systems, because a lot of that change and innovation actually extends outside the traditional borders of the water system. And I think probably the third key enabler is really around data and insights. And so there's an opportunity there for the Saudi Water Authority to almost become a single source of truth and a central source of data and insights to inform the stakeholder community to act as a driver towards innovation. So that's on the enabling side. And then there's also the need to put some controls around innovation. The Saudi Water Authority will be the licensing authority for the operating companies, and as we know, it's unwise to pick winners. Innovation can't be forced, and innovation comes with risk, and it's important that not too much of that risk is pushed onto the consumer, or in the case of subsidies, pushed onto the Ministry of Finance. So what that means then is putting in a control framework to manage processes of innovation. That could include new methodologies for the robust assessment of business cases, business plans, looking at consumer protection arrangements, putting in place more robust controls and standards and certifications in terms of emerging technologies, controls around managing and overseeing and approving the process of testing, approval and deployment for innovation. So I think for the Saudi Water Authority, it's a combination of balancing enablers with controls to affect a massive amount of innovation that has to occur across the system.
If I may interject slightly then, and maybe just press on one more point, is that from my own experience, particularly from the UK, is that we focused on, I'll say, shareholder return, stockholder return, and probably innovation has fallen behind. What's a good example of getting the balance right? Because you talked about the push, you talked about the pull. How do you get that balance right?
I think it's engaging the private sector as much as possible and setting up the regulatory framework so there's not too much of a force to sort of push the risks of innovation onto the consumer. So there's a need to make sure that innovating companies wear a lot of that risk. And in the event that consumers, or in the case of the subsidy, the Ministry of Finance, if they're ultimately bearing a lot of the cost of innovation, including failed innovation, I think it's a need for the SWA to have a very strong control and prudency framework, really to be sure that the innovations that are deployed deliver value for the system and the consumer.
Thank you. I'm going to move on to you, Phil. You were one of the first in the door, let's say, to help us with benchmarking and situation awareness of the authority where we're at, and maybe where we should play in terms of innovation that we can make an impact not only in Saudi Arabia, but also to take that impact to the rest of the world. So please tell us a bit about what you've done and how it's going to set us on a good course for the future.
Sure, thank you, Neil. So just to kind of recap on the value of intellectual property and looking at how to protect the investment and innovation within SWA and the water space. So across all industries, it's now predicted that 90% of the value of an organization is actually in intangible assets. And I think that's not something that's typically obvious in the water sector, given the tangible, physical, natural resources that are being managed and desalinated in particular. So some of the work that we've been doing with Watera and part of SWA is looking at the investment trends, the fundamental research, and really where people across the world in the water-stressed areas are investing in things such as desalination, brine mining, but also ways of fueling these processes, whether it's sort of ultra-high pressure or solar distillation. Some of these trends we're identifying and actually advising Watera and SWA on how to partner what it could be the trend for the future, as ultimately when you're investing in intellectual property, you're making a technology bet for up to 20 years. And as Scott was saying, you take some risk in that. You expect that the conditions in the market will change. But I think the intangible asset opportunity could be in areas that are non-traditional, such as sensors, system designs, artificial intelligence, and to Scott's point as well, it could be the data that is being held within the authority in the kingdom. It may not even be a formally protected asset, but could be a very valuable piece of know-how and trade secret that could be applied to other water economies, even to other industries itself.
No, thank you, Phil. And the other end of the chain now, we're really talking about impact. When I look at you, Chris, you're particularly helping us with taking our ideas into the market, into impact. So give us some examples of where you've done that, particularly in the rest of the world, and how can we adopt lessons learned also to take them into the kingdom?
Yeah, I think there's a lot of lessons to be learned around how different areas have explored how you get impact with innovation and how you encourage adoption. Because if you can't get those solutions adopted, then really you have to question why we're innovating at all, of course, and it all dies in that moment. I'm from the UK. It's a water sector there that's been operating as a private industry with the regulator since 1989 for quite some time. Largely throughout that period, it's been viewed as a success. There's been questions recently around some of the financial controls and the performance reporting in the sector. But it's interesting to reflect on what the regulator has done to promote innovation across the sector and what's worked and what hasn't. Initially, you saw the regulator set very stretching goals to try and necessitate innovation and to encourage it in. Those got more sophisticated, where the regulator then asked end users to start to co-create those goals as outcomes with their customers. And then more recently, they've introduced a real financial stimulus in the form of a grant to try and promote innovation. And what's been interesting about the last example is that it has driven a lot more collaboration between end users and the regulator, between the regulator and the regulated. Previously, it might have felt a little bit more like a sort of a headmaster and school pupil relationship. They're neither really understanding each other's perspective. But the way the grant has been implemented has brought those two parties together. And that collaboration has been really powerful, I think. And so I think when we think about an innovation framework that serves a regulatory agenda, creating that in a collaborative fashion, I think, will be really important, because it draws through the needs of the end users. And in doing so, you can ensure that those end users are then in a position to actually adopt that solution. And there's lots of interesting ways that you can keep close to that end user need. Again, in the UK, one of the examples is that all the water companies there have come together to create an innovation strategy, a lot like MOU have done here. And that just defines in a very clear way where those needs are, so that if you are doing some research or you're an entrepreneur bringing new solutions through, you can be sure that they are pursuing a place where there's going to be demand and where there's going to be need for those solutions. But I think we can look to other sectors for some of these lessons as well. One of the examples I really like is from the world of corporate venture capital, where they take a centralized view in where they're going to invest their money and what opportunities they will put it in, much like we might take a centralized view of innovation. So they'll have an investment committee that makes decisions on where that goes. But those solutions that they invest in need to have some strategic significance to the parent business. And so often that investment committee will ensure that they have an end-user sponsor within the decision-making body to release the funds for that opportunity. And that sponsor is there to say, yes, I'm interested, I'm up for trialing that or implementing it in my company. And when you get that tick, then you know you can release the funds and you can invest. And I think that sort of principle of having that direct engagement, that direct collaboration with end users, and having that run through all the processes and mechanisms that get set up in creating these things and how we create them is really important.
Thank you, Chris. Because I was on a bit of a time warm in there as well, I just want to get to probably one last question that I'm going to ask you. But there is a panel tomorrow also on accelerating technology into the market. So I think a lot of what you were talking about then can also be picked up tomorrow. But I think a final question, sorry that our panel is very short, but if I start with you, Ali, what is the critical success factor for Saudi Arabia to achieving a globally recognized model for water technology innovation? Just.
Actually,
I know the answer to that one, but tell me.
Yeah, no worry. As I mentioned earlier, I think the deep innovation and presence of ecosystem innovation, this is what we are targeting and building currently at Rabiq, to have all the water players in one place. And generally, if we look into the innovation, we are looking into two main initiation or ignition for the innovation. Either it's coming from mission-based output, or from the problem solving. And in Rabiq, we are targeting to have all people in one place so that we can hear the stakeholders, what they have. In addition to that, parallelly, we are developing and building our internal capacity, supporting the talents to attract either internationally or supporting the local academia by having a program supporting the graduate studies, especially master and PhD degree, because it's very well known that more than 60% is coming from this fresh people.
Thank you, Ali. Scott?
I think it's probably engaging and empowering the diverse stakeholder ecosystem and giving them, an extent of focus towards some sort of a common sort of research mission.
Bill?
I think it's kind of tailored business plans across each technology area. So intertwining the business, the innovation, and the intellectual property strategy. Some things will be created in-house. Some things will be with innovative startups. Other technologies might be licensed in. So I think picking those strategies and being completely aligned.
And lastly, Chris.
I'll repeat what I said earlier, and I think close collaboration embedded throughout the process with the end user is critical.
So collaboration is the key word I'm hearing here. So, well, thank you, esteemed panelists. I'm sorry that we had such short time, but for members of the audience, I'm sure you'll be about. If you want to have a conversation with this group, please do that. Thank you very much. Thank you.
Thank you very much, Neil. Thank you to all your panelists for another enlightening session. And yes, as Neil said, everyone is around to have further discussions throughout the day, today and tomorrow. So we are now actually going to do a very special series of announcements of MOUs between Saudi Water Authority and stakeholders in the water industry. So I'd appreciate if you could all stay in the room just to witness these very important and very special MOUs that we are going to sign today on the stage. The first MOU is between Saudi Water Authority and Takamul, water sector accreditations and human capital improvement, For Saudi Water Authority, I'd like to invite the VP of Sustainability, Mamdouh Al-Shwaibi, to the stage, and the Takamol representative, Fozan Al-Mosheibda. Thank you very much, gentlemen. Congratulations. Mamdouh, if you'd like to stay on the stage for the second MOU. Okay, so the second MOU between Saudi Water Authority and the Khebra company. The title is Enhancing and Developing Academic Programs by Using Advanced Technologies. Mamdouh Al-Shwaibi is representing Saudi Water Authority. From Khebra, please welcome to stage Ms. Rawan Al-Mokhbel. Thank you very much indeed. Congratulations. For the third MOU, this is between Saudi Water Authority and WCT Bahrain and Tahliya Water Treatment, titled Brine Mining Development. For Saudi Water Authority, please welcome back to the stage VP of Research and Promising Technologies, Engineer Tariq Al-Khafari, and from WCT Bahrain, Director Mr. Tony Chan. And this is also witnessed by the Consul General of Malaysia, Mr. Roslan Sharif. Well, very welcome, sir. And also Tahliya Water Treatment Representative, Mr. Isa Al-Dosari. Thank you, gentlemen, and many congratulations. The fourth MOU is between Saudi Water Authority and IAU University. Saudi Water Authority, Engineer Tariq Al-Khafari staying on the stage. The title is Renewable Energy Development. And the IAU representative, Dr. Reem Al-Jendran. Dr. Reem, please. Congratulations to yourselves. Again, IAU University. The fifth MOU agreement between Saudi Water Authority and Tabuk University, titled Supporting Innovators in the Water Sector. Engineer Tariq Al-Khafari and Tabuk University, Dr. Omar Abulawi. Congratulations again, Tabuk University. The sixth agreement between Saudi Water Authority and NWC Company. The title, Supporting Innovators in the Water Sector. I'd like to welcome to the stage the NWC Executive Vice President, Engineer Raid Al-Rashid. Shukran jazilan, mabrukatain, NWC. The seventh MOU between Saudi Water Authority and Saudi Irrigation Organization, titled Strategic Collaboration in the Water Sector. I'd like to invite to the stage the SIO President, Engineer Mohammed Abu Zaid. Okay. Ya mabrukatain. Thank you. Shukran. Okay, thank you, sir. The next one, number 8th MOU between Saudi Water Authority, Saudi Water Authority and MOU Center, supporting innovation and entrepreneurship in the water sector. I'd like to invite to the stage the MOU CEO, Engineer Fahad Al-Dosari. The 10th MOU. Oh, from Mike. Okay. Could you please come back to the stage for a picture, please? Engineer Fahad Al-Dosari and your other colleague from MOU. Thank you again. The 10th MOU is between Saudi Water Authority and Princess Noor University, titled Sponsorship Agreement for Water and Energy Projects. Engineer Tariq Al-Ghafari and Princess Noor University Vice President, Dr. Fazia Al-Amrah. Dr. Fazia. Thank you, sir. Engineer Tariq Intada Shwaya, do we have to repeat the third MOU? Just to repeat, because not all representatives were here. This is between Saudi Water Authority and WCT Bahrain and Tahliya Water Treatment, titled Brine, Mining and Development. So could I have to the stage, again please, WCT Director Dr. Tony Chan, Consul General Malaysia Mr. Roslan Sharif, Tahlir Water Treatment Representative Mr. Isa Al-Dosari. Is there anyone else we've missed? Thank you very much, ladies and gentlemen, distinguished guests, Honorary Consul. That concludes our very special MOUs for this morning between Saudi Water Authority and our various stakeholders. We are now going to lunch, and what we'd like you to do, if we can, to make up time, is if you could make lunch to 30 minutes if possible and come back here at 10 minutes to 2 p.m. 10 minutes to 2 p.m. if you can. Enjoy your lunch, enjoy your networking, and we'll see you for a packed afternoon proceedings. Thank you very much. Okay, ladies and gentlemen, welcome back to the afternoon session of today's conference. I hope you're all having an enjoyable time. So what we're doing today is, at the conference, we're introducing various new technologies for the first time in the Kingdom of Saudi Arabia. And for a number of technologies we're going to be showcasing now, I'd like to start with GI Aquatech, the new era of wastewater, and introduce to the stage engineer Fahad Al-Fahad.
Thank you. How are you doing? Thank you. Assalamu alaikum wa rahmatullahi wa barakatuh. Marhaban. Good afternoon, everyone. According to the UN nation, around 80% of the globe lacks access to sanitized water. At GI Aquatech, we put innovation, sustainability, and collaboration with great people of vision at our core of what we do. Throughout spending all of our time and resources to solve this global issue, we have came up with a new generation of wastewater treatment, something that we believe will shape the future of wastewater and reuse for our globe. Let us watch this video that will give you an idea about what we do and how we are going to change the future of wastewater management in Saudi Arabia and in the world. Our non-biological system utilizes G-Nano, which is a nanomaterial made of clay, to remove all the contaminants of wastewater and make a full treatment that is suitable for use and reuse. We basically developed the G-Nano to be environmentally friendly and to be environmentally balanced in order to produce a full treatment that removes the biological and also the non-biological loads like heavy metal from wastewater. This complete treatment happens in 3 stages. The first stage, where the G-Nano is mixed with the wastewater and captures all of the contaminants in the wastewater. Then it settles it in a way that is very effective and very efficient. The entire process will not take more than 20 minutes until you get a clean water that is suitable to be reused in irrigation. The old methods of wastewater are extremely wasteful and lack the power that we are offering. This allows us to put so many values into the next generation of wastewater industry, offering a plug and play system for the first time. The minute you install your unit is the minute you get a full treatment. As you can see, the system can be mobilized. It is a breakthrough innovation. It can take treatment from one place into another. Old methods like the activated sludge, which is great, needs 2 months until it develops its biological system. Our system works instantaneously. It saves around 80% of the power consumption in comparison to the traditional wastewater methods, and it saves around 90% of the footprint that is utilized in wastewater treatment in traditional methods. We have a vision for the future to make wastewater treatment plants appealing. We want it to look like something that you would visit, actually. This development and our breakthrough allows us to play in areas that traditional and conventional methods could not be very effective. We treat the domestic and industrial, but also we treat the slaughterhouse wastewater, we treat the concrete wastewater, we treat also very challenging pharmaceuticals and industrial wastewater that fails to be treated in the conventional methods or faces huge challenges to be actually effective. All of those segments offers a 360-degree into wastewater treatment and management. The solution is very simple and attractive. It can be deployed and employed at the same time to tackle all of those segments effectively and efficiently. So far, we have been very successful. This is not just words and papers. We have implemented the solutions in different areas. For example, in Dir'iyah, in Samhan Hotel, we have a unit that treats the black and gray water coming from the same hotel and give the TSE, the treated water, to the same hotel for reuse in irrigation and flushing. In Mecca al-Mukarramah, we have literally treated the blood and turned the blood into water. It is something that we are very proud of because it solves a huge issue in a seasonality aspect. We are very proud to welcome you to join our journey in reshaping the future of wastewater, not only in the kingdom, but worldwide, to serve those 80% of population that lacks the sanitation services. Thank you so much for listening to us, and thank you. Thank you.
Thank you. Thank you, Engineer Fahad. Clicker is there. Okay. Okay, thank you very much indeed. So next to the stage, I'd like to invite Beijing Enterprises Water Group Limited, based in Hong Kong, who are going to speak on BE Smart Water Systems. I'd like to invite to the stage Bin Liu, please. Bin Liu, to the stage.
How does it work? Good afternoon, ladies and gentlemen. My name is Bin Liu, and I'm from BWG, Beijing Enterprise Water Group. And we are a comprehensive water service and environmental service provider based in Beijing, China. Our fields include water supply, wastewater treatment, and water environmental restoration. Sorry? Excuse me? How does this work? Okay. Okay. Don't press. Okay. Okay. Okay. Okay. As the biggest water service provider in China, now we are operating more than 1,000 wastewater treatment plants with a daily treating capacity of over 40 million tons per day. Through years of experience and hard working, we build and we expand and we upgrade our wastewater treatment plants. But after a while, we realized that some of the urban water environmental problems still remains the same, because sometimes the problem is not within the treatment, but in the drainage pipe area, in the drainage pipe systems. Inflow and leakage in the drainage pipes, combined sewer overflow, and illicit connections and illicit discharges. Those are the main reasons today for us, for the urban water body degrading. And also, they can cause serious threats to our daily operation of our wastewater treatment. They can bring unexpected fluctuations in the inflows. Sometimes it can even cause failure in our bioreactor, in our biotanks. So technically speaking, we need constant sampling and constant monitoring in our drainage pipes. For this reason, here we present our new product, our BE Smart Monitoring System. It adapts the traditional monitoring technology with the new IoT things. So this product includes 3 parts. First, it's the data acquisition module, the sensors. They acquire data directly from the drainage pipes. And then the data will be sent to the data transmission module, the RTU unit, and the sensors kind of manholes. At least a kind of manholes in China, but we can do the customization on demand. And also, the sensors are very reliable and durable. We develop most of our sensors by ourselves, catering to the harsh environment in the drainage system. Take the nitrogen and COD sensors, for example. It is able to monitor the nitrate nitrogen and the COD at the same time. It is based on the absorptiometry method, so it gives the sensor very high resolution, and also it is very low maintenance requirement, since there is no extra agent needed. And we also have it in very compact design, and we have it in very sturdy material and solid material. And it is suitable for long-time monitoring in our sewage system. And finally, thanks to China's manufacturing abilities, we are able to make this sensor relatively cheap. And it's cheaper, it's around 40 to 50% cheaper than most of the product on this market. And also, the application is very adaptable. Now we use this product, this system, mainly on the drainages, for the sewage drainage and for the storm drainage. But with certain modifications, it is also very suitable for the water supply and the gas pipeline leakage detections. The basic logic behind this product, behind this system, is just data collection and data transmission and data analysis. So we just need to monitor the pressure change or related parameters along those pipelines. Then we can narrow down or even locate the leakage point or the leakage area. And also, there is some built-in functions and built-in algorithms in our cloud system. The tracing program, it allows us to trace back the illicit connections, the illicit discharges, especially the industrial illicit discharge. And we also have this warning program where this cloud system will constantly calculating the pollution load, the volume of the inflow in our wastewater treatment plant. So if there would be a peaking, if there would be an overload or a lot of industrial discharge in our draining systems, it will send a warning sign to our wastewater treatment plant. So we have time to react and even take emergency plans. With all the programs, all the functions, it's easier for us to make data-driven decisions based on real data, based on live data, not merely based on our daily operation experience. There are multiple applications where we made our daily operation much easier. Take the city of Yibin, for example. It's a city in China, it's a small city, and the wastewater treatment plant suffered from an illicit industrial discharge. So we installed dozens of monitoring devices upstream in the pipelines. With data analysis, we managed to trace back the main source of the industrial discharge. we help the government to regulate those factories, to regulate those discharges. And even if there are still some remaining industrial discharge with the warning signals, we can always take time and take emergency plans before it is too late. It is just a simple example that how little investment we can make to make our life easier. By applying the smart monitoring system, we can make our underground drainage pipes much easier to see, much more visible and much more accessible, and to ensure the well-being of our water body and the smooth operation of our wastewater treatment plant. Thank you very much for your attention.
Thank you very much, Mr. Bin. So I'd like to next invite to the stage Shenzhen Water Environmental Group Intelligence Laboratory on the new generation water testing steward. I'd like to invite to the stage Yao Qin. Yao Qin, please. Mr. Yao.
So, distinguished experts and scholars, good afternoon. It is a great honor to be invited by Saudi Water Authority to represent Shenzhen Water and Environmental Control for the global launch of our intelligent laboratory in Jeddah today. I'm greatly impressed by the contents shared today. The Intelligent Lab is an integrated IoT equipment independence developed by our group, which carries the innovation spirit of our city, Shenzhen, providing a new digital mode for water quality testing. Shenzhen is a megacity in China with a huge population density. Meanwhile, it serves as an innovation demonstration of sustainable development. It is duty and mission for our group to serve as a water steward for thousands of households through providing excellent service to this city. We are facing challenges toward water quality testing, especially in demand increase, quality improvement, and the transition from traditional to digital operations. We need to build economical and intelligent laboratory for future development based on our demands from our daily cooperation. After 3 years of R&D, today we are presenting our Intelligent Lab. It's an IoT equipment designed and ensure testing quality and efficiency while meeting the requirement of a new smart water management mode. We call it the new generation of full-process water analysis steward. It will bridge the gap between tradition and the future, ensuring needs and supporting the development of smart water management. This is the world's first pre-educated IoT integrated multi-indicator synchronous water analysis intelligent lab. We have made great effort to address its adaptability, stability, and reliability. First, we have developed a water quality multi-indicator synchronized detection system. It can rapidly complete the automatic detection and generate results. It can be tested 26 quality indicators for produced water, or 16 quality indicators for wastewater within 1 hour. This system greatly improves the detection efficiency and enables unmanned detection. Secondly, we have established a digital equipment control system for the entire process. Based on the technologies such as RFID and machine vision, it enables precise control of testing process and the traceable results. This efficiently solves the difficulty of standardizing in water analysis. Thirdly, based on the construction of standardized central control system, we have built an IoT system with one interface and two platforms. This IoT system integrates with an independent intelligent lab management platform that links with the smart water platform. The system is also integrated with another platform that links with limits water analysis and measurement in system. This enables automatic assignment of tasks, uploading of test results, sharing and interaction of big data, and supporting prediction and pre-warning of emergencies. At the same time, the Intelligent Lab aims at green and sustainable development. It has achieved remarkable results in reducing consumption. Compared with traditional labs, it can be reduced energy consumption, personnel, footprint, reagents, and waste liquid, and time consumption up to 80%, making our device a strong support for efficient operations. The most popular feature among kinds is that the lab is designed and assembled in a modular way, which allows for rapid assembly in minutes based on the client's needs. The lab can be set up in a 22 square meter space, making it suitable for various scenarios, including water supply, drainage, and industry wastewater treatment. As a new generation of water quality testing equipment, the Intelligent Lab has independent intellectual property rights with world-leading novelty checking reports available for your needs. It has also obtained relevant certification and accreditation from Chinese Academy of Engineering. The Intelligent Lab brings a new definition to the stability, efficiency, and connectivity of water quality testing equipment, leading the further upgrading of standards for water quality testing IoT equipment. The Intelligent Lab has already attracted significant attention worldwide. Like our global counterparts, we firmly believe that the Intelligent Lab will bring brand new value and benefits to the digital and the green transformation in water industry. We believe our digital device makes the future accessible. During the exhibition, we warmly welcome all participants to visit our booth for detailed discussions. And we also invite global peers to visit Shenzhen in future for exchanges and cooperations. Thank you.
Thanks to Dr. Yao. Thank you very much. So that's our quick-fire innovation speakers to kick off this afternoon's conference. We're now back to another panel discussion, which is discussing desalination innovation, CEO leadership in tackling the water energy nexus. Well, I'd like to invite to the stage Dr. Sarper Sarp to head the discussion. Sorry. Dr. Sarper, would you like to come to the stage, please?
Thank you. Oh,
thank you very much.
Very, very loud, sorry. Thank you so much.
I'll let you introduce your panelists.
Of course, thank you. Welcome, everyone. I'll actually stand here for the guests. My name is Sarp. I work for the Saudi Water Authority. I'm a senior expert. I would like to introduce our esteemed panel, and they will come to stage. Engineer Khalid El-Kouarshi, he's the Chief Executive Officer of Saudi Water Partnership Company. We have Engineer Abdullah Al-Zuwaid, and he's the Chief Desalination Officer of Saudi Water Authority. We have Benjamin Tam. Mr. Tam is the CEO of IL Utilities. We have Mr. Walid Khodri, and he's the trustee on Water Environment Federation, an multinational company. And we have Mr. Simon Zosi, he's the VP of Huawei, and he's currently working in the Saudi. Please.
هناك عشان صورتك تحت صورتك تحت.
Good afternoon. We are a little late today. Sorry about the delay. So welcome to our conference, and thank you so much taking the time and coming here to talk with us. Again, we talk a lot about in this conference about the technology, how we can apply the technology, how we can introduce the technology in different water systems, but we rarely talk about what is the strategy, looking from a CEO point of view, and what is how we can actually convert technology, implement technology coming from innovation to actual systems. So I would like to start with Engineer Khalid. Welcome, sir. I would like to ask you about, you are the head of partnership company, and I want our guests to understand what is the role of partnership in facilitating new innovation into desalination.
Thank you very much, and I appreciate SWA for having this conference and having me here. And we're sorry for changing the times. We were supposed to start 2 o'clock, but there is some circumstances that caused this delay. And I know many of you waiting these sessions. The Saudi Water Partnership Company is the principal buyer of water in Saudi Arabia, and also responsible of procuring infrastructure, desalination, sewage treatments, pipelines, strategic reservoir, through PPP, public-private partnerships. If we come to the desalinations and what is the role of partnerships, if you look at before 2016 till today, you see a lot of things related to sustainability. That you have an infrastructure is really have a meaning of sustainability. For instance, an example, if you see today, everybody talking about the specific power consumptions of cubic meters. In early days, you remember that we are just looking to provide services, but without looking to this. Also, from 2016 till today, the reduction of the cost of cubic meters goes down more than 40% less compared to 2016. And the reason behind this is that the efficiency of producing water with a lower kilowatt-hour consumptions, which means that if you reduce the kilowatt, you reduce the emissions. If you reduce the kilowatt, you reduce also the raw resources which you are drawing from the. And this is a mandate by a document we sent to the market saying that you should not exceed more than cap of energy. We start with a cap of 3.5. I can tell you today, the competition, they reached to 2.61. And if you calculate one beyond 2016, it was the range of consumption of cubic meter above 4.5. I can say average 5 to 6 kilowatt hour per cubic meter. So you see that how much the reduction, the partnerships with the public that being achieved today, And if you translate it to the environment and sustainability, it's a huge number of money and reduction of emission of CO2.
Correct.
That's from desalination. In addition to this, the partnership, we start mandating or allowing to use the renewable energy, including solar. We have 3 projects right now, having approximately 30% the energy consumption not from the grid, it's from the solar, which another way of sustainability using the green energy compared to the normal fossil energy. And so on. We keep pushing for environment and sustainability, and we believe in future we can use the byproduct coming from brine, like what Siwa nowadays is doing, like a magnesium which is done in Shuaiba 5. It could be later on with the partnerships, enhance this and bringing the all competitions from international. In this way will help for further sustainability.
Thank you. Yeah, I think Desalination has a great story to show last 20, 30 years how innovation affected everything from energy consumption to environmental impact. Engineer Abdullah, thank you for coming, sir. As a CEO or a Chief Desalination Officer, what do you think the role of a CEO could be in a company, in a desalination company, to foster the innovation? So we understand from the partnership point that it's important, so we have to gatekeep, we have to understand what is coming and we have to approve. Within the desalination production, what is the way to foster this innovation within the company? What do you think, sir?
Thank you, Dr. Sarib. Thank you for the colleague for participating in these sessions. Before I answer your question directly, I got two facts that I'd like to share it with the colleague in here. One related to the power consumption. In order to reduce the footprint for the emission, carbon emission, we have to focus basically and improve the efficiency of the power consumption or the energy consumption is one. The second fact that 70% or more than 70% of the globe air surface is covered with waters, while the fresh water is only not more than 2.5% of the fresh water that is accessible. Therefore, we do believe desalination is a key solution in order to address the world water scarcity. And for that, it is very important to make the desalination technology affordable. We have to make it accessible, and we have to make it also sustainable. Therefore, we are very much strong belief that innovation is the way forward in order to make it accessible, sustainable, and also available for everybody. Therefore, in order to foster an environment for the innovations, we have to cultivate sort of a culture in order to move forward in this innovation. One of the important things for this culture is to encourage people to come up with an experimental trial without fear of failure. The second concern is also to make them incentivize in a way or another by rewarding the innovative idea. And where we are in here, this is distribute part of the function that we do believe in SWA as a solution to move forward with the cheapest price or the innovation cultures where we are having. And as a result of this, we could achieve a lot of success story within the Kingdom of Saudi Arabia, as SWA is the world leader in the desalination industry as of today. So we get into what we call it a fuel liquid displacement program. And as a result of that, we could save more than 37 million tons annually from the emission control. The recent number for the consumption per cubic meter in the last plant where we have it produced is not exceeding 2.35 kilowatt per cubic meter. This is the last project which we have recently constructed, where we can see a dramatic drop in the power consumption comparing with what we have been doing it before. Moving forward, we are targeting to utilize more than 30% of the power consumption in our plant using renewable energy before 2030, moving forward to eliminate all the thermal technology, desalination thermal technology moving in the RO. And for that, we are setting a new era for the water sustainability, moving and believing that innovation is the way forward. Thank you.
Thank you so much. I must add, as a researcher in Vitira, we really enjoy having access to the plants, because without having those plants, our innovation programs or our innovation experiments or pilots, we wouldn't be able to test them in the real situation. So I would like to thank you, because we had many plants, many pilots in the plants.
Thank you, sir.
Ben, you've been working here for a while in the Saudi, and you're very familiar with everything. What do you think, how we can, as a Saudi water sector, Saudi water environment, how we can improve innovation? Especially now we are transforming Saudi water, and we are transforming from SWCC to SWA. So what do you think, what are your opinions to make that transformation the best way possible, and include innovation as much as we can in this transformation?
Yeah, thanks, Sab, and thank you everyone for having me here. The first thing I wanted to say was around this session, actually, and framing it. Because as CEOs or as leaders in this room, some of the biggest challenges you have are around the decision-making about where to allocate resources to. And often, and you may recognize this, when you're given reports, there's a glide path of how we're going to get there, and there's often a box at the end, which is, we're not sure how we're going to do this box, and that's generally your innovation box. And that's the one where I think is the hardest as a leader to understand where to allocate the right amount of resources. Now, fortunately, at SWA and in the Kingdom, the understanding of the imperative need around water, but also the prime opportunity to become and continue to exist to be a leader in the space, means that the ecosystem has been maturing. And so there are two areas, and I know we have a short amount of time today to answer these questions. The two areas are come into two buckets, or maybe three. First is around de-risking innovation. So at SWA, there's a very strong history of research and development and piloting. And just to that conversation there, that link to be able to do fundamental piloting and research, but get it to scalability. And I think any organization who can do that will have a step ahead against any other water, utility, others trying to take a risk, take moves further. The second one comes around the financing of all of this, because there's a lot of commercial opportunity and value which gets lost, or if we're in a water conference, gets leaked away somewhere through this. And I believe that one of the ways that SWA will become leading is forging more of the path around commercialization and possibly being the first in that corporate venturing space for a water authority. So that doesn't happen globally. The water authorities are very cautious. Their outlook, although is very long, tends to be quite short in terms of the horizon, and they're leaving a lot of value on the table. One way, what would this look like? This could look like an entity which is part of the ecosystem, which is able to take some of that risk by attracting other investment in, but also harnessing the massive ability to do those pilots and scales and taking the advantages of that to scale technologies through. And I think that could be world-leading, but also attract much more investment in. And the third one is the communication part. This conference is amazing for the amount of people it attracts in, but also in water, we're talking largely into a silo. Like if anyone here doesn't know about the water challenges, you're probably in the wrong room because we've been talking about them for a long time. This is about taking this room and SWA's role in the world and talking to other sectors, harnessing the ability of the Saudi Water Partnership, Saudi Water Authority, for the Ministry for Agriculture. Talking about these topics in other sectors brings that diversity. I think that enhances that innovation ecosystem.
Thank you so much. Walid, you're here with your Water Environment Federation hat, and thank you for being here. Since we started talking about, investing in water and talking about economy, we always come back to circular water economy and how we can make it circular, how we can leverage desal, and especially innovations, to advance the concept of it. So what do you think the leaders, what do you think, first of all, how we can leverage innovation to improve the circular water economy?
Excellent, thank you for having me. It really fits very well, desalination, reuse, and circular economy. Just one word about the Water Environment Federation. So it's one of the oldest associations and largest globally for water professionals. So it was founded in 1928, so almost 96 years, and we have 36,000 professionals around the world, 75 associations part of it. So we look at water a little bit holistically on all the technologies, and our mission is to have water, life free of water challenges is our mission. And to get there, we have 3 strategic goals. One of them is the water circularity, like the circular water economy on the water side. And Christopher, I think yesterday he mentioned that as Saudi has played a huge role in desalination and became the dominant in the world in desalination, I think it's a very good position for Saudi to be also on the reuse side, because the circular water economy needs reuse, and there are 2 aspects. Of course, the water part. So you will be withdrawing less water from the environment if you're recycling water, which means less competition with other usages as potable, agriculture, and so on. But also you'll be polluting less, because if you're using reuse technologies, advanced membranes, you will have less challenges on the environmental, because you're disposing less pollutants. This is one side of how desalination fits in, and membrane technologies fit in the circular water economy. On the other hand, you can recover all the nutrients, like in terms of brine, but also in terms of wastewater, you can recover some of the nutrients. You can treat emerging contaminants. So there's a lot of things today that go hands in hand between, water, reuse, circular water economy, and desalination technologies. So it's a very good opportunity.
Thank you. Just to follow up a short one, what would you suggest to the leaders in Saudi? To what role should CEOs, for example, in Saudi play in order to implement these circular economy?
I think it works for Saudi, but also globally as a CEO. And first thing is very important is adoption, because we're always risk adverse. We try to avoid risk, so encouraging adoption. So in your plants, in your industry, because you cannot make change unless you try and take some risk. So adoption is really key. Second one is investments. So you have to reallocate, as Ben was saying, you have to reallocate some of the funds for investments, because you cannot expect things to happen without investment, piloting, R&D, and so on. And the most important part is collaboration. No one can solve the water challenges alone. So we need to work all globally, hands in hand, and try to foster these real relationships where we embed the circular water economy in our day-to-day activities.
Thank you so much. Mr. Simon, so we are talking about a lot of different things, different aspects of desalination. Of course, none of them can be, applicable if we don't have a, good understanding of digitalization, handling data, managing the data. So, as as Huawei vice president and leading the innovation, what is Huawei's strategy and innovation approach when it comes to water systems and their digitalization?
Thank you very much. And thank you again for having the chance to be here. And Huawei is a global leader for the ICT solutions. And when it comes to the water industry, we have been exploring on this industry for a long time. Some people may be strange and curious to ask, what are you doing in the water industry? We are handling the most important data. While the sensor collects a huge amount of data, while we collect all the weather forecast data, we put all this data into most important platform, what is based on the cloud. The cloud is a strong platform with a big data capability, with the AI capability. So whenever we collect all this data, we'll put into our large language model. And we keep on training the model so the model can play a very important role in different scenarios to support the decision makers to make the correct decision, to make even the weather forecasting, to make the photo analysis. So while we are working with our ecosystem to produce industrial solutions for different scenarios. This is one thing we're doing. Another thing is, while we are working with many water-related customers, we see they have a huge amount of silo systems. Different silo systems, they cannot talk to each other, and data cannot be shared. And it's very difficult for us to realize a common decision, on the data level. So what do? We enable our friends and our ecosystem partners together to realize the real big data for the industry. To make the things short, as Huawei, we believe the cloud and AI will play a very important role in the smart water management, and we will be part of this. And we'll be very happy to work with all my ecosystem partners to support the kingdom to make the water industry to be more smarter.
Thank you so much. I'm aware of some of our guests has flights to catch, and we are a little bit running late. So I would like to thank you all for coming and for your valuable time. And hopefully we can continue later on this discussion on different aspects of the desalination. Thank you so much.
Thank you.
Thank you, Sapa. Thank you to all your panelists as well. Much appreciated. Thank you. So while we're getting off the stage, we're now going to introduce the third theme of today. Now, as a sustainability campaigner and speaker and writer, we stress the importance of having a systems approach, a holistic systems approach of economy, society, and environment. The triple bottom line of people, planet, and profit, not just profit alone. And that sort of gives me a nice introduction to our next theme, which is wastewater treatment. Water and wastewater treatment, reclamation, and reuse technologies. It's perhaps the least glamorous side of the water industry, but a critical factor in itself. And no better to start with a keynote speech on this. I'd like to introduce Mr. Glenn Deger, who is... Sorry. Okay. So I was going to introduce Mr. Glenn Deger, but apparently he's not just ready. We've got Glenn online. So while I'm waiting, let me just give you a little bit more information, because it came up in the panel last night on Neil Reynolds asked the panel what was meant by sustainability. And the panelists obviously gave from a water perspective. But my holistic view on sustainability, the three pillars, economy, society, and environment. And there's two key fundamentals in this, which is what you do in one pillar will affect the other pillars altogether. What you do in your economy will affect society and the environment. And critically, what you do to solve any problems in any one pillar, you've got to look at the whole system put together. You cannot solve problems on its own. And so everything is linked. Everything is a system. Everything is inextricably linked. And this is why personally, and it's only a personal opinion, it's not the view of the conference, I sometimes think the net zero mood is just a single obsession on one factor only within this whole system, and one issue within that factor, carbon dioxide, and one solution, net zero. You've got to look at the whole thing put together. That is what sustainability is. And in the water industry, you are looking at reuse, we're looking at desalination, we're looking at many different factors as well. We're ready to go. So there's a short interlude, speaking off the cuff, but give me my chance to say what I believe, and I'm passionate about this concept. So over to Mr. Glenn Deger, who's going to be talking about transforming water management reuse technologies in the circular economy. Glenn, you'll be online. Over to you.
Well, thank you very much. I'm sorry that I'm not able to be with you due to some circumstances, but very pleased to be able to make this presentation. You introduced the topic of wastewater reuse by saying it's not very glamorous. That's a matter of perception. So one of the advantages of water reuse is that it is the most secure water supply. And when you look at it from that perspective, perhaps one thinks that it is a desirable thing. So let me start with some key messages. So I have 5 key messages that I want to deliver to you, and then I'll expand somewhat as we go forward. So the first key message I've already made, but let me make it in a different way. So reuse is an important component of a balanced and resilient water supply. Many utilities around the world in water-short areas are finding this to be the case because it is the most reliable water supply as long as you're providing water to your service public. If you have water supply, you have wastewater. And it is balanced then with other water supplies, but it is part of a resilient water supply portfolio. Secondly, technologies today are available to produce a product water of any desired quality, from basic irrigation to potable to the water needed for high-tech industrial processes such as the semiconductor industry, which requires some of the cleanest water any place on the planet. Technology is not the constraint. Cost. Many look at the cost of treatment for reuse and become concerned about that cost. And I think you were, in introducing, you were talking about the need to look holistically. The cost for reuse is offset by the avoided water supply cost and wastewater management costs. You have to look at the entire picture when you're looking at reuse, because reuse addresses 2 issues. First of all, it's providing water supply, and as you do that, you're offsetting those costs. It's also providing wastewater management, and as you are reusing, you're also offsetting other costs for wastewater management. So it's very important to look at the full picture when you consider the cost of reuse. Number 4, water reuse professional practice is well developed and well understood by experienced practitioners. And in my subsequent slides, I'm going to spend a bit of time illustrating this. So it's not simply a matter of selecting technologies, but it's a well-developed, integrated area of professional practice that's applied here to achieve reliable supply of water, and water which is safe both for the uses and from an environmental perspective. The 5th item deals with public acceptance. This has been an issue for decades. The suspicion that the public will not accept reuse water, particularly potable reuse. This is also an area where there has been significant advance in the last 2 decades, especially the last decade. And there are 2 critical areas here. The important words here are legitimacy and credibility. The experience, as well as, quite frankly, research in this area, demonstrates that the public will accept reuse if, first of all, they believe that the practice is legitimate. That is, that it is possible to produce and to safely produce water for reuse based on the overall practice, which is the technologies, but how it's applied. The second is is credibility for the organization that's implementing it. So it's one thing for it to be possible, which is about legitimacy. The second is whether it will be delivered, which is the credibility of the implementing organization. And again, there's quite a bit of knowledge in this area. So let me then go on to the next slides and go through some of the specifics. So first of all, the level of treatment depends on the extent of human contact. This first, and I'm going to build a table here. This first slide has the lower line of that table, where you have limited or no human contact. This can be through restricted irrigation or dust control or a variety of fairly typical uses where that's not coming into consistent contact with humans. Here, basic wastewater treatment and basic disinfection is generally sufficient to protect public health. And here we're talking largely about disinfection, about exposure to pathogens. The next level is where there is direct human contact, but not consumption. So this can be for purposes such as laundry, toilet flushing, if we're looking in-home, car washing, unrestricted irrigation. So this would be sprinklers of parks and things like that. Here we're looking for good removal of bulk organics. This would be a low BOD and suspended solids, if you will. And here we are now more concerned about disinfection. This would involve generally conversationally 4 or 5 logs of removal of indicator organisms. Oftentimes this is accomplished by filtration to improve the effectiveness of disinfection, and then some high-level disinfection such as chlorine or a high dose of UV. Trace organics control, again, is not so much an issue. So the issue is if there's some unintentional ingestion that it's largely free of pathogens, so protecting public health in that regard. The next level is for human consumption, and now a higher level of disinfection, generally through multiple barriers, and I'll talk about this in a minute, but here we have, in general, 10 or more log removal of bacteria, viruses, and protozoa, looking at the 3 specific types of pathogens that can be present in wastewater. And here, because of consumption, now there's extensive control of trace organics. So a very logical progression in terms of the protection of public health with this. But as I indicated, there are a variety of other factors that affect treatment requirements and technology selection. And you see the 5 items here, which I'm going to talk through one at a time. The first is source control. Source control so that we are not putting into the source water control or source water that we are going to treat to our required standards. We're not putting problematic materials into that source water. This can involve separating individual waste streams. So Singapore, for example, their industry is located on Tuas Island, and the Tuas is treated separately at the Tuas water reclamation plant versus the domestic wastewater, which is brought in by by separate sewers. This can also be treatment at source, and oftentimes for specific sources in the collection system, treatment at source. Dry cleaning is an example of material in a domestic setting that can be problematic in terms of removal. So we keep out those materials that give us problems. That's the first and very important thing that we do. The treatment trains involve multiple barriers. Multiple barriers, first and foremost, provide resilience and robustness so that we, in terms of the constituents that we're looking to control, we're not depending on a single unit process. Disinfection is a good example of this, where we incorporate unit processes capable of removing a range of constituents and of concern. So for pathogens, it's bacteria, protozoa, and viruses. Typically, we'll have more than one disinfection step in the process that are effective in each of these, and ideally some not every disinfection step is equally effective. So if we have something which is a little bit less effective on protozoa, we have another one which is more effective on protozoa. With regard to organics, rather than look to control specific organics, we control a variety of organics based on their physical characteristics. Then we verify this based on the removal of representative constituents, which leads to critical control points, which are the way we control this. So rather than the online control based on specific constituents, we basically simply verify that the technology is functioning efficiently with things like disinfection, residual turbidity, total organic carbon, and so forth. Salinity control depends on the use, either the impacts on vegetation, aquatic life, meeting drinking water standards, or if it's industrial reuse, what the needs are for industry. And then depending on the use, nutrient removal may or may not be needed, and in fact it may be undesirable in some instances. With regard to technologies, the technologies that are used are the same as are used for desalination, and also what is called advanced water treatment. And let me highlight just a few here. So one of the most transformational for water reuse has been membrane bioreactors, where we couple biological treatment with membranes for liquid-solid separation and producing our effluent. These are very robust and reliable. They produce very high-quality effluent and contribute to a high level of disinfection. This is perhaps the one technology which is specific to water reuse. Membranes, of course, are transformational for reuse as they are in many other areas. And we're looking at the variety of membranes here, certainly reverse osmosis, microfiltration, membranes, and so forth. But this group, this audience would be well aware of emerging options, and these also are increasingly being brought into water reuse. UV and advanced oxidation with materials such as ozone and hydrogen peroxide. They're very effective for especially protozoa and viruses, and for the oxidation of recalcitrant organics. And then ozone and BAC, where ozone is an effective disinfectant, but it also increases the degradability of organics that can then be removed in a downstream biological activated carbon system, and of course, granular activated carbon. So returning to my core key messages, reuse is an important component, in many ways an essential component of a balanced and resilient water supply. Technologies are available. Cost needs to be viewed in a balanced fashion in terms of the full range of benefits. I hope I've demonstrated that there's a well-developed professional practice that's also well understood, and public acceptance requires legitimacy and credibility. Thank you very much.
Thank you very much. Thank you very much, Professor Glenn, and you've corrected me. That is as glamorous as anything else in the water industry. But as you said aptly, a complete holistic approach and a very, very critical part of the whole water management systems. Thank you very much indeed, and thank you for joining us. So moving on to taking this further now, we have our next panel discussion, from wastewater to resource, implementing circular economy principles in water management. And I'd like to invite the stage, the moderator of this session, which is Dr. Wada Al-Rashidi, along with the panel, which is Dr. Chedli Tuzuri, Professor Edu Imnam, Dr. Nick Hankins, Dr. Manuel Hidalgo, and Professor Shipeng Sun. Over to you.
Good afternoon, everyone. It is my pleasure to welcome you all in this extraordinary event. I am more than happy to be here to present a panel discussion about circular economy. Please warm welcoming to our panelists, Dr. Ido Inom, Director of Energy Sustainable Innovation Research Center, and Dr. Manuel Hidalgo, an expert in water sector, particularly in water treatment. Dr. Chedli Tuzuri, a professor in Department of Chemical Engineering in Suzhou University. Dr. Nick Hankins, professor in Chemical Engineering, expert in water treatment from Oxford University. And last but not least, Dr. Shipeng Sun from Institute of Nanjing University. Welcome, please. My name is Dr. Wada Al-Rashidi, a research specialist in Saudi Irrigation Organization. And now we will start our session, and the first question is for Dr. Ido. What is the principle of circular economics, and how can it be implemented for water sector reuse?
Yeah, thank you so much. And first of all, I'd really like to appreciate the organizers for inviting me here. This is my first time in Saudi, and it's been amazing, impressive, very important meeting. I'm very grateful. Yeah, going back to the question, so some decades ago, probably about 3 or 4 decades back, it was the general thinking that natural resources were inexhaustible, endless. And based on that thinking, we brought the idea of linear approach to water resources management was in place, whereby emphasis was mainly on water use. But currently, there's been a paradigm change, whereby we are thinking more of bringing in the approaches of circular economy into water resources management. The circular economy theory was being brought forward around the 80s through a lot of reports and scientific papers, especially the one that talked about the economies of natural resources. And this concept basically means that we need to think about water reuse, water recycle, and resource discovery. And there have been several drivers that also promoted this line of paradigm change. Basically, like the concept of climate change. Climate change has made some countries water scarce, water stressed, and industrialization such that we have witnessed here rapid industrialization like in the kingdom, urbanization, demographic changes, and a lot of other things has also driven this paradigm change. And what this change really means is that we are thinking about laying emphasis on water reuse, water recycling, and water resource recovery from wastewater. And the advantage of going this change, of going this direction, is that it will ensure that we mitigate climate change, we ensure equitable economic development, and then we also ensure that water is made available to all. In line with what the President said in his opening remark, that the central core of this meeting is making water available to all. Thank you.
Thank you, Dr. Edon, for this short, direct for the explanations. Now, my second question is, wastewater recycling is an opportunity for both water recycling and for resource recovery. But which one is the priorities? Can we achieve both effectively, or we can choose which one the priority? Dr. Nicholas?
Thank you, yes. First of all, again, I'd like to express my gratitude for the invitation to this fabulous event where we've come from all over the world to talk about these very important issues. And we're now talking about water, recycle, and reuse. We talk about the circular economy, and we talk about waste, but I think both of these words are actually slightly confusing or even misleading. First of all, it's impossible to say it's truly circular because in any treatment process there will be a loss. As a chemical engineer, we know that in a recycle unit, you need to have a makeup stream, and this is true for wastewater as well. So I think, the good news is that we can do these things and we're working on them, but we will always need to have some input into that system, be that from desalination and from fresh water. The second thing I'd like to say is that waste is not the right word anymore. There's a paradigm shift, and waste is really opportunity. So when we talk about wastewater, we know that it has water that we can use again, but it may have materials which can be used to create energy. So there may be organics that can be used, turned into methane, for instance. There may be other valuable components, such as metallic resources that can be recycled and reused, and all of these things play a role. And of course, the type of technologies that we may wish to use will depend entirely on the nature and composition of those wastewaters. There is no one wastewater. Is it urban water, industrial water, agricultural runoff, etc.? So I think moving forward, we need to think carefully about how we will prepare our technologies for this very wide range of wastewaters that we may wish to treat. And of course, on the radar, it depends on the final uses we have. For instance, for the water, we know that there are emerging contaminants, and existing technologies may not be adequate to treat these contaminants. So I think we will have to think more carefully about how to analyze them in the first place and then how to deal with them. So it's not circular and it's not waste, but those are my feelings.
Thank you. Thank you so much. Now, moving from a linear approach of using water, take, use, dispose, to circular system is the goal. But this approach is facing a lot of challenges, and if we can have insight from Dr. Manuel about this kind of challenges, and please, all the panelists are encouraged to participate. Thank you, Doctor.
Thank you so much, Dr. Wahda. It's a pleasure to be here. Assalamu alaikum wa rahmatullahi wa barakatuh. Good afternoon to everyone. So there are a number of challenges when we talk about water reuse. So main challenges are, I believe, first of all, the economic or the financial challenge, of course. If we don't have the necessary resources, economic resources, we can not do much. Although the technologies now are allowing to use, let's say cheap technologies like natural-based technologies. However, if we are using the technologies available right now that are expensive. For example, I'm thinking about membranes, or I'm thinking about RO, or advanced oxidation like femton. So this is very expensive. So this is the first challenge, I will say, also in technology limitations, or the second challenge. So the third challenge will be related to the gap, infrastructure gap, because most of the time the infrastructures are not there. The infrastructure for collecting, for transporting, for treating and transporting and distributing the reused or reclaimed wastewater. Okay. So most of the time we don't have integrated system when it comes to infrastructure for reclaimed water. So the fourth challenge, I will say, is not technological, it's not economical, but it's even more important, which is the challenge of the perception by the public, right? So we know in some places it's difficult to accept to use reuse water, although the quality is very good and can be reused, but there are certain people and certain regions or countries where this is a bit difficult, you know. So a lot of awareness and education is necessary to overcome this challenge. And finally, I will mention the challenge of the regulatory framework, because without effective regulatory framework in place, which is enforceable, we cannot really achieve many things. So for me, these are the 5 basic challenges when it comes to wastewater reuse. Thank you.
Now, these are the challenges, but what are the opportunities? How can we convert these challenges to opportunities and overcome them? Dr. Shadley?
Okay, thank you. Assalamu alaikum all. I'm pleased to be here with you in the first time in Jeddah. I've been in Saudi Arabia in other parts, but in Jeddah I've been here. Thanks for the organizers for the kind invitation and for the excellent conference. So talking about wastewater, I hate to call it wastewater, and I hope one day the community will agree on a different name. I know the translation in Arabic, المياه المستعملة, which is in my view more accurate. That means the water that's been used rather than waste. So from that angle, wastewater, it is not a waste, it's an opportunity. It has a lot of resources, it has a lot of energy inputted into it, it has a lot of materials that inputted in, but unfortunately those materials, they end up somewhere that people do not think to use them. However, they have a lot of value that can be recovered. And I would cite here a couple of perhaps projects we ran with the industry at Swansea University, where I come from in the UK, where we looked at, for example, taking what is called wastewater from the steel industry and try to reuse the materials there into the wastewater company. For example, if we take the steel industry, there are a lot of iron there, and that iron can be used as a coagulant, where the water industry is hungry for this sort of coagulants to treat the water. So there are opportunities there to recover the materials that are in the water, but also to recover the water itself. And here I make reference to using what is called wastewater to treat it. If it treated properly, can be used for irrigation at different level. Singapore goes further than just simply irrigation, but recover that water and distribute it to the public again. But that requires, of course, more input in terms of treatment and also the legislative part of it and the financial side of it to get it to the drinking water. But if we aim to have that water used in, for example, irrigation, already alleviates a lot of load on bringing new water, fresh water. I would add another opportunity. We have grey water, and grey water is, in fact, it's a fairly clean water. It has little contamination, and that little contamination can be treated, can be removed from the water, and the water can be reused again in various applications, such as irrigation, or even use it internally within the house itself for example, toilet flushing, or other application, or car washing. So these applications, they don't need the humans to drink it. So I believe the opportunities for what is called wastewater are huge, and there is potential for applications that can vary. My colleague here, Nick, mentioned the micropollutants. That remains a challenge, particularly depending on the application. And if we talk about irrigation, we need to be careful about the emerging contaminant and micropollutants, because these can be uptaken by the plant. And if a human consumes them, there is some risk there. But also there is a risk those hormones can interfere with the hormonal behavior of the plant itself, and these are evidenced by research. So there are the opportunities, but also we need to weigh the risk carefully.
If I may jump, I would like to add something else. Thank you so much, Doctor. So we are talking about innovation. This panel is about, this whole conference is about innovation. So what you just mentioned is about innovation, being more innovative, more creative, find the right technology for the right application. So that means we need to invest more in R&D, for example. We need to be more creative. We know the technologies are expensive, but I think there is a way to lower the cost of the technologies, and I think in many countries this is what we have to do, right? So that cannot afford the cost of membranes, for example, or they cannot afford a phantom reactor. So we need to find these solutions that Dr. Edu was mentioning at the beginning, right?
Yeah, so for me, I'm looking at the bottom line most of the time. It has to do with funding. So if there can be a way that this conversation can be taken to the highest level globally, whereby there can be a fund that can be created for wastewater recycling or reuse, something similar to where you have the climate fund for CO2 emissions, or where you have the green fund for renewable energy. Because if we have this fund, whether in terms of grants, it can encourage, it can motivate innovation, startup, research and development in this value chain.
Thank you. Thank you so much. Dr. Song, China, and particularly Nanjing Institution, is known for innovation, technologies, and projects. Can you please give us an insight? What are the new innovative technologies that will come on soon in the near future for this matter?
Yeah, thank you very much for your introduction, and also thank you for the Saudi Water Authority to invite me to be here. And this is also my first time to be in the Saudi, although I have many good friends here. So as we talk about wastewater treatment, and I think Saudi and China had some similar problems, such as the water scarcity and also the rapid increased economic needs. And China also has another two problems. One is the big population, and the other one is the limited land. So China has many stringent regulations on wastewater disposal. Not only the quality of the treated water, but also the volume to be discharged is also very strictly regulated for each factory. So due to these issues, so the technology advancement in China for wastewater treatment is progressing very rapidly. And I come from the National Engineering Research Center for the Special Separation Membranes, and we focus on developing membrane materials and processes for the chemical separations and water reuse. So we focus on these technologies. And when we talk about the circular economy for the wastewater treatment, as the other experts has mentioned, we are not talking about only water reuse. We talk about resource recovery, the ions, the solutes in the metals in the wastewater treatment. we turn them into the resources and recover them. So now in China, we focus on the membrane research as the core for the whole process, and we use reactive process such as catalysis and adsorptive methods to assist the whole process. So we use membranes to do the classification of various components in the wastewater, and also reduce the volume of the feed waters. And then we use adsorption to adsorb some residual microorganisms. And also we use catalytic methods to reduce the concentrated stream of the membranes process. Here I can introduce successful projects of the new technologies we use in China. So we use such kind of hybrid systems to treat to do a zero liquid discharge project in the paper and the pulp industry.
Thank you, Dr. San. Yeah. We're running down, but last question.
Okay.
We need to explore a successful stories of implementing the reuse system for water. Please, in 30 seconds, please, starting with Dr. Manuel.
Well, I'm here in the country, in the kingdom. I'm honored to be here since 12 years, and I have seen very good examples of reclaimed water, of reusing water. For example, Marafik, they are doing very well in Jubail and Yambu, industrial cities. But we have another examples I have seen with my own eyes. For example, Saudi Aramco in the Udalia plant, they have an MBR, and they are recycling 100% of the sewage. And they are using it for irrigation purposes, like in Marafik for landscaping. So we have a new technology, which is, I have seen it in Ma'aden, aluminum from Alcoa. So all these technologies are examples, are clear examples in Saudi Arabia, and what I have seen in 12 years is really a great evolution. So now we are doing much more than before.
Thank you. Dr. Shadley.
Well, an example I could think about, in addition to what I mentioned earlier, we had a project where we looked at a factory that processed tomatoes to produce concentrated tomatoes. So this is like the food sector. There is a lot of potential to recycle their waters and reuse. So this particular company, they recycled more than 90% of their water within their internal process. The food sector is a huge consumer of water, and again, there is potential if things are done as it should be.
Thank you. Dr. Nick?
I'll give two very quick examples. The first one is urban water reuse. So the very successful project in Singapore known as New Water, which combines the use of a conventional activated sludge plant and then some reverse osmosis polishing, sometimes using an MBR, membrane bioreactor as well, to achieve a drinkable water which you can buy in little bottles. The second example is actually my own spin-out company, Soloxium, where we've developed a technology which allows us to recover water which can be reused in a non-potable purposes, but also we can selectively recover valuable precious metal resources from them, and that seems to be going pretty well. Thank you.
Thank you.
Yes, so for us, recently we've been experiencing torrential rains and increased precipitation, flooding, and so we're collecting flood storm water and then storing it in wetlands, using the idea being to use a nature-based solution. So we store in wetland and then reuse it for irrigation.
Thank you. Dr. San?
So I only introduced one project. It's the paper pulp at the industry. It consumes a lot of waters. And we use membrane hybrid systems to recover 99.9% of the wastewater to be reused in the industrial process. And we can, because we have high precision materials and optimize the system control, we can reduce the cost of the treatment to be less than 5 RMB per ton. That is 2.5 Saudi dollar per ton for a 40,000 ton per day project.
Thank you so much. Now we reach our last minute. Thank you so much for our speakers. Thank you for your informative discussion. Thank you for the audience. Thank you so much.
Thank you. Shukran, Dr. Wahda, and thank you very much to all your panelists. Indeed, another enlightening session. Thank you very much. So, we are approaching the final section of today's conference, but we're ending up on a very special, unmissable four of case studies to finish the day. And the first one is to discuss electrified membranes for wastewater treatment. I'd like to invite to the stage Dr. Shadi Hassan. Dr. Shadi.
Hey, thank you. Right, assalamu alaikum. Good afternoon. So before I get started, I would like to thank the SWA for inviting me and giving me the opportunity to be with you today and present, some of the research activities that we do at Khalifa University. So for those who do not know me, my name is Shadi Hassan. I'm the director of the Center for Membranes and Advanced Water Technology at Khalifa University in the United Arab Emirates. So for those who are not familiar with Khalifa University was established back in 2018 upon the merger that took place between three different institutions in the UAE, which are Masdar Institute, the Petroleum Institute, as well as the old Khalifa University, to form the big Khalifa University, that we see nowadays. And we're very proudly happy, about the achievements that we have accomplished so far when it comes to world ranking, as we are in the top 200, over 6 years, and hopefully, we can see that progressing even higher and reaching, climbing the ladder, in the near future. So we are also the first university in the MENA, young according to THE, Times Higher Education, in 2024. We have several academic programs, undergraduate, graduate. We have 12 research centers, focusing on several aspects, including water, energy, sustainability, robotics, and so on and so forth. We also focus on attracting, high caliber scientists, professors, students through the different schemes of scholarships that we have within Khalifa University. Since I came from United Arab Emirates, I could not find a better quote than the quote that was given by His Highness Sheikh Mohammed bin Zayed, the President of the United Arab Emirates, when he said that water is more important than oil for UAE. And that's a big statement, that's a huge statement, not only putting pressure on the public or private sectors, but also putting a lot of pressure on us as scientists and researchers, trying to cope up, with technology, trying to advance, water solutions, in order, to preserve our resources in the UAE. Just to give you a hint or a brief about the situation, the water situation in the UAE, as everybody knows, UAE is located in an arid or semi-arid region. We don't have a lot of surface water. Well, actually, we don't have surface water. We do have some dams, scattered here and there, with only access to the Arabian Gulf with a narrow opening to the Indian Ocean. So basically, we don't have a lot of water, and the majority of the water that we get as drinking water is through desalination process. So in Abu Dhabi, for example, we've got 60% of the water from groundwater, which again, we're facing some challenges with that. 30% desalination and 10% from water reuse. So this is why, we have decided to establish this center. We call it Center for Membranes and Advanced Water Technology. In short, we call it CMAT. In order, as I said, to advance technologies, water technologies, and help the country, become sustainable when it comes, to water resources. So just to give you a brief idea, I don't know why this slide is looking like that. It's not, I think there is some technical issues with the animations, but so CMAT basically is a research center focusing on water purification. We have 5 different thematic areas. One of them focuses on the desalination water technologies, wastewater treatment. Another one is on novel membranes. A third thematic on 2D material. Everybody knows the evolution of 2D material nowadays and the advantages of those 2D materials, when it comes to advancing technologies, down the road. And a fourth thematic area is basically on environmental modeling, because we do have still thermal desalination, despite the fact UAE is shifting, towards membrane-based desalination, building the largest desalination plant in the world in Al Tawila with a capacity exceeding 900,000 cubic meters per day. And a fifth thematic area is basically water microbiology, because we have seen, the importance of wastewater as an early detection tool, especially when it comes to pandemic, early warnings and detection, beforehand. And what inspired us, to come up with this is the pandemic, COVID pandemic, and we could see how we could detect, SARS-CoV-2 in wastewater and so on and so forth. So at CMAT, we're very, as scientists, we're very proud of our numbers. So since 2018, we have published more than 400 papers. 97% are in Q1 journals, for those who are familiar with that, for the scientific community. We have made more than 30 filings, patent filings. We attracted several funding opportunities. We hosted a lot of our seminars, events, conferences, as well as we established, several collaboration opportunities, academic institutions, industry, both nationally and internationally. And we hope, to expand this list, down the road. So in CMAT, I couldn't achieve all of that without the help and the assistance and the support that I got, from my colleagues. We believe in CMAT, innovation or multidisciplinary, interdisciplinary is the way to move forward, is the way to innovate, is the way, to develop these advanced technologies. So we're trying to bring things out of the box. We always think, we don't think, about the norm, we think about the abnorm. How can we achieve, things differently, from different angles and different perspectives? And that's why, we have people from chemical engineering, mechanical engineering, material science, chemistry, biology, joining the centers, working hand in hand, joining forces in order to, as I said, start to think differently than others. We have also huge contributions from the scientific board committee, that we have within CMAT. These people, they're always given their feedback on how we can advance, how can we adjust things accordingly and align our research activities, every now and then. I just want to say, express again my condolences to Professor Enrico Drioli's family, who passed away, a few weeks away, and we lost, a high caliber, scientific caliber, in the scientific community. Okay, so for this talk, I selected, this case study because of the importance, the significance, of these emerging pollutants. And nowadays, everybody talks about microplastics, PFAS, pharmaceuticals, antibiotics, and so on and so forth. So we at CMAT, we focus our research and some of our research directions in that area, trying to prepare ourselves, to tackle those problems before they even, go beyond our control. And we're always trying to align our research activities, with the sustainability development goals, ensuring, safe clean water access, hygiene, to everybody around the world. In the UAE, we have, or the government, has initiated a lot of initiatives and programs, when it comes to water security. One of them is what we call the 2036, the UAE Water Security Strategy, with several objectives. Well, I think it disappeared for somehow, I don't know why, but aiming at reducing the water, the water consumption, increasing, the water reuse mainly, from 95% to 95% by the year 2036. The current situation is that, we're recycling about 51 to 70%, of that. But, by 2036, we aim to recycle 95% or maybe 100%, of that, opening, future opportunities, future doors, for reuse applications, in the future rather than, only irrigation. As I said, the talk is going to be about microplastics, and microplastics, as you know, are very small material ranging, between 5 millimeters to 10 nanometers and smaller, and they're very problematic. I mean, they cause problems to humans, they cause problems to the ecosystems, to the fish. They might mistake them, with nutrients, so they end up having some nutrients deficiency and so on and so forth. And in the water treatment side, they create some problems, membrane technology, for example, fouling, so this is a major issue that we're trying, to overcome. And literature has been rich, so far, but we need a lot more, of these studies, looking at microplastics, nanoplastics, and their impact, their adverse impact, when it comes, as I said, on humans, ecosystems, or mainly because of this talk today on membranes and membrane fouling more specifically. So on this research, which was done, by the way, by my PhD student who recently defended her PhD, her name is Maria Mauda. And as I said, the main objective here is basically summarized in two things, is what and how. So what are the microplastics? We talk about them, and how we are tackling, or we have tackled, the problem of fouling or fouling medication, as I mentioned before, that one thematic area at CMAT is focusing on the evolution or the 2D material. So in this case, we utilized 2D material, mainly MXene. Perhaps everybody is talking about graphene and so on, but we have other examples such as MXene, MOFs, COFs, MOS2, and so on and so forth. There's plenty of those exciting 2D material, and they exert a lot of these interesting properties in them. So we decided, to try MXene 2D material, and MXene is basically a 2D material made up of a single layer of transition metals and sandwiched, between carbon atoms. Okay, just as simple as that. So we tried. There are several types of MXenes, and we tried what you see there, the titanium-based MXene, in a technology called electrified membranes. So this is another emerging, area in membrane technology. Because everybody is aware of electrochemical treatment. Everyone is aware of membrane technology, right? So we decided and said, okay, why can't we combine these together? Can we do that, in a way that the cathode is not only acting as a cathode, but also as a filter, as a membrane. And the novelty here is basically the integration, not only integration electro with membranes, but also the integration of 2D material, MXene-based material, to make these electrodes and the membrane from that material itself. So what attracted us when it comes to MXene, as you can see there, it has a lot of these interesting properties. What are they? It provides large surface area. You can tune it. You can functionalize it, with several chemicals. In addition, it has high conductivity and high electrical conductivity. And in a system like that, this is very important for us because we want to achieve, that electrokinetic phenomena within the system. So basically, these are the different objectives. We went all the way from scratch. We went from A to Z. We synthesized the material, the MXene, and then we synthesized the membranes, using a technique called phase inversion. So this is here just a summary. So we started with, at the top, you can see the polymer that we selected, the PES. It's a very common polymer in membranes. But what we did is basically we changed that. We used a process called sulfonation. So we produced sulfonation PES. And the reason for that is to increase hydrophilicity of the membrane, which will enhance, the water permeability and reduce membrane fouling. And the second is how we synthesize MXene material from the max phase through sonication, through etching, the aluminum layer, sonication, exfoliation, and so on and so forth. And lastly, you see how we mixed, the material with the polymer and cast the membranes using phase inversion. This is the setup that we used. Even it looks simple, but it took us, months, to come up with a proper design for that cell. And for those who are in the area, they can understand exactly how difficult, to develop these kind of cells. So you can see the membranes and the electrodes, and the cathode, as I said, will act as a filter. So we've done a lot of characterization in order to make sure that we have successfully loaded, I mean, the MXene material, and we have successfully sulfonated, you know, the PS, and we have successfully made or fabricated those membranes. So just to go very quickly, we've done Raman analysis to check on the sulfonation process. We did XRD to check on the peaks, on the MXene peaks. We checked also some of the physiochemical properties, you know, such as contact angle, because we're looking for hydrophilic membranes, because microplastics are negatively charged hydrophobic. And this is where we decrease the contact angle, showing, you know, an increase in the surface energy, the hydration layer, which will allow, you know, to increase the mass transfer and therefore more water permeability. The other two figures is what we call EDS, elemental mapping. We want to make sure that the MXene was well incorporated. And lastly, we check the porosity of the membrane as well as the pore size, and we can see an increase in the porosity as well as in the pore size of the membranes. We changed the loading, by the way, of the MXene material from 5% to 15%. We wanted to optimize, you know, the best loading material. This one on the left side is the EDS elemental mapping. You can see the homogeneity or the homogeneous distribution of the material across the surface of the membrane, as well as the SEM images. You see the surface as well as the cross-section. The surface, you can see the porous structure of those membranes, which will allow water, I mean, to pass through. And you can see in the cross-section images at the bottom, the channels, you know, what we call them like finger-like, you know, which ensures the high rate, I mean, exchange rate between the solvent and the non-solvent, which indicates a successful membrane fabrication. And I'm sorry for this overlapping. I don't know why it's coming like this. But anyways, this slide, you know, shows that, you know, we have successfully achieved good flux when it comes to the integration of MXene as well as, you know, the sulfonated PS. And then we said, let's apply electricity now. So we tested it without electricity, and then we said, okay, let's apply electricity and see what happens to the flux. And what we have observed, that we increased the flux, but it was continuously supplied. And then we said, okay, so now there is a trade-off. So we want to have a good flux, but at the same time, we're increasing energy consumption, but this is not good, right? So what we did is we came up with another technique, is to supply electricity intermittently. So we tried different on-off mode, what we call, so we tried 30-90, 30-60, and 30-30, and then we started, you know, observing the stability of the flux, and we did also membrane characterization to ensure, and so on and so forth. So I don't want to spend, I mean, a lot of time, but the key message here is basically we have a synergetic effect, you know, due to the material properties, the inclusion of the MXene as well as the sulfonation process, as well as, you know, the impact of electric field. Because if you're asking me what happens between when it's on and when it's off. When it's on, you allow electrokinetic phenomena, I mean, to take place. One of them is electrocoagulation. If you're familiar with electrochemical treatment, you've got electrocoagulation, you form these bigger flux, electroosmosis, you extract the bad water, you know, from the flux, so you produce some kind of, let's say, dry flux. And when the electric field is off, so you're allowing those flux to sweep away from the membrane surface. So this is where, you know, you are reducing foulness. They don't come across, or they don't stick to the membrane surface. So this is how we overcome, you know, the problem associated with microplastics fouling. And I encourage you, I mean, invite you to read our publications. We have published maybe 3 or 4 papers, you know, on this topic in reputable journals, and we also have a U.S. patent and UE patent filing on the technology. And hopefully, you know, we can it can see the light, you know, when it comes to scalability. This is the next step that we aim, I mean, to do, because these systems are modular, so it's easy to scale them up. But we need to put them, you know, for pilot testing and so on and so forth. So these are the conclusions or the concluding remarks, which I have well captured, I mean, during my talk. And at the end, I would like to acknowledge, I mean, Khalifa University, you know, for the financial support, the SWA for bringing me here, and to my team, my PhD student Mariam, as well as my postdoc, Dr. Ravi. At the end, thank you very much for listening, and looking forward, I mean, to establishing collaboration down the road. Thank you.
Thank you, Dr. Shadi. We have 3 more case studies to do. If I could ask Professor Talsung Professor Chunhei Weiss and Professor Mehmet Kitis, if they could keep their presentations a little shorter in the respect for the audience. We are running over time, so if you can keep it to 5 minutes, that will help. Skip some slides, whatever. So, in the next case study, we're going to process innovation, improving the rejection of low-molecule, weight-neutral organic contaminants by reverse osmosis, mechanism, and strategy. I would like to welcome to the stage Professor Tao Zhang.
So the coordinator told me I have only 5 minutes, so I have to go through my slides very quickly. So for the reverse osmosis, I think you are very familiar with this process. It is mainly used for the desalination. But there are also many practices in the TOC control with the reverse osmosis. For example, the industrial reuse, the portable reuse, and the electronic ultra-pure water production. And the demand for the ultra-pure water is not small, it is huge. And for example, for the chip industry, it requires a lot of ultra-pure water. And in this industry, there is a stringent standard for the TOC control. Usually, it requires 1 ppb for the production of chips. It is a huge challenge for the water treatment. And for the normal ultra-pure water production process, reverse osmosis is the mainly procedure to control the TOC. And for portable reuse, reverse osmosis is also important in the rejection of the organic compounds. And in our permeate, there are always some small compounds. It is very difficult to remove them efficiently. These compounds can be oxidation products, solvents, DBPS, and also some volatile organic compounds. So this shows the structures of these compounds and the molecular weight. Then how does a reverse osmosis reject low molecular weight organic compounds? There are many mechanisms. The main mechanism is like the salt rejection. It is based on the molecular size exclusion and also electrostatic repulsion. But unlike the salt, the small molecules are quite different in the molecular size, in the charge, and in the heteroatoms. So effectively reject these small molecules by reverse osmosis is still very challenging. And there are many interactions determine the organic molecule rejection. These factors, none of these factors cannot describe precisely the rejection of the molecules. Yes. And how to improve our rejection for low molecular weight compounds? Normally, there are 4 strategies, like the composite membrane fabrication, the alternative materials to fabricate membrane modification, and the introduction of interlayer for the membrane. And we focused on the membrane modification because compared to other strategies, the membrane modification nearly do not change the membrane fabrication process, and the modification can be easily adopted in the production line. So we can see in this figure that compared with the virgin membrane, the modification have nearly no influence on the morphology of the membranes. And when we did modification, the hydrophilicity, the surface charge, and the surface carbonyl content of the modified membranes also changed. And regarding the rejection of low molecular weight compounds like benzothioazole, benzotriazoles, the modified membranes have much a higher compound rejection rates, and it can achieve doubling water permeance and the better compound rejection. And even at the same permeated flux, the rejection of this small compound can be even better than the virgin membrane. About 50% of the in the permeate of the reverse osmosis, the compound concentration can be 50% lower than the virgin membrane. And we can characterize the polyamide layer composition with pyrolysis GC mass. We can see the modified polyamide has a higher content of oxygen-containing groups and more dimer constructors. That means the oxygen content and the cross-link of the modified membrane is better than the virgin membrane. And we can simulate the interactions of the modified moieties and the small compounds. We can get an idea on how strong they interact with each other. So the conclusion is that when modified, the membrane will have a lower binding energy with these small neutral compounds. And we can also evaluate the contribution of various surface interactions to the boosted the compound rejection by the modified membrane. And unlike the virgin membrane, the modified membrane, in the modified membrane, hydrophilic interaction contributes a lot. Okay, here comes the conclusion. So identification of the low molecular weight organic compounds by in our permeate is still a challenge. And there are many rejection mechanisms. So further clarification of the reaction mechanisms still need more effort. In our research, the oxygen content of the hydroxyl groups in the polyamide layer can reduce surface affinity of low neutral compound to the membrane and subsequently improve their rejection. And we still need to validate this finding with pilot scale tests. Thank you.
Thank you very much indeed for speeding that up. So we'd like to go to the third case study. Thank you, Mr. Chung. Resource recovery from municipal and industrial wastewater. I'd like to invite to the stage Professor Chunai Weiss. Chunai.
Thanks very much for the chairman's introduction. I'm very honored to be here to present our study on anaerobic membrane bioreactor, conducted both at King Abdullah University of Science and Technology in Kingdom, and also the Guangzhou University in China. Okay. Oh, sorry. How can I? Oh. Okay. Yeah. Sorry. Nowadays, it's just like the panel discussions, the wastewater now, it's not just simple waste. It can be regarded as energy and resource carrier. For the most, among the components of the wastewater, the water can be reused or reclaimed, where the appropriate normally hybrid process of physical, chemical, and biological. And since the energy or the chemical energy bonded in the organics, they can be converted into methane, hydrogen, or other high-valued chemicals, where mostly anaerobic-based biological processes. And another for the nutrients, in terms of phosphorus and nitrogen, they can be recovered as a fertilizer, normally via the chemical processes. And also for the domestic wastewater, we know the they also retain some of the thermal energy. They can be recovered for air conditioning via the heat pump technology. For the anaerobic membrane reactor, actually, it's a hybrid process of a conventional anaerobic digestion followed by the membrane separation, including some microfiltration, ultrafiltration, and also some forward osmosis membrane, and also membrane desalination for the high rejection. But the NMBR, actually, they have a similar configuration to the aerobic one, the aerobic NMBR. Now it's widely used for the domestic wastewater treatment. But they have normally lower flux, and also they have normally no nutrient removal capacity due to the anaerobic metabolism. And also they normally, for the low strength wastewater, they have very low methane recovery. That's some of the limitations. Thus, for the moment, there's only some small scale engineering application for some industrial wastewater. But for municipal wastewater, it's only some pilot for the moment. Yeah, I think that's I think use some of the animation they cannot display. I show some of the paper. You can see the publication, the history. That's mostly in the last decade. The NMBR actually got many attentions in the academia, especially for the EST paper from the Professor McCarthy. That's why. Now for the application scenarios, the NMBR actually they has some greatest potential for the high strength wastewater, and also must with the high proportional organics, like the livestock wastewater or some the landfill leachate. Also, NMBR also some medium potential for municipal wastewater, because municipal wastewater they have also a high proportion of particulate organics. Now the NMBR, we have some small scale application, mostly for the brewery and the dairy wastewater treatment in the USA, in Europe, and also Japan. For the municipal wastewater, actually we have several pilots from, I think, a few cubic meters per day to maximum of 20 in Japan. The NMBR for the domestic wastewater, they also achieved some good COD removal, but they have much lower flux, and also they need some additional pre or post treatment for the nutrient removal, because in the municipal wastewater the nutrient concentration is low. That's infeasible for recovery for the moment. Yeah, we did some NMBR demonstration study, I think, for the low to high strength synthetic wastewater treatment at cost about around 10 years ago. We used lab scale CSTR reactor, mesophilic reactor, followed by a hollow fiber UF membrane for the separation. We test the different operation conditions. Here we can see the reactor actually performed very good performance for the organics removal for COD, mostly since 98%, even at a very high OLR, around 10 gram COD per liter per day. Actually, it's much higher than the aerobic one. And also we can get some to the critical parameters for we define as a sustainable OLR about for the COD permitted COD below 50 milligram per liter, like 6 grams COD per liter per day. we all look for the machine the production. We can see in most runs, for the suitable runs, the machine content, they can be even high, 90%. It's quite high. This is sometimes close to the natural gas. Yeah, we do the microbial analysis to find that actually in the archaea group, we have found the high proportion of methanobacteria, which is a kind of hydrogen utilization methods, and that's why they consumed some of the CO2 conversion to the hydrogen to the machine. And also we did the analysis about the machine yield. We found that actually in some of the high OLR, we achieved the theoretical value about 380 milliliter methane per gram COD removed. That's why it's yeah. And we also do some of the microbial, the evolution. We also observe the biomass yield. Actually, it's quite very low. It's 20 times lower than the aerobic one. Yeah. And also we do some of the genetics evaluation for the organics biodegradation and also for the microbial growth. We can see some of the key, how maximum rate concentration or the true biomass yield or the maintenance energy like that. Yeah. For membrane the operation, we can see some, if we run a low flux operation about 6 liters per square meter per hour, we can see very stable operation. The TMP still keep long steady operation. But if we double the flux around 10 to 12, the TMP increase so fast. Yeah, this agreement with the precious AMBR study, we cannot achieve the equivalent flux to the aerobic one. Yeah, that's why we need more studies to improve the AMBR, the sludge fieldability. We also do some the trace organics actually for the municipal wastewater. We must for reuse. We must take concern about the trace organics. Also, we call the organic micropollutants like that. We also test the NF system, AMBR followed by NSM, and we found that for the organics, the book organics, is quite very high stable removal. We also test about 15 compounds, 15 trace organic compounds. Some ones are easily degradable. Some ones they need a long simulation, and also quite some ones is very difficult to remove. Yeah. Yeah. We also explore some of the mechanism about the OMP's removal. The NF, the NF90 membranes actually can have high rejection for all the compounds. Sorry. Oh, okay, I'll go fast. Yeah, we also do check some of the microbial response to this OMP spark. And also, we just compare the AMBR versus the AMBR. We also found some, we also do some of the OMPs by transformation, the pathway. It's more the mechanism study. And for AMBR, from the application, the potential, we can some ways to improve, to enhance. Once for enhance the dissolution on the hydrolysis by the suspended organics, and also we some enhance the methodiness, and also we must to improve the membrane the permeability, and also the nutrients recovery. Yeah, we do some the protocol, use the micro aeration to enhance the particulate organics, the dissolution and the hydrolysis, as to enhance the methanolysis. And also this microaeration, they can enhance the large flux formation that can be enhance the sludge filtrability. Yeah. And also we just check some use the modern microbial technology to check the microbial community response to this the microaeration. We also synthesize some of the functional material to enhance the methane production. We synthesize the composites of iron and carbon composites, and both composites also to enhance the conductivity and to facilitate the transfer of electron for methane production. We also test some of the performance of these companies and also the microbial response. Also, we do the post-treatment. Post-treatment after NMBR treats the raw, the wastewater, and the permeate. It can be where the chemical process to recover the fertilizer. That means straw white. Yeah. We also do use the microalgae also to assimilate the nutrients in the NMBR permeate. That's another way. So. And also recently, we found that some the groups, they just use the electron membranes in NMBR to achieve in one reactor, so to achieve the organics removal and the nutrient recovery and also following the control. Yeah. And since the time is so limited, I just go we found that maybe besides the wastewater, I think the NMBR may be also some of the potential for the I think the high solid waste, like the waste activity sludge back then. Yeah. And also we appreciate the support from both Carlson and Guangzhou University and also the funding agency. Thank you.
Thank you, Professor Chennai. Yeah. Sorry, we had to rush you, speed you up. There's a lot of detail on those slides. So for the final case study of today, thank you very much for staying on to the end. We have Professor Mehmet Kitis, who is going to discuss circular economy water efficiency studies in Turkish industries. Professor Mehmet, how are you? It's all on. Yeah.
Good afternoon. Selamünaleyküm. I have the last presentation, which means that I have unlimited time. No, I'm gonna hopefully finish in 10 minutes. My name is Mehmet Kitiş. I'm a professor at the Süleyman Demirel University, Environmental Engineering. I'm also working with two Turkish ministries. One of them is Turkish Minister of Environment and Turkish Minister of Agriculture and Forestry. And in the last 5-6 years, what we are doing is we are trying to establish new programs and water control measures for Turkish industries, so that we use less amount in industries. Okay, basically, I'm just going to spend a couple times for proactive and constructive methods. In 1960s, what we were talking, it was just ignore pollution, passive approach for the industrial wastewaters. In 1980s, maybe early 1980s, we were talking about dilution and dispersion. In early 2000 years, end-of-pipe treatment was the solution, but right now we are talking cleaner production. So we have to produce goods, products, for example, this jacket or this t-shirt in textile industry, use less water, less energy, produce less amount of emissions, and make it cleaner production. This is 2024, but maybe what I think that after 30 years or 40 years, this phase will also finish. We will talk a new phase, which is the super cleaner production phase, which means do not use any water, do not use any raw material, do not use any nitrogen or phosphorus, just use the recycled materials. Just use employ the industrial symbiosis. Industrial symbiosis is just the use of waste A from company A as an input to company B. So maybe after 25 or 30 years, we'll talk about super cleaner production phase. So we won't be able to use the raw materials. We have to use all waste amounts as input to the production. So this is a general thing. So I'm going to talk, the first project was done, it was a European Union project, and the ministry said, okay, we have a lot of industries in Turkey, let's check their water efficiency. Are they doing good or bad? We selected 3 watershed basins. We have about total of 25 watersheds. One of them is called the Yeşilırmak, is in the north part of Turkey, which is heavily industrial. And we selected different sectors, and we employed, we look at the BATs. BATs are the best available technologies, best available techniques indicated in European Union documents. These are called EU BREF documents, reference documents, to see the water consumption, wastewater generation, energy use. And we did the study for about 40 different industrial facilities in basins. This is the first global study that investigated water efficiency based on NACE codes, NACE codes. You know, the industries have different NACE codes, NACE codes, because the other documents published by the European Union countries is very general. For example, it says BREF documents for pulp and paper, BREF documents for wood industry, but that's a very wide range. There are a lot of different subsectors within textile. So we don't have any globally available reference document for each NACE code in terms of water consumption. So Turkish government did this first time globally. So we produced about 150 technical guides for each specific NACE codes in terms of water efficiency, which techniques they should use, what is the specific water consumption they should achieve, and specific water consumption is meaning, what means is that it's how much liter water you have to use per kilogram of t-shirt you want to produce, or how much liter you have to use per kilogram of cell phone you produce. So this is specific water consumption. So this project was finished a couple years ago. Basically what we did was we visited about 40 different industrial facilities on site, spent at least 2 days, and we took water tomography. So water tomography is you start from the groundwater, from the wells, up to the wastewater generation point, and try to detect problems. Are there any leaks? Are there any inefficient points? Can we employ these techniques to these companies? How is the water softening units? What is the ion exchange regeneration frequency? A lot of different questions. Yeah. And then we tried to close the mass balances for water use and wastewater generation in each of these things. The mass balances were already done for heat, steam, water, wastewater. But this project is today totally for water. These are the mass balances for example, they have paddock, slaughterhouse, carcass resting, dismemberment. For each process, the water consumptions were determined and compared with the water values given in the EU BREF documents. So it's like a water checkup, water tomography checkup. These are the values, we call these, for example here, average specific water consumption. The problem in the European Union documents, BREF documents, is that number one, they are not NACE code based, they are not NACE based. And also the values given are very wide. For example, it says for cotton dyeing in textile, what we recommend is 80 to 200 liter per kilogram. But what is the correct one, 80 or 200? A huge range. So this range should be narrowed in terms of water control measures. Also, some of the data are narrow, and the data are only for the whole plant. But I don't need the specific water consumption for the whole plant. I need per machine-based or per process-based. And these data are not available in any other country. For example, this is an animal slaughterhouse plant. For example, for the paddock unit, the specific consumption was 1.8 per kilogram liter. Is it good or bad? That's the problem. We don't have any reference value globally. Even the United Nations doesn't have it. EU doesn't have it. So we should have any reference documents for each NACE code and for each process so that we can compare our performance. Am I doing good or bad? So Turkish government is trying to right now produce a database and produce a reference value so that we can check ourselves in terms of cleaner production, in terms of water used. For example, this is the value of our slaughter. This is the value for slaughterhouse, carcass resting, dismemberment, meat cooling. So process-based water consumptions were calculated. Also auxiliary processes. And this project was liked very much, and European Union asked us to do the second project. The second project is finished last year, so we visited about 400 different industrial facilities, totaling about 160 different NACE codes, 4-digit NACE codes. So we have the data for about 160 NACE codes. These are, I'm sorry, some of them are Turkish because these are official, official slides, so they didn't want me to translate. So we did a survey to each plant. It's like an 80-page survey, technical evaluation. And we sent these surveys to the plant. They studied it, and we visited them, and we complete these surveys. The survey asked them, please give points. For example, if we give this recommendation in terms of water usage, for example, reuse of ora concentrates, brackish water ora concentrates, or use dry processes instead of wet processes, or use pressurized spray systems for cleaning. A lot of technical BATs. They give points. For example, they say, okay, in terms of water savings, 0.4. In terms of economical savings, in terms of environmental benefits, applicability, cross-media. Cross-media means like eutrophication effect or other side effects. For example, in any factory, while you are fixing one point, you can screw with another point. For example, you employ a new technique for water control, but it can have more carbon footprint. So that's very important. In clean production, cross-media effects is always overlooked, which is not good. You should always check the cross-media. The fifth one is the facility preference. So the technique you recommend may be cheap, seems very logical, but they cannot employ it because they don't have any space to install. The factory is very old. You don't have any open channels for concrete pipes. So basically, it's not applicable. So they give points, and we evaluate sorry, them. So for example, for NACE codes, mining of lignite, 0520. For example, mining and quarrying, production of meat and poultry, processing and preserving potato, manufacture of oils. So we have data about 160 NACE codes. So this is the average specific water consumption in the facility. This is the specific consumption value given in the European Union draft documents. See, some of them are very wide because they are not NACE code based. And these are the values, potential saving ratio. For example, it is below the reference, doing good. This is like 75% reference. So we know each factory's performance right now. All right. Another example, and then the minister asked us, please calculate the cost, how much money we should pay for these techniques so that they are clean in terms of water usage. And we calculated the cost, capital cost and operation maintenance cost of all these water control measures and divided them to the kilogram product. For example here, specific water consumption after they employ these new techniques, this is before. For example, facility 41, current performance 0.02 liters per kilogram. If they employ what we suggest, it should decrease to 0.01. And this is the value, how much they have to spend. And these are the specific wastewater generation. Specific wastewater generation means per kilogram of t-shirt dyeing, how much wastewater you produce. So we have data for all these facilities. And these are the cost-benefit analysis. I don't have that much time. We did, so I'm not going to spend more time. We just determined the cost-benefit analysis. So this is the final action plan published by Turkish Ministry of Forestry and Agriculture. They said, okay, sorry, it's difficult to read, but I'll give you an example. For example, detection and reduction of water losses. This is BAT, one of the water control measures. How much water saving it will provide to you. If you employ this technique, how much money you will spend per kilogram of t-shirt, and what is the payback period, who's the responsible authority, who's going to pay it, and the application deadline. So this guidelines, again, done first time globally, is right now specific for each industry. So everything is good, but the problem is application, a lot of politics, a lot of bureaucracy involved in the application. But we have the action plans right now for all industries. And all the control measures are already known. There are a lot of different techniques. For example, use of air cooling system instead of water cooling system. Use of automatic control or shut-off valves to optimize water. There are a lot of different, and also operational blindness. If you work in the same factory for 20 years, we call them operational blindness. You cannot detect the problems. So someone from outside should see and check these inefficient points. So what is the result? For example, just for one basin, we call Batı Akdeniz, which is the Western Mediterranean area, totally touristic area, for only 19 facilities, and these are small factories, total consumption was about 15 cubic million per year. If we employ these water techniques, we will save about 40% water usage. So these are the real values from the site. Another project was done called BESTU. This is the checking of Turkish textile and leather industry in terms of European Union harmonization. Are we doing good or bad in terms of European Union rules? So we visited about like 150 plants, did a lot of surveys all around Turkey. I'm not going to spend that time. A total of about 160 surveys was collected, and each survey was continued for 2 days. Because it's not just filling, it's on-site investigation. Are they saying the truth or not? Okay. This is the survey form, about 80 pages, from emissions, wastewater collection, steam production, pressurized air system, cooling systems, all these details. I don't know why, but the slides are a little bit screwed. Basically, the result. For textile industry, about 37% of the BATs, best available techniques, was already implemented, which is good. And this value increased to 88%. So actually, the Turkish textile industry, in terms of cleaner production, is much better than the other countries in European Union right now, because the installation rates and implementation rates was much better in Turkey compared to other textile producers in European Union countries. That was interesting. That's because a lot of Turkish textile companies have global sellers, and they are selling to global ventures, merchandise, so they have to be clean, otherwise they cannot sell their goods. So there are a lot of different techniques, a lot of buts. I don't have that time. So what was the problem? What is the major problem of the textile industry that prevents them to employ cleaner production? One, high capital and O&M costs. Second, operation and installation difficulties. They have money, but no space to do it. Third, limited sectoral know-how and experience, limited space for implementation, stringent customer requirements. For example, you sell a T-shirt to Levi's, to Inditex, to H&M. They have their own rules. Okay, if you sell me T-shirt, your effluent COD will be less than 300, for example. Your water value should be this. So, if you sell to H&M, they have their rules. If you sell to another Zara, they have their rules. But the rules do not match, different numbers. So they don't want to do it. They say, okay, if I employ this technique, I'm not going to be able to sell to A, let's say Zara. So that's the problem. Another problem, anxiety on possible product deterioration. Okay, I'm going to reuse my wastewater, no problem. But if there is something happening on the brackish water RO, and if my conductivity increases to 25 microsiemens, or my hardness is less than 3, French hardness, then there is going to be scaling on T-shirts, and I'm going to lose my 2 million T-shirts, and I'm going to send them to waste. So that's a problem. So industrial wastewater reuse should be zero risk, and also operational blindness. So these are the major needs. Another project, this is the first time globally, I was a researcher in this project, also advisor. This is the first global application of cleaner production in terms of online measurement and online control. This is a very good textile company in Istanbul, Zorlu Text, one of the big ones in the world. They put digital flow meters to water and wastewater, and flow meters for steam, for power, everything. So they're online, they are connected to the PLC and SCADA systems, and they have set values. For example, they are dyeing red T-shirts today. They start the dyeing process, and these are their set values. For example, for this production, our set value is 100 liters per kilogram. This is theoretical objective. And this is the real value. Okay, I dye this t-shirt with 80. Very good. Smiling face, I am less than 25% of the upper limit. This is done for specific auxiliary chemical. How much salt I spent per kilogram of t-shirt. Gram of salt per kilogram t-shirt. Or kilowatt hour per kilogram t-shirt. Or all these things. So they are online controlled and online measured. So if there's a problem, then the boss say, okay, you are doing bad in terms of wastewater generation, please correct yourself. So this is the online software that is really working on in the factory right now. And the boss can check all these values at the end of the day. So this is the first global application on site. This is a new project just started 3 months ago. Again, this is the first global application of artificial intelligence in textile dyeing in terms of wastewater reuse. So what is happening? It's right now pilot scale tests. We have a machine. You can just think this as a washing machine. This is a dyeing unit. This is a dyeing unit here. So this is a batch system. So what you do is you put the t-shirts or all the clothes inside, and you put like 5 cubic meter of water, and you have different dyeing recipes. Each textile company has about 2,000 dyeing recipes. White color is different, black is different, 2,000 different recipes with different dyes and with different salts. So the first 6 months, this machine will learn the data. So we will make about 600 different dyings and then measure online the wastewaters generated from the system by time. So we have online COD sensors, color sensors, conductivity, TDS, pH, and we will collect the data from 600 different dyeing recipes. So the system will learn it. So after that, after the project is finished, let's say the boss received a new purchase order, different color, but he doesn't know what's going to happen. So the artificial intelligence will understand based on the information, okay, this is the new dyeing, which is close to dyeing number 340 or 50. So the effluent quality estimation is this. And we have scenarios, set values. For example, scenario 1, if the wastewater is less than, if the wastewater COD is less than 10, and the conductivity is less than 20 microsiemens, there is a 3-way automatic valve, 3-direction automatic valve. It will send the water directly to the raw water, to the groundwater tank. Scenario B, if COD is and color is this value, send it to the wastewater reclamation plant, pilot scale plant in the facility. Scenario 3, if it's very contaminated, send it to the centralized system. So this scenario will automatically work, and during the wastewater discharge, they say 15 minutes, time 0 to time 3, the wastewater will go to raw water tank, for example. 3 to 8 go to advanced treatment plant, and the last 5 minutes directed to the centralized plant, depending on the color. So it will automate, and artificial intelligence will estimate the output quality of the wastewater for the unknown recipes using the already taught data. So this is the first global application. It's right now we are piloting this in the city of Denizli, and this also received the award from some companies. Hopefully it works, but a lot of problems in the kitchen. I don't have any time, especially the sensors, the verification of the sensors get clogged. There is a lag time of data sending, a lot of problems. All right, so I hope I finish in a couple of minutes. Okay, another problem in Turkey, huge problem. We have a lot of brackish water RO plants in industry because our groundwaters are hard, generally 10 to 30 or 40 French hardness. And they have to use processed water, softened water. They use ion exchange resins or brackish water RO, soften them, produce like goods, t-shirts, automotive, a lot of different industries, also for steam production. But the problem, the groundwater in Turkey is very clean generally. TOCs are less than 1 milligram per liter, conductivities are not that much. Let's say you are working with 80% recovery, water recovery in brackish water RO. Basically, your RO concentrate is just 5 times the groundwater value. So your value is on the 5 TOC, milligram per liter, and 700, 500 microsiemens. So it's not a waste. We should do something. We should reuse it. And we are also conducting projects to recover And we have a lot of different options. For example, resend them to the storage tank, use them for cleaning of the tanks, for CIP cleanings. And we have also some interesting projects, connect these brackish water aura concentrates to SCADA system, measure the conductivity and hardness online, and set some values. If your raw water tank is less than, for example, 30 microsiemens, send this aura concentrate back to the raw water tank. If the set value is higher, stop it, send it to waste. So brackish water aura recirculate concentrate can be inserted to the system as long as you keep the salt accumulation problem out of your mind. So there are some applications that we reuse, directly reuse brackish water aura concentrates in the plant. Some of them use for like cleaning the tanks, cleaning machines. Some food industry use these aura concentrates deliberately because during the pre-cleaning of goods, for example, potato chips or tomato production, so the raw material comes, they need salty water to clean it. So they deliberately add salt to produce that salty water. We say, you already have the salty water from the brackish water aura, please use this one. So there are very interesting things. You should, enter the plant and find these problems. And then we told the ministry, look, we have about 1,000, where is it written? I can't read it. We have about 1,600 industrial plants in Turkey just using BWRO. And we did a calculation, and right now we are losing about 240,000 cubic meter per day of aura concentrates just for brackish aura. No seawater, no municipal, no drinking water, just industry. We are losing this amount. And this makes a water demand of a city of about 1.2 million people. Right now, the ministries are pushing industries, please go and check your BWRO. If you don't have a virus problem, no microbial problem, please consider reusing them. This is another book that we did for the management of concentrates in Turkey. This is a technical guide. This is published, and Turkish industry is using these guides right now, but it's only in Turkish. Okay, the last one, these are all industry, little bit, couple slides from academia. So the problem is, okay, you went to a factory, a big industry, you provide them solutions for water and energy efficiency. Let's say you say 20 recommendations. Which one is good? Which one is good in terms of what? Capital cost, O&M cost, a lot of different criteria. So the problem is, the boss will say, please prioritize them for me. It's difficult to prioritize. It depends on which aspect you look. So we employ decision models from industrial engineering, and my PhD students are working on this. So we published a couple of papers. For example, Prometi is a decision model. It's used a lot in industrial engineering, but not in water. So we should employ these methods also in environmental engineering. Another one, which one is best? It depends on the process, basically. So you should do it. So there are a lot of different techniques to employ them. All right, I'd like to acknowledge the Turkish Minister of Environment, Urbanization and Climate Change, TÜBİTAK, Turkish Minister of Agriculture and Forestry, and also European Union IPO program for all the funds. Thanks a lot.
Thank you, Professor Mehmet. Thank you very much indeed.
Thanks.
Ladies and gentlemen, we can relax. That brings us to the end of today's conference. Thank you very much to the case study speakers, to the keynote speakers, to the panelists, and to the MOU signatories today. It's been a busy day, but we look forward to seeing you tomorrow. Bukra inshallah, الساعة 8 في الصباح. And have a nice evening. See you tomorrow. Shukran. Assalamu.